I can't hear you. Hi. Can you hear me? Okay. All right. Hello everyone. I hope you can hear me. I'm uh, I'm Chirag. Hey, can you can you hear me now? Sure. Can you hear me now?
No, see, it is the problem is at the seminar hall. It is audible online. Okay. Is it okay? Am I audible, Monte? Hello.
I can hear you, Pranav, but I think they
No,
can't.
no. I'm talking to the
Is it audible
team
now?
there in the seminar hall.
Hello?
Yeah, yeah. You are audible, but not this. My voice is audible that side or not? Mantai.
Hello? Hello?
Yeah. Am I audible, Sitaji?
It was working, right?
Can you hear me?
Hello? 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 Hello, Mr. Chirag?
Am I audible now? Can you hear me?
Yes, I can hear you.
Okay. I think now Chirag can be invited, right? Chirag, are you
Can
there?
you yeah, can
Yeah,
you
yeah.
hear me?
I think yes, yes. You're audible now.
I think I can't hear you though, like the presenter on the stage. I can't hear
Presenter,
you.
presenter, please speak.
Hello, sir.
Yeah, I can hear you now.
Okay, sir. Sir, could you turn on your camera? Very sorry for the technical issue. So you can continue now, sir.
All right. Um, so um, hi. I hope you can hear me now. I'm Chirag Agrawal. Um, I'm a senior software engineer at Amazon. Today, I'm going to talk to you about building AI agents for real production use cases. We'll cover core concepts of agent design and implementation, and see how they fit together into a practical framework for building agents that can run reliably. I hope you're having a great time at this conference. I'm excited to dive in. So, first, a little bit about me. Um, I'm one of the lead engineers behind Alexa's Brain, basically the part that make Alexa useful and intelligent assistant. My job is to make sure Alexa can do three things at a massive scale. One is to pick the right action to help you with your request. Second one is to remember what you just said to keep the conversation natural and smooth. And then the third one is to do everything extremely fast. I work on conversational AI platform that internal teams and external partners plug into. So instead of building everything from scratch, they just add new capability to Alexa's Brain. So this is our roadmap for today. We'll start with in context learning, and then each topic will build on the previous one. By the end, we'll have a practical framework for building AI agents that can run reliably. And uh, at the very end, we will have time for questions as well. Okay, so with that, let's dive in. I want to start with this example. On the screen, you have a prompt. It starts with the word cat, followed by an arrow, and then the word tack. On the second line, you have the word rice, followed by an arrow, and then uh, the letters ECIR. And on the third line, we have the word smart, followed by an arrow, and then a blank. So if you copy paste this prompt into any AI chat interface, you will get a completion that says crams. Uh, and if you notice, the words on the right are just the words on the left, but reversed. But the interesting part about this example is that we never told the AI model to reverse these words. We only gave it two examples and a new word. The model recognized the pattern from the examples and applied it to new data. This property is called in context learning. Basically, the model's ability to learn from examples in the prompt and generalize it to new input. Um, this ability is at the very heart of AI agents. So before GPTs came along, achieving something like this with a machine learning model would have taken substantial resources and expertise. But with modern GPTs, that is not the case. These models are massive neural networks that that are trained on internet scale data, and they exhibit emergent uh, properties like in context learning, meaning that these models can learn a completely new task with zero training. You just need to tell them what to do, and sometimes you have to show them one or two examples, but with that, they can accomplish the goal. And this means that these neural networks can be programmed in real time. Uh, and that has huge implications for technology industry. So, um, in context learning or ICL brings us to a very interesting analogy, which is that LLMs should be seen as a new kind of computer. LLMs come with a lot of knowledge prepackaged and compressed in its model weights. We program it by writing instructions in natural language. That's the prompt. And we can load external state into it through context window, just like putting data into the RAM. Once you think of large language models this way, you can argue that uh, if we build a scaffolding around these models, we can harness their intelligence to make decisions, to execute workflows, and manipulate external data. So that is the very foundation of AI agents, and that's what we are going to use for designing our agents. Um, Let's talk about how agents interact with external state, basically the data that live outside model weights. And to make this concrete, we are going to take an example of planning a picnic. So let's say there is an AI agent or an AI assistant, and the user says that I want to plan a picnic for tomorrow in Central Park. Can you help me? Um, from this one sentence, the agent can extract some clear inputs, basically the location of the picnic and the time of the picnic. It might also ask some follow up questions to the user about food preferences and activities and so on. Those are all direct user inputs. And there is a crucial piece of information that the user didn't give us, and and the agent shouldn't keep asking the user for it every time, and that is the weather. So a good agent should realize that I can't plan a realistic picnic without checking the weather for that time and place. So at some point in its reasoning cycle, the agent decides that it needs external data. So before we move forward with this example, I think it's very important to understand the structure of the prompt of an agent. Uh, Basically, that will give us an idea of uh, what an agent is made of, and uh, it would be easier to understand the the slides that follows. So here you can see that we have the structure of the prompt in this blue box. And at the top, we have system instructions. These generally include any high level horizontal behavioral instructions for the model. For example, how to use a tool, or how to generate a response for a human, or how to utilize contextual information present in the prompt. Then we have a bunch of tool definitions below the system instructions. Below that, we have contextual information. That is basically stuff like the current time, the history of the conversation so far. It could be other domain specific data like device state or something else. Just really depends. And and then at the bottom we have the user request. Um, so for our example, the prompt would look something like this that you see on the screen. We have three tools. One is to get the weather, another one is to convert units, and the third one is to get latitude and longitude for a place. And in the context information, we have the city name and the current date. Um, and then we have the user request, which is to plan a picnic. Uh, so, uh, what is a tool? When we say a tool, what really it is? The agent obviously cannot magically know the weather right when it needs to plan a picnic. So this is why we give it access to tools. A tool is essentially a function that the agent can call, and it looks something like this that you see on the screen. So this is how it would appear in the prompt as well. In most cases, it has a name, it has parameters. Each parameter has a type. It has return, a body, and then a description of what the tool does in natural language. So the agent reasons over the user request and the tools that it has been given access to, and it decides that to plan a picnic, I should call the get weather tool. And it produces this tool call that you see on the screen. So this pattern of like reasoning over context information and tools present in the prompt and acting on that is what we call the React framework, and stands for reason and act. The LLM reasons over the context and takes actions. So when the model produces a tool call request like you see here, the framework around the model uh, will intercept this tool call and turn it into a real API call, and then invoke the API. So once the API is invoked, you will get a response from the server. And in this case, the response would be the actual weather forecast for Central Park on the date. Uh, this API response is then added back to the uh, agent's prompt or its context alongside the original request, which was to plan the picnic. And this is done by the framework that surrounds the model. So now the agent has the user input, which was, help me plan a picnic in Central Park tomorrow. And now it has also acquired this external state, which is the weather forecast for the date and place of the picnic. So the the React loop will run another inference and the model will reason again. This time it doesn't need more tools, so it can generate a concrete like itinerary for the picnic. And what itinerary the agent generates really depends on what the forecast was. So if the forecast was good, then the agent will generate the picnic itinerary. But if the forecast was bad, the agent might, suggest a different date or place for the picnic. So if we zoom out of that example and see what's really happening here, we'll notice that the agent is continuously running in a loop in three stages. What first one is perceive stage, second one is reasoning stage, and the third one is act. Uh, and the agent only exits this loop when a terminating condition is satisfied. Typically, that is when the agent produces a response for the human in the loop. So let's map it to the example we just saw. The agent perceived the current situation by reading everything in its context, and it received this user request. So the user request was a net new information that was sent to the agent, and that's what kickstarted this cycle. So the agent moved to the next step, which was the reasoning, and here it inferred that the user wants to plan a picnic, and the agent is missing a critical piece of information, that is the weather. Uh, and it thinks that to answer this question well, I will need the weather information, and I have a get weather tool in my prompt, so I'm going to invoke it. Uh, so the model decides to use the get weather tool, and that decision is basically an act. The surrounding framework executes the tool call, gets the real forecast, and feeds it back into the context. So once you get the weather from the external server, uh, that is net new information that is perceived by the agent. So so the agent enters the this agentic loop again, starts with perceive, and it has new information in addition to the user request. So it, as the next step, it will reason over all that information, and it will decide that, okay, now that I have the weather information and the date and the time of the picnic, I can go ahead and create the itinerary. So this decision to go ahead and create the itinerary is also an action. Uh, the difference is that in the previous action, there was a tool call involved. In this action, there is a natural language generation involved, but they are both effectively actions taken by the agent. And since uh, generating a natural language response is intended for the human in the loop, the agent will exit the loop because it has answered the user's request. So this is effectively what the agentic loop is. Um, it perceives user input and current context. It reasons and decides what to do next, and then it acts in the form of tools or response to the human. Uh, if the if the action is a tool call and the new data comes back into the context, then the loop will repeat. And if the action is a final answer to the human, then the loop will terminate and the interaction is done. So this this perceive, reason, act loop combined with in context learning and access to the right set of tools and external state is what turns a large language model into an agent that can operate in the real world and interact with real systems. Um, so now that we have seen how an agent works and what it is truly made of, uh, we can dive into the next topic on the agenda, which is the multi-agent systems. So, multi-agent systems, or multi-agent in simplest words, means multiple agents collaborating together to achieve a goal. And there are many different orchestration patterns for multi-agent systems, but the most canonical one is where agents are arranged in a hierarchy, where the top agent is the user assistant. Uh, the core idea of multi-agent system is that agents can use other agents just like they use tools, like we saw in the example earlier. The agentic loop that we just saw is still the foundation, but the only difference is that now agents are composed not just with tools but also with other agents that it can call. So let's look at a concrete example to understand it better. Here we have an assistant agent who, so this is our top level agent that talks to the user and the user talks to it. And this agent has access to two other sub agents. One is the weather agent, just like we saw earlier, and the second one is device agent. So the weather agent can tell you about the weather. The device agent can control devices in your home, and each of these agents have access to their own set of tools. So let's look at an example. If the user says, uh, turn on my sprinklers tomorrow morning if it doesn't rain today, the assistant agent will start its agentic loop, uh, beginning with the step perceive. The agent will reason that it first needs to check with the weather agent to confirm if it's going to rain later today. And it will act on that decision by producing a tool call to invoke the weather agent with a natural language query. And the query could be very simple, like, will it rain today? So when this call is invoked on weather agent, the weather agent will start its own agentic loop to produce the answer for assistant agent. It would reason over all the information and tools it has, and it will decide that it needs to fetch the weather using get weather tool. It will receive that information from the API and produce the natural language response. This response is added to the assistant agent's prompt by the agentic loop. So now the assistant agent knows that it is not going to rain later today. Uh, so it will do another round of inferencing, or rather reasoning, and this time it will decide to invoke device agent to schedule the sprinkler to run tomorrow morning. It will act on that decision by producing this tool call, and then device agent will do basically the same thing that the weather agent does, which is to run its own agentic loop. It will see that it has been asked to schedule the sprinkler to run, so it will call the schedule action tool that it has access to. It will get back the response from the server, produce a confirmation, and then send it back to the assistant agent. So once the assistant agent receives a response from device agent, uh, the external state has been modified, and in combination with user requests, based on all that information, it will decide that it is now ready to produce a final response for the human. So it will do third round of inferencing, and it will produce the confirmation for the user that the sprinkler has been scheduled because it's not going to rain later today. So this is essentially a multi-agent workflow. And you can see that it is built on the same foundation as a single agent workflow. Um, just the difference is like how the agent is composed. And although this example is relatively very simple, multi-agent systems promise a very powerful paradigm where hundreds or even thousands of agents can collaborate to complete a task, which is far more complex than turning on a sprinkler. So protocols like A2A and MCP are taking us exactly towards this future. Okay, so let's look at uh, LLM token cost management as the next topic in this talk. Uh, so far, we have talked about how agent can acquire information, how it can manipulate information um, outside. But these agents cannot run sustainably unless they have a predictable cost, and more importantly, they have clear cost levers that can be pulled when the spend exceeds the budget. So this is really where we start getting into like what truly matters in production scenarios, uh, and what it takes to like actually launch an agent that is used by millions of people. So the problem should be obvious if you have used LLMs before. LLMs are powerful, but they are very expensive if you run them at scale. And primarily, the the expenditure on LLMs is metered by token spend. So the number of tokens that goes in as input and the number of tokens that are produced as output is how you get billed to use an LLM. So this is what you need to monitor unless you want it to become a budget killer. Uh, uh, and a simple example is that a 2000 token call uh, can cost less than a penny uh, for a demo. But like if you scale that to millions of users, then the cost can run into thousands of dollars per day. Um, and there are basically these five cost levers uh, uh, for LLM spend. First one is the overly long prompt. Uh, so as I mentioned earlier, one of the ways you optimize. I'm sorry, one second. I got distracted by something on my screen. Sorry. So these are the five cost levers for LLMs. Long prompts effectively means a high number of input tokens, and context window refers to the amount of information you are adding uh, to the prompt as part of your agentic loop. The third one is what kind of model you're using. So one of the common mistakes is that people use very giant models for very simple tasks, and big models cost a lot of money because they have higher cost per token. Fourth one is that teams don't monitor their token expenditure, and the fifth one is that they don't utilize techniques like prompt caching, which are very useful when you're trying to reduce uh, your token consumption. We'll talk about the prompt caching very soon. It's an interesting topic. Uh, yeah, so from that we can infer that there are these four heavy hitters when it comes to like optimizing LLMs: prompt efficiency, context management, prompt caching, and selecting the right model and routing to it. Uh, uh, and we'll talk about that one too. Uh, so. Um Prompt efficiency basically refers to the exercise that teams have to do to continuously make the prompt more concise. uh, so usually in production cases what happens is that teams start with a prompt, but they as the product matures they keep adding new stuff to the prompt, and what ends up is you end up with a lot of uh, uh, bloat in your prompt, which is not actually required by the model. So actively making your prompt more concise is uh, is a very necessary exercise to keep the prompt more efficient. Uh, You can also engineer a few ways to keep the prompt small. One of the ways to do that is to implement some sort of a semantic retrieval over contextual data. So uh, that would help you reduce down the number of tokens that you add to the prompt uh, uh, when running the agentic loop. Uh, the third and a very interesting way to control prompt size is to standardize the prompt template across teams. Uh, this is useful only when you are operating in an organization where several teams are using uh, your framework or your AI agent. Uh, Standardizing the prompt template effectively creates a very powerful, lever within your framework, because you can optimize template once, and then the gains of that optimization are distributed across teams instantly. uh, yeah, so like, bottom line is that prompt efficiencies, like reducing unnecessary token that can add up when you like do agent development at scale. um, So here, when we say context management, what I'm really talking about is the conversation history that is generated as the user talks to AI and goes back and forth. So the examples that we just saw, they were single turn based, meaning that uh, user would say something to the agent. The agent will invoke a bunch of tools, and it will produce a response for the user. uh, but like in real scenarios, the interaction between a human and an AI is very complex. It can go several turns back and forth, and whenever you complete one turn, typically the agents add the information from that turn into the context. Uh, Managing that context information effectively is a very important uh, topic, and there is a whole section dedicated to it later on. So I'll cover it in more detail soon. Uh, Prompt caching is an LLM optimization technique to cache key value matrices for subsequent inference turns. So the KV matrix is a component of the attention layer, and each value in the matrix is dependent only on the prompt tokens before it. So for the portion of the prompt in which there is no change, reusing this element of KV matrix reduces the attention layer calculations, which effectively reduces the GPU resources that you're going to consume, and hence it reduces the cost of of your inference. And there are two types of caching. One is implicit, which is done on the server side by the model provider, and the other one is explicit, where you explicitly tell the LLM to cache parts of the prompt. Uh, they are both very effective, and I think a common pattern in both types of caching is that the static parts of the prompt should be kept at the very top of the prompt, and the most dynamic part of the prompt should be kept at the very bottom of the prompt. So anything that is related to system level, which doesn't change between users, uh, that should go at the top, and things which are user or request scoped should go at the bottom of the prompt. So this essentially ensures that the prompt cache will be utilized to its fullest extent by the server. Um, and uh, the fourth one is model selection and routing. And in my opinion, this is like one of the best ways to reduce LLM cost at scale. Uh, so here, a typical pattern that teams use is they they put in a ML request classifier in the system. So when a request comes, it is first given to a request classifier, and the classifier decides whether the request is simple or is it complex. And if the request is simple, it is directed to a smaller model. And if the request is complex, then it is given to a larger model. Uh, and this reduces the inference cost significantly, because in a lot of cases, the user requests are indeed very simple and it doesn't require a 500 billion parameter model. So model selection and routing is a huge win when it comes to cost control. Um, so this is the context management and multi-turn conversations. Uh, and as I mentioned earlier, like the examples we saw were single turn, where the user said something and the agent said something back, and that was it. But the real interactions with AI are very complex and involves a lot of back and forth. That brings up interesting challenges that I want to go over with you quickly. Uh, so, context is basically a running memory of everything that has happened. Like I said before, it's the conversation history of what you said to the agent, what the agent did, and what said to you. And every time you interact with the agent, it adds new data to its prompt. Uh, and if the context is left unchecked, it can result in basically these three high level issues. One is obviously the high token cost, because you are adding thousands of new tokens per interaction to the prompt. Second one is bias towards only some of the data that is uh, that appears towards the end of the prompt, and this phenomena is like popularly known as lost in the middle. So basically, what happens is uh, LLMs have this behavior that they only pay attention to uh, tokens that appear either at the very top of the prompt or at the very bottom of the prompt, and they kind of gloss over the things that are in the middle. And uh, a a context that is building up over time kind of worsens uh, that that situation. And the third one is degraded instruction following capability, because the agent is overloaded with lots of information that it doesn't need. Um, so broadly, there are like these three types of techniques to manage the problem of context, and we will cover each one in detail. The first one is a rule-based context pruning, which simply drops older turns from the context. For example, an agent could retain only five latest turns in its context and drop all turns that are older. So this is very easy to implement. You can have a simple logic in your prompt construction, which basically keeps dropping turns as they get older and only keep the recent five things that the user said to the agent.
Hello, sir. Sir, really sorry, we are actually short of time. Could you
Okay.
please call in 2 minutes if possible? Okay, sir.
Sure. Yeah. I think we are very close to finishing. This is probably the third last slide. Uh, okay, so this is the rule-based approach. The other one is the AI agent-based approach, where the agent summarizes the context instead of you deterministically dropping older terms. And this is very effective at reducing number of input tokens. And the third one is the hybrid approach, where we combine the best of both worlds. So, in this approach, the agent retains a few turns in their uncompressed form and replace the older ones with the compressed history. Um, so, uh, that was the end of the talk. Sorry, I had to rush it a little bit towards the end, but these are like the six key takeaways from this session. LLMs should be seen as new kind of computer. Prompts are basically programs. In context learning is how agents generalize over new data. Reason and act. Reason and act is how like LLMs work with real life tools. Agentic loop powers real products, and context management should be handled more intentionally. If you have time for questions, I'm happy to take one. But if not, it was nice talking to you.
Thank you so much, sir. Now we uh, now we take this moment to felicitate our esteemed guest speaker with a token of appreciation. We are honored to present an e-certificate of appreciation as a gesture of gratitude for sharing valuable insights with us today. Thank you so much, sir, for taking out your valuable time. Thank you, sir. Sir, Chirag, sir, excuse me, if you're there.
Yeah, I'm still here.
Sir wanted to ask a question. She does.
Yeah, let me present the virtual memento, CIT presenter. Let me present the virtual memento to Chirag ji. If someone is there, please allow me to present. Stop presenting, please. Yeah, stop presenting, please. CIT. CIT, please stop presenting. Yeah. Stop presenting, please. I am presenting the.
Not it's from.
Just here.
It's okay. Question. Okay, but next speaker.
Okay, sir. Thank you so much, sir. Thank you. Thank you, sir.
Thank you.
Any round of applause, sir. Thanks. Moving ahead, uh, now we have keynote talk 2 by Professor Dr. G. Kullantheval from NITTR Chennai. Professor G. Kullantheval is a senior professor at NITTR Chennai in the Department of Electronics and Communication Engineering and also serves as the Dean of the Institute's Center for International Affairs. He earned his PhD in Information and Communication Engineering from Anna University, Chennai. His master's in microwave and optical engineering from Madurai Kamaraj University and his bachelor's in electronics and communication from University of Madras. Professor Kullantheval's expertise spans a broad range of fields including biomedical, electronics and telemedicine, communication and networking systems, virtual and instrumentation, MIT LabVIEW, ICT in education or training, and technical and vocational education and training. Now, I would like to invite Sir on the stage to share his valuable insights. Everyone, please give a huge round of applause.
Yes.
So now I would like to request our felicitation team to kindly come forward and felicitate our esteemed guest speaker with a memento of honor as a symbol of respect and gratitude. Everyone? So, please. So please.
So good morning to all. First of all, I wish to congratulate the Department of Computer Science and Engineering, CITK Assam, for organizing such a wonderful third International Intelligent Computing and Technologies Conference from December 2nd to 3rd, 2025. And all the organizing team, especially we have from CITK IIT Goa, and I'm happy to see that we have from NIT Sikkim and University of Technology Sydney, Australia, University of Barcelona, Spain. Jetlas is also there. And we are missing Professor Devendra Jalihal, Director Additional in charge, CIT Gugraj also. We have to thank him also. And I personally wish to thank two coordinators, especially Dr. Pankaj Pratap Singh, CIT Gugraja, Dr. Sitalal Prasad from IIT Goa for inviting me for this conference. Also to Professor Amitabh Nag, Registrar of CIT Gugraja also. So first, then I wish to congratulate all the participants also. Really, I'm happy to see students are coming, faculty members are coming, and all many are from US also is there. Different participants from different parts of the world are attending this program. I'm really happy to deliver the talk on towards a super smart future, integrating industrial revolution 5.0 in society 5.0. So when we heard the keynote address from different resource persons yesterday and also from USA, we are really happy that we can see what are the developments going on. And I'm sure during the oral presentation also you might have seen different technologies, you might have learned that. But next maybe, I don't know how much time is there, at least 30 minutes at least I'll try to do. Yeah, I planned a long time, but anyway, we were running short of time. So I'll try to quickly cover the topics what I wanted to do. As you know, olden days, we are all depending for the internet speed. It was, I still remember 1995, August 15, internet was given to the public. As you know, NITTR Chennai, we train the teachers of engineering colleges and polytechnic colleges from 1964. We are doing the training. I joined in this institution in 1996. So 95 when I started this, I started demonstrating to the teachers of engineering colleges, polytechnics, how the internet technology works. So the speed was only 56 kbps. Then slowly I remember like technology changed to ISDN, we call Integrated Service Digital Network, which started like 64 kbps. We multiplied by 2, like 128 kbps, 256 kbps, 512 kbps, 1024 kbps, it was 1 Mbps. it was really great thing because when it was 56 kbps, we had lot of buffering. But when I was going for like 1 Mbps, 2 Mbps, it was really good. I still remember maybe 2003 or 4, I attended a telemedicine conference where I could see a doctor demonstrating uh, an operation which was held from one country and another doctor from US or other country, I forgot. So he was giving an expert opinion. So based on that, what I did, I approached Ministry of Human Resource Development and we got some project and we set up like video conferencing So usually those days NAWR were called as TTTA. North it is in Chandigarh, East it is in Kolkata, West it is Bhopal, South it is in Chennai. So the teachers from Andhra Pradesh, Karnataka, Kerala, Tamil Nadu used to come to our institutions, stay for 1 week or 2 weeks. Even I remember the actually pedagogy courses we did 16 weeks of 8 weeks people used to come. So I thought why should their participants should come this much distance. Then we established a video conference center in our excellence center like Bangalore, Hyderabad, Cochin, and Chennai. So the teachers used to go to the capital and they really enjoyed. They told me, sir, we are able to save a lot of time and so people were having very good connectivity. But now I'm sure every one of us is having this type of mobile with us. So where all public or teachers or students are having a mobile phone with them, which is really going to help them a lot. Nobody expected. Say, especially you talk to senior people. We had ordinary telephone line. Then a concept called pager came. Okay, maybe you may not know that. The connection is there or disconnect? Okay.
So can you present again?
Okay, pager is a device which really it was helpful for the people because what happened, like service engineers used to come to repair, for example, computer. They used to travel for more than 50 kilometers, do some installation or service, and they again go back to the college, the company. Immediately, the company will tell next to NAWR, there is an organization called CSCR. You go and they got a complaint from there, you have to go there. So the same person should travel more than 30 kilometers. So, but when the pager came, the student, the company person was having, there was just like our SMS he will receive. After completing NAWR service, go to CSCR campus. So that person immediately went after completing our work. That saved a lot. Not only his travel, but pollution or traffic, everything was good. So we travel like that from ordinary telephone to pager, then mobile phone, which was with bigger size. Even for incoming, we paid. Then everybody's got the small phone, like Nokia phone, ordinary button phone. Now we are all having this phone. So why I'm telling? So especially we call now Gen Z. You are all Gen Z learners. Okay. You are all really lucky to have the system with you, and you have whether it's a swim or any other. You can take like online university, any of the things, whether it is edX, Coursera, Khan Academy, many other in front of you, and you have many simulations also online. I try to show like Tinkercad, for example, which is really going to help you to do any type of experiments, especially in the area of electronics or Arduino projects. Or similarly, you have MATLAB software as company who are doing a lot of, I observe, image processing you are doing. So those days we started, I still remember 1995 was in IIT Madras. So I was using MS-DOS based, okay, the MATLAB. That was really difficult. But now the latest version, you have everything related to Industry 4.0, 5.0, including the deep learning concept, whatever you want, within fraction of a second. I still remember, I have to stay inside IIT for more than 36 hours to run something like aggregation deformity. We did some blood related experiments that I researched about. But now the same thing can be done with the help of maybe 1 or 2 hours because the processing speed increased. Yes. So you are in that age because whatever we started, okay, it was like a industry 3.0 maybe, and it is 17, 90, 80 like that we started. But now we are all in the industry 4.0, 5.0 era. So what I want to say is just to show you what is happening. So this also everybody should know because we are all you because from 2000 to 2015 we were there in MDG, we call Millennium Development Goals. But from 2015 to 2030 we are in SDG goals, Sustainable Development Goals. I'm sure if you are going for NBA, especially from January 2025, you have to show in your curriculum how you are achieving each goal, especially for the faculty members. Please try to follow. And I always say this. So, goal number 4 is quality education. The teacher should start giving very good quality education so that the student will get a skill. In turn, he is going to get a good job so that we will be achieving goal number 1, no poverty. Goal number 2, no, okay, no hunger, then good health. So it is the duty of all the faculty members to do this. And students, I feel because I was talking to some of you, start learning some value-added courses. Don't depend only on the course curriculum, whatever is having. Because as you know now, we have seen like AI agent, all these things are going to replace a lot of jobs. So we should be ready for this. So with this note, I want to start my talk, especially NEP you are going to follow this, where people started telling many technologies. So what I want to say is we started like this. Okay, before 2006, many of us were not aware of this, or it started coming only like this. There is iPhone, we don't know all these things. iPad, Kindle, 4G, Uber, Airbnb, Android, Oculus, Instagram, Snapchat, WhatsApp. So all of this you know. But we started hearing one by one, we learned all these things. So this is how the world was there. Okay. Even if you see, the internet really helped us, and especially this industry 4.0, 5.0 is going to help us to do a lot of research. If you see this, total population was only around 7.3 billion in 2015. But in 2050, they are expecting to be 9.6 billion, which is 32% increase. And if you see the population was 65, so it was around 600 million in 2015. We expect it to be 1.5 billion. That is increase in 105 billion. So the technology, whatever we are discussing, whether it's related to smart hospital, or whether it's a smart manufacturing, or smart cities, okay, whatever you say now, it started coming like smart. That is because of this industry 4.0, 5.0, which is really going to help the senior people. For example, so all these days I have to go to a center like a hospital or ECG center to take an ECG. But now it is possible for me to take my ECG just by keeping my finger like this for 30 seconds, like Apple watches. Okay, they brought watches. So I have to just keep this my finger like this for 30 seconds. my ECG will be generated. It will be going to a remote doctor who may be in US, UK, or my Chennai or wherever they is there. He'll be able to tell, okay, GK, you have this problem. I'm sure you know Abdul Kalam was talking like this, he fell down. But assume this type of devices were there, his team might have checked that. Always, just half an hour once, 1 hour once, they check, they'll be able to know the heart condition. So simple thing I'm telling, or continuous glucose monitoring. So I have to go to the hospital, give my blood. That was the day. But now at least we are able to do acute check. The companies are giving a small stick. I have to prick like this and check my blood sugar. But now you started getting something like a small sensor we call CGM, continuous glucose monitoring, where I'm going to keep my, just I'll be talking like this, but my 15 days sugar level will be monitored by the diabetic centers. So like how when I was sleeping, how it was there. Morning I took breakfast with coffee, with sugar, how it changes. While sleeping, how it will be. So all these things will be monitored by the people. So we should be ready for this. See, we are going to do a lot of things for the society. Whatever we are going to read and do, your research is going to help us. We are all talking about all the technology, but ultimately it is going to help us only. I'll try to discuss about autonomous car also, because all these days whenever I call Ola, okay, a driver comes. I hope Ola, Uber, Rapido you may be having. So when I call, the car comes in front of my house or wherever I am there, and it takes me to the location. The driver drives. But already started that autonomous cars have started coming, where I am going to book a Ola car means a car will come in front of my house without a driver. So whenever the vehicle goes, so what I drive, whenever I drive, what is happening? I am just going, seeing a like a traffic signal from yellow to red it is going to come. So what I do, I reduce my acceleration and apply the brake. This is what I do. But here you are going to have a lot of sensors. So these sensors are going to pick up the signal, and the sensors are going to send the signal to a cloud computer. Cloud computing is nothing special. You are going to see whatever is there like a remote computer, which is server we call, which is going to work switch on for 24 hours. So just like your Gmail server. So whenever you are accessing, you are getting your Gmail. Similarly, whenever I want, that is the whenever I go in the car, my sensors are automatically going to pick the signal. It is going to send the signal to a cloud server. It is going to give command, just like my brain. So my eyes are seeing, and immediately my brain is signals going. Brain is going to give a command to my leg. Okay, reduce acceleration, apply brake. So this is everything is happening automatically in my our human body. Similarly, the sensors are going to send the signal to cloud computer, which is going to do AML or deep learning. The processing is going to do, and it is going to take a decision and give a command. We call actuators, the devices which are there in our car now. Like it is going to give the actuator like accelerator or reduce brake, apply brake. Okay, this is going to be circle. So like this, somebody is going to overtake the car. Yes, signal processing, image processing, video processing. So all these things are happening without our knowledge. So we should be ready for these things, but ultimately it is going to help our society. All these things is because of internet or the technology, what we get 3G, 4G, 5G. Already people are doing a lot of applications, especially 5G. Okay, 6G also they started. So this is how the industry 1.0, 2.0, 3.0, 4.0, 5.0 developed. So anyway, you can go through that. But what I want to say is, see, 1780, 1900, 1000, okay, 1009, those days, 900, 1970, 2000, 2020. Just see the difference. So those days industry 1.0 to 2.0 took 120 years. Then 2.0 to 3.0, 70 years. 3.0 to 4.0, it took 30 years. But 4.0 to 5.0, now we are 20 years. So as the technology develop, many changes are happening. So we should be ready for this. Okay, this is what you have to think. How the technology is, and we should be ready for this thing. This is possible. Okay, especially now the industry 5.0 is going to change, especially like mass customizations. Okay, cyber physical systems, we call cyber physical cognitive systems, sustainable systems, human centric systems, resilient systems. So many changes are going to happen. So where the things, whatever is going to happen is already autonomous, automatically it is happening. Or we have everything is we have smart manufacturing, you know, because industry 4.0 you have all these things, whether it's autonomous robots or big data, augmented reality, additive manufacturing, cloud computing, cyber security, internet of things, system integration, simulations. So yesterday we could have a morning session, we could get a lot of ideas about digital twin, how the simulation is happening, or like AR, VR, XR, MR, metaverse. We could see how virtual reality is going to change the way we learn also. Okay, this is going to really change us by new technologies. So what I want to everybody try to go through this different layers of technology. You try to create the value added skills. Okay, 3D printing is one area. Try to learn how the 3D printing, how you can do. Because now it is possible for us to even do any type of design. See, for example, if I want to have this design this bottle, I am going to just keep like this. There will be a scanner which is going to scan it, and using the printer, different materials are there. Okay, if I want this type of material, keep the material, I'll be able to manufacture or produce whatever device you want. I want something like a bolt net. Yes, it is possible. Only you are going to change the material, and different types of printers are there. So you can go for like metal printers, like they cost 2.5 lakhs crores. So, but it is possible to make it any nuts or whatever you want with the metal is possible. So it is not necessary to make a like a mold. Okay, what one item if you want, it is can do. But this type of bottle I have to do means I have to design, I have to create a mold. We have to spend a lot of money. Bulk when you want to go, it is that is better. If you want to go few numbers, it is you can go for 3D printing technologies. So which is really going to help you. So maybe just I don't know if so is a simple level I can show you 1 minute. Anyway, I assume that most of you are aware, especially for youngsters.
Due to the advancement of 5G technologies, we are in the midst of the revolution, especially the way we produce products and run manufacturing operation. Organizations are facing challenges to adapt themselves in order to survive. IR 1.0 and IR 2.0 emphasize on mass production, while IR 3.0 further enhance the approach through automation. In order to react faster according to customer need, IR 4.0 emphasize IoT, which enable real-time monitoring for better decision-making.
What is Industrial Revolution 4.0 and why it is important to us?
Industrial Revolution 4.0 involves large-scale machine-to-machine communication. Internet of Things such as sensors, digital monitoring meter are integrated with systems to achieve higher automation, better communication, and auto monitoring. This produces a smart machine that can analyze and diagnose problems by itself with no manual intervention is required. The key components of IR 4.0 include cloud computing, big data analytics, Internet of Things, artificial intelligence, autonomous robot, cyber security, and system integration. Industry 4.0 emphasized on digital transformation. It has increased the value of supply chains by introducing flexibility, adaptability, and efficiency. Industry 4.0 represents the next wave of technology driving efficiency across operations. Failing to adopt
so
4.0 technology will cause.
so most of the industries also they wanted to have like this because they want what they feel, if we have this type of technology, they can reduce the what is it like recurring cost. One time they have robot, like robots are most of like I visited Hyundai factory. So we use most of the robots only because they want to replace. Otherwise, if I am going to work, I need like refreshment time, lunch time, or I need rest time for night time. But that is going to work for 24 hours. Maybe 2 months, 2 weeks once, or 1 month once they have to do the regular service maintenance only because most of the industries going for that. So why I am worried is all these things are replaced means our future generation people will not get a job because I told you autonomous cars are going to come. So no need of drivers. So what will happen? So where I want people to learn the technology, how to do the service like this. For example, you have the driver should try to learn how the sensors are there, how these cameras are fitted, how GPS or whatever the automobile engineers are having idea, they have to have interdisciplinary. Don't think sir autonomous car is only related to mechanical. computer science or IT, no work. No, whatever you are going to do, all this AI, ML is going to come. Or if some electronics people or instrumentation is there, they are going to deal with sensors. Or that communication people are there, it is going to have a lot of communication. So it is called interdisciplinary. Like civil people say, sir, why should I learn all these things? Future we are going to see smart cities. If you take a light, electrical light, it is not necessary that I have to switch on, switch off. You are going to have something like a moisture sensor. Okay, moisture is different. You can have light sensors. Based on the light condition, it is going to on off. For example, I think, meantime, because I don't know, whatever possible, at least I'll try to show you. You have like Tinkercad, there's a software, at least in case you are not using this, please try to use this. So just click Tinkercad. Okay, in case you are not using, I want all the electronics teachers to start using, everybody. Because this happened during a COVID, what I observed is I asked one student to, for project like that, people brought in, that person came. The student, when I asked what is CRO, he was not aware. But unfortunately, when I asked what is camera, is just press, no, press 29. So what is going to happen is people should start using this. One example I'm telling. This is MATLAB, LabVIEW, many software for all the departments you have. But why I'm telling is, in case the students were aware how to do this. For example, I want to show this related to IoT. So people are doing related to IoT with all these hardwares. But I want the teachers should start using this for teaching them a simple thing. For example, assume everything I can bring. I want a Arduino means by sitting from here, it is possible for me to drag and drop like this. Okay. Or if I want to do some of the basic electronics experiments, yes, ask them. It is like breadboard. Okay. Whatever you want, you can try to ask this. It is possible for you to get it. Okay. Breadboard, take it. So like this, you are going to connect everything. Whatever sensors you want to do related to IoT, do this. So once you complete, you connect this, click start simulation. So if I want to have something like a fire, something I want to show a demo, people have to do matchbox. So these things are risky. But what I can do is just by touching like this, it is possible for me to bring like this. So it is going to give Allah. Okay. So there will be a sensor which is going to take care of these things. Okay, what I want, every teacher should start teaching like this, whether it's a basic electronics like that, because the student whom I met, he was not aware of what is CRO. Really, I was worried. Then when I asked, he told, sir, I am from COVID batch. He told, they have not taught me what is CRO. We didn't have the time to do this. So finally, the students, really, I was surprised to know that. So he worked, anyway, I have taken, because I was taking care of, I was Dean International Affairs. So I used him for other Google form, all those things. He was happy with that. Then he has gone for like a multimedia, something related. He has changed. So the career sets are changing. That is why I always say faculty should take care of this. So see this, this device has come in India. So you are going to have something like a device, AI lab diagnosis. So just by going like a security checkup, you are going to have 86 different
This is an
disease will
AI-powered
be
doctor's
seen.
office. But the craziest part is that there's no doctor inside. It's called CarePod. When you step into a CarePod, you can access 86 different medical tests, including body scans, heart checks, genetics testings, and even blood draws. Once you choose a test, the CarePod dispenses the necessary equipment and sends your data directly to a remote doctor for analysis. The remote doctor reviews your data and gives you feedback, often in just minutes. This whole system is built by a company called Forward, and their goal is to place a CarePod on every street and offer affordable healthcare to billions of people.
Okay, this is what is going to happen. Already they say, already they included in Malaysia. As we had a talk, like we are going to have this industry 5.0, which is going to really happen industry, manufacturing area, disaster management, defense services, smart education, supply chain management, healthcare system, cloud management. So everywhere is going to help. Even as we have seen generative AI, which is already we are all using. So which is going to really help us in many areas like pharmaceutical industry, virtual prototyping, autonomous decision making, production process optimization, generic research, agriculture research, okay, supply chain management, e-commerce, power industry. So many of the areas is going to happen, and you please remember this word also. All this industry 5.0, 5.0, we are going to start calling like cyber physical systems. Because I told you like a watch you are going to keep like this means the sensor which you are going to use is like a control. Okay, sensors are controls, and it's going to communicate through internet, and it's going to do computation. So control, communication, computation is going to form like cyber physical system for information like VAT. Okay, Vellore Institute of Technology. No, already they started like MTech in cyber physical systems with specialization in IoT for EC branch. MTech cyber physical system with cyber security, something like that. MTech cyber physical system with each department, mechanical, they started something like smart manufacturing. So you are going to have this type of degree in futures. So you should be ready for these things. Try to get a lot of ideas what is happening in cyber security. Skip some of things, and we are going to have this type of society, future society. All these things will be committed. Okay, like smart health, smart ambulance, smart security, smart parking, okay, smart offices. So all these things are going to be connected with technology. So everywhere we are going to do. And even if you see the analysis, especially for the AI, they say like 243 million billion is there as on date, but it's expected to touch 826 billion. So try to do research, try to do more work, because we are telling one side that we job will go, but we expect a lot of things. So you have to develop the skills related to this area. That's what I want. That is, try to do this. See, like this, robots are already serving food, and you can see drones are delivering food like this. Okay, so we should be take care why this is happening. Okay, how these students will be there. If you see in Chennai or most of metro cities, I see most of the BSS engineering degree holders are going delivering food. I don't know what will happen to that. I'm always thinking, okay, technology is good, but what will happen to those people? So we have to see. Then they have to start developing some other technology they should try to learn. Learn some value-added skills. Okay. See, Amazon products is going to be delivered like this, or even the medicines are going to be delivered like this using the drone. And even the agriculture, what we are doing is going to change. Okay, all these things manually it is done is we are going to have this type of drones are going to do this type of fertilizer. So whatever is there, you have to be ready. So because sprinkler, sir was telling, so previous speaker, where all these days we are doing like by hand we are doing, but now automatically there will be a moisture sensor, which is we are going to keep some threshold. Okay, whenever the water level or the soil level like dryness is there, it will automatically open it. So this is what is going to happen, whether it's a robot or whatever you take, like most of the car factories. If you see just a few seconds, you can see because of time will show. Just most of things are happening like this. So mostly it is done by robots. Okay, whatever technology you have, most of the factories they started using this. But we have to learn this robotic technology, and we should try to do the coding, whatever you want to do related to this. We should be ready for this. Anyway, a lot of things that will take time. It's just for idea I'm giving you. Even this type of AI newsreader has come. So nobody will believe this is actually like what I can say. We'll feel that she's real lady, but the way she talks or everything, you will feel the difference.
OTV has reached many milestones, earning the reputation of being all the people's go-to news channel. Now, giving birth to me and by instating me into the TV and digital world, OTV has marked the beginning of a historic moment not only in Odisha, but for all the regional television broadcast mediums across the country. Please tune in for our upcoming segments where I will be hosting latest news updates coming in from Odisha, India, and around the world. I hope you will accept me with the same love and enthusiasm. Namaste.
Okay, so we should be ready for these things. All the technology, as I told you, is going to be connected cars, driverless car, smart hospitals, whatever softwares like hardware people are using is okay. Raspberry Pi or Arduino, ESP82C6, like Node MC, you can try. So what is going to happen is the technology is going to be because of this IoT concept. Especially we are going to call this as Internet of Things. You see this autonomous car, we are going to have all these sensors are going to be there. Different sensors are going to be there, and we have jobs in all these things because I told driver's job will go, but you are going to have all these companies are giving jobs. Okay, that much activities are going on, so we have to develop our skills related to that, and we should be able to do this. Maybe just quickly I can show this also. Okay, quickly one more car, how this autonomous car is going to change the way we live.
A self-driving taxi service called Waymo is coming to Los Angeles.
The service already up and running in San Francisco. Rich Duro takes us for a ride in one of the cars in today's tech storm.
So I'm here in San Francisco where Waymo has fully autonomous cars picking up people and dropping them off just like a taxi, except the big difference is there's no driver. We gotta try this out. The way you do this is kind of like any other rideshare. You open up the app, 555 Laguna Street, $9. It says I'll see you in 8 minutes. The ride is about $9. While we wait for this, I'll tell you about the car that's gonna pick me up. It's a Jaguar I-Pace, all-electric car. For safety reasons, the cars stop in certain areas to pick you up. And so on your app, it'll tell you I should walk 90 feet ahead to where it's safe to pick me up. So there's the car. Oh, that's so cool. Use your phone to unlock the car, then you can open the trunk, put your stuff in the back, and let's go in. Oh, this is so wild. Here we are inside the self-driving car. It says, good afternoon, start ride, and I see my destination right there. I don't even have a place to charge my phone. All right, to start the ride, here we go.
Heading to Ben and Jerry's. Please make sure your seatbelt is fastened. For any questions, press the call support button to speak to the rider support agent.
It's cruising the street just like a regular driver would. We're actually passing another Waymo. They honk to each other, and I love that you see the map on the screen here. What's really interesting is that this car is very sure of itself. It's not like creeping along the streets. It's driving like a real human would, so you feel like it's confident about what it's doing. The best part is watching the wheel move all by itself.
Proceeding on Miller Street.
You got your map view, your music, your temperature. You can even adjust the temperature. Oh, that's cool. Oh yeah, here we go. We got a truck that's in our lane, and we're just going around it. No big deal.
So like this, there will be a LiDAR sensor which is going to take care of communication.
So how's your day going? Oh wait, I forgot. If you're sitting where I'm sitting, you really won't even know there's not a person in the seat in front of you driving.
Door here. Please make sure it's clear before exiting and don't forget any items in the front.
Okay, that was a pretty neat experience. I've been in lots of cars where there's a driver. Even without a driver, it felt safe. It was fun. The Waymo handled these streets with ease. It even opened the trunk for me. Pretty neat. In San Francisco, I'm Rich DeMuro, and you are Tech Smart.
Okay, so this is what is going to happen in future. So we should be ready for all these things. If you see the medical related, many changes you are going to see like this. Okay, you are going to have all this. So we are going to have nano sensors like this, which is going to take care of this. Okay, everywhere you are going to call like smart. So neuroscience or mobile health, e-health, bioinformatics, point of care, drug discovery, affordable diagnostics, digital twin, health for all, 360. So this is what I told you. So you are going to see all those things through like this. Okay, I think because of time, I'll try to skip some more things. Change this like this. Okay. So many changes you are going to see in the world. It is really going to help us. Actually, for the society, you are going to get many things. And most of things you are going to see like a smart like this. See, whether it's a smart homes or smart egg tray, smart washing machine, or smart lighting, smart AC, or smart sleep systems, or smart weather stations, smart slow cooker. Everywhere, whatever. See, even for this garbage, they say smart garbage. So what they want, a simple thing. They are going to have some like a sensor which is going to be there, which is going to take care of this. Okay, it is going to help us automatically. It will send a signal to the concerned person, and maybe in future autonomous vehicle may come and pick up that also. So this is what is going to happen. That disturbance is like this. Okay. So smart gardening, healthcare, industrial use, smart homes, smart cities, and as I told you, agriculture. Everywhere you are going to see this. See, smart transportation. Many changes you are going to see, or smart wearables. Okay, as I told you, like whether it's a learning, also you are going to see many reality, virtual reality. Even you are going to have like 360-degree videos. Okay, which is really going to make our students to have like immersive videos. They are going to really enjoy these things. Okay, so I think quickly I can skip some more things. A lot of technologies are there, but I don't want to cover. And we are going to see in future everything we are going to call as internet of everything, because it is going to have like machine to machine, or people to machine, or people to people, like this. So many changes we are going to happen. I think because of time I'll try to skip these things. And so what I want to conclude is, it is going to be like all these things are going to be like this. Future we are going to have all the smart city concepts, which is really going to make us like this. And all these things, whatever you have, you are going to have this as hunting society we started, then agrarian society, industrial society, then information society. Now we are all super society, where we have smart government, smart environment, smart economy, smartphone, smart institution, smart technologies. Because as all of us were discussing a lot, so what I want to say to the, especially to our students, start doing more research, try to think how I can do for the society. So some of the society applications we have to prepare, and we have a lot of jobs. So don't think, because those days when computer came, people are telling it is going to replace all the type machines or typing typewriters or everything. But computer gave a lot of jobs. Similarly, people are saying whatever you are doing like AI or whatever, all these things are going to change this. But you have, please look into, so that it is going to really help you. Again, I say that don't depend only on your degree. Whatever syllabus or whatever curriculum you have, whether it's updated or not, don't worry. But try to do all those courses. I know the difficulty what is here. You may not get a lot of training here, but try to use the online portals which are giving free courses. I'm sure if you go to SWM, you have all the courses are available. Or I don't know how many of you are using Virtual Laboratory of Government of India. They have vlab.co.in. Okay, just click vlab.co.in. You can get all the laboratory experiments available, even for computer degree or mechanical, whatever you want, EC, electrical, all the branches you have. Try to use that, try to develop your skills. That is why I always say we have to take care of the kinesthetic learners. Okay, we have three types of learners we call. One is like audit learners, visual learners, kinesthetic learners. So wherever possible, we have to make our students with good kinesthetic learner concept, give them simulation first and ask them to do the practical. So that is going to really change the way we teach also. So thank you for the opportunity. Thanks, sir. Thank you very much. Hope to discuss in future whenever we have time. Thank you very much. Thank you. Connect. Sorry, we can connect them. Huh?
Okay, okay, sir.
Sorry. Or you want to finish that, so that they can see that whatever that group will be there.
What's up?
No, they have to, that external people will be seeing. You can see that. I don't know. That's please 1 minute. You can use this. No problem. So, until you change, next is speech or break.
Sir.
Okay. That means we can keep this. Okay, so that your people can see that.
No, so we can actually handle that.
Now come up and provide sir a certificate of appreciation as a gesture of gratitude for sharing valuable insights with us. Everyone, please give a huge round of applause. Thank you so much. Now we will be starting our paper sessions shortly.
So, okay, the current मध्ये येतो current मध्ये येतो straight up current मध्ये
Everyone, please join your respective halls and get
Hello. So good evening everyone present here. So myself I am Surajit Alvar. So now we'll be moving to one of our most important segments of today's event, the research paper presentation session. This session provides a platform for researchers and scholars to showcase their innovative work, share new ideas, and contribute to the advancements of knowledge. So we look forward to insightful presentations, engaging discussions, and meaningful academic exchange. So So let me introduce you all to our session chairpersons for this session. First in session chair we have Dr. Shitla Prasad here. Dr. Shitla Prasad is an assistant professor in the School of Mathematics and Computer Science at IIT Goa and a highly respected researcher in the field of computer vision, deep learning and AI-enabled imaging system. Dr. Shitla Prasad has authored more than 140 research publications, including journal papers, conference papers, and book chapters, and his work has contributed significantly to real-world applications of AI, ranging from plant identification and medical image analysis to advanced drone-based image intelligence. He is also a senior member of IEEE and has received multiple recognitions, including the Best Paper Award at IEEE ISES 2024 for his breakthrough work in on-device cardiac arrhythmia detection using tiny ML. Another one is the Best Poster Award at the Ninth International Conference on Computer Vision and Image Processing in 2024 for his work on semi-supervised drone-based traffic rule enforcement. At IIT Goa, he also contributes to institutional responsibilities as a liaison officer for STS-TPWD welfare and is a key researcher in the Center for Drone Applications. So next in session, co-session chair, we also have with us Dr. Ranjan Maiti. Dr. Ranjan Maiti is an associate professor in the Department of Computer Science and Engineering at Central Institute of Technology, Kokrajhar, Assam. Dr. Maiti's research interest spans a broad and important range in extended reality, human-computer interaction, video processing, machine and deep learning, medical image processing, and IC architecture design, reflecting his commitment to bridging advanced computing with real-world applications. He has contributed numerous high-impact publications, including recent work on augmented reality for tribal language education, machine learning-based disease risk prediction, and computational model for web page aesthetics and interface design. Today, under his leadership as conference chair, we look forward to insightful discussions steered by his rich academic and research experience. So we'll begin with our first paper, which is paper ID 227. The paper is titled as From Data to Diagnosis, Harnessing Machine Learning for Early Identification of Autism Spectrum Disorder. And this will be the authors for this paper are Pushplata Munda, Pratham Kumar Uttam Giri, Alok Kumar Agarwal, Mary Saxena, and Ramani Tripathi. Yeah, so maybe the author can start sharing the screen and respected author can start sharing the screen and begin their presentation. So there will be 10 minutes of presentation. Yes, sir. Followed by question answer. Yes, sir. There will be a 12 minutes session for a presentation, which will be followed by a 3-minute Q&A session.
Sir, is my screen visible? Sir, am I audible? Good morning, everyone. My name is Pratham Kumar, and I am second year BE Computer Science Engineering student at CITK University, Himachal Pradesh. So I will begin with a brief introduction and motivation behind our
Hello,
work.
sir.
Yes, sir.
Are you are not audible, sir?
Sir, not audible. So now I am audible. Am I audible, sir?
Please, sir, wait for a moment. Sir, please, sir, you can just check in for a while.
I am audible, sir.
Change the speaker. Change the speaker. Yes. What are you?
Pratham, you are audible online.
I am audible, sir.
Yes, sir. Yes. Yes, sir. Yes, sir. You
Okay.
can continue. Yes, sir. Yes, sir.
Should I start, sir?
Yes, sir. You can start.
Good morning, everyone. My name is Pratham Kumar, and I am second year BE Computer Science and Engineering student at CITKARA University, Himachal Pradesh. So I will begin with a brief introduction and motivation behind our work. Then I will summarize the key finding from existence literature, explain the problem we are addressing, and walk you through our proposed methodology and experimental setup. After that, I will present and analyze the results of different machine learning models. Finally, I will conclude with key takeaways and future directions, followed by reference. So, this research this research titled From Data to Diagnosis Harnessing Machine Learning for Early Identification of Autism Spectrum Disorder is a collaborative work by faculty and researchers from Chitkara University, Himachal Pradesh and Punjab. The authors are Pushpalata Manta, myself Pratham Kumar, Uttam Kumar Giri, Alok Kumar Agarwal, Mary Saxena and Ramamani Tripathi. We belong to the domains of nursing and computer science and engineering, making this work interdisciplinary in nature, combining healthcare and AI. Autism spectrum disorder is uh, a complex neurodevelopmental condition affecting communication, social behavior, and interaction. Although early detection can significantly improve patient outcomes, current diagnostic methods are often subjective, time consuming, and costly, and also require trained specialists. This motivated us to explore data driven approaches using machine learning that can automate and support early screening. Our aim was to create an efficient, reliable, and objective prediction system using simple AQ10 screening questionnaire data. And now the literature review. In recent years, many researchers have applied machine learning for early detection. Several works reported accuracy above 95% using ensemble models and decision trees. Some studies explore MRI based detection, while others focused on behavioral questionnaire like AQ10. However, very limited work exists on balanced behavior dataset, which is what our work tries to address. Now, the problem statement. The current ASD diagnostic process suffers from three major issues. It is slow, subjective, and highly dependent on expert clinicians. This make early diagnosis difficult, especially in rural or low source settings. So our problem is how can we design an automated, accurate, and cost-effective machine learning framework that help in early ASD screening using simply available AQ10 questionnaire data. We focus on reducing subjectivity and increasing reliability in early identification. Sorry. Our methodology begins with data collection from AQ10 autism screening dataset. We first pre-process the data by handling missing values, encoding categorical features, normalizing numeric value, and selecting important features. Then we trained six machine learning models: logistic regression, sport vector machine, multi-layer perceptron, MLP, XGBoost, Light GBM, and CatBoost. For evaluation, we use accuracy, ROC, AUC score, and confusion matrices to carefully compare their performances. Now the experiment settled. To avoid bias, we converted the original data into balanced version. We split the data into 80% for training and 20% for testing. Our goal was to check how well machine learning models generalize to unseen data, which is very important for real world deployment. Now, these are the results showing on the slide. The results clearly show that ensemble models significantly outperform traditional models. XGBoost achieved the highest performance with a test accuracy of 94.79% and ROC IOC of 99.23%. CatBoost followed very closely with similar test accuracy and excellent cross validation scores. LightGBM also performed very strong. On the other hand, SBM showed poor performance with high false negative, which is risky in medical screening. Now, these results shows that grading boosting models are highly suitable for ASD screening tasks. Now, come on the conclusion. For conclusion, our study proves that machine learning, especially ensemble boosting model, can significantly improve the process of early ASD identification. XGBoost, CatBoost, and LightGBM demonstrated excellent performance and reliability. In future, we plan to use larger and more diverse datasets, integrate genetic and neuroimaging data, and apply explainable AI techniques to increase trust and among in, clinicians. Our long-term vision is to integrate this model to a clinical support system or mobile screening tool. Now, this slide contains the key references that supported and guided our research. These include recent journal articles and conference paper related to ASD using ML, ensemble models, and behavioral datasets. With this, I conclude my presentation. Thank you for your time and attention. I will be happy to take questions or hear your valuable suggestions.
Can you hear me?
Yes, sir.
I am Dr. Ranjan Maiti.
Yes,
So I have some question like you have mentioned your data is balanced data.
yes.
What is the size of your data? I think we missed out that point during your presentation.
Size, sir, almost 1,000 patient data.
Means have you considered any standard data set or it is created by yourself?
No, sir, it is available on UCI machine learning, UCI publicly available data on Kaggle.
Okay. And means in real-time implementation, if you feel that I will implement it, the AQ10 questionnaire needs to be answered from the parents, those who have those kids who have these problems. So often it becomes very difficult to figure out or the collecting the data. How do you think in future we can overcome this problem?
Sir, basically, the data set contains 1,000 fields. In that, there are 70% or 80% above are negative. So that is imbalanced data. So we balanced by applying yes and no equally.
No, no. My question is different. Say your data is CSV data in CSV format, correct?
Yes, sir.
So whenever a kid, say for whom you are supposed to diagnose that whether the kid has a autism or not, then this data needs to be collected, and it's very difficult for a parent that to diagnose to identify this reason at a very early stage. So why don't you plan for a mobile-based application where people can use it and check whether their kid has a
Yes, sir.
this symptoms or not?
We are thinking about it for future to
Okay.
make AI integrating explainable AI.
Okay, fine. So yeah, right. This is Sheetal Prasad. So just to ask, like anybody has any question, online participants? Okay, fine. So Pratham, I'll just have one quick questions. So
Yes,
do you
sir.
have, as I see the results, it's like almost 95% above. So what do you think, like, is it more challenging data for you, or do you think like the task which you are going to contribute over here is going to have a significant impact? Because there is no much margin over here.
Sir, can you repeat the question, please?
The question is like the data set is already very much saturated. You are getting a performance which is more than 95%.
Yes, sir.
So is your method going to contribute anything significant? So my question is like, do you want to reconsider the dataset choice? Because the work which you have done is maybe good or maybe not good.
Sir, for more larger data set.
Yeah, larger data sets maybe you can consider.
Yes, sir.
Yeah, okay, fine. So thanks. We'll move to the next.
One question, Shikala.
Thank you so
Yes.
much, sir.
Just one question. Yeah, what is the type of data set you have considered? Is it, can you just explain what is it inside the data set?
It's a numeric data of AQ10 chat questionnaire.
Okay, so these informations are related with the baby in the womb or after birth?
After birth, sir.
Okay,
5 to 10
because
year of age.
okay, maybe in later stages you can consider datas which is available within the womb itself, because now the technology has improved so that you can predict the autism everything within the mother's womb.
Yes, sir, definitely, sir. By neuroimaging.
Okay.
Okay, fine. So thanks. So let's move to the next paper.
Okay, sir. Thank you, sir.
Okay, so next paper ID is 50. Paper ID 50. So the paper is on cancer detection using machine learning frameworks using ESO assisted feature selection. So the author is Tanya Gupta. Please. So 10 minutes presentation followed by question answers.
Good morning, everyone. Am I audible?
Yes, audible. Please carry on.
Is my
So your
screen
screen.
visible?
Yeah,
Oh,
go to your presentation.
okay, thank you.
Present. Make it full screen. Yeah, okay, fine.
Okay. So, good morning, everyone present here. I would first like to extend my respectful greetings and gratitude to the session chair and the co-chair. My name is Tanya Gupta, and I am a PhD research scholar, and I am affiliated with Department of Computer Science, University of Delhi. Today, I will be presenting my research work titled as cervical cancer detection using a machine learning framework with PSO assisted feature selection. This work has been carried out under the guidance of Professor Neeraj Kumar Sharma, affiliated to Ramlal Anand College, University of Delhi, and Dr. Subodh Kumar, affiliated to Department of Data Science and Analytics, Central University of Rajasthan. So, in this presentation, I will walk you through the background and the motivation, the literature review, and the proposed methodology, experimental setup, and results and analysis, and finally the conclusion with some future scope. So, cervical cancer basically continues to be a major global health concern. Based on the recent Globocan 2022 statistic, there are over 662,000 new cases reported each year, with approximately 348,000 deaths worldwide. And what makes this especially concerning is that about 90% of these cases occur in developing countries and low resource countries, reflecting both the healthcare inequalities and gaps in the screening accessibility. Globally talking, cervical cancer is like the fourth most common cancer among the women. So, if we look specifically and at India, the burden is particularly significant. Each year, the country report around 1,27,000 new cases annually, and sadly, a woman dies from cervical cancer every 8 minutes. Talking about the current diagnostic practices that has been held, the most popular diagnostic practice is the pap smear test. It is widely used, but yes, it is subjective and it depends on the expert interpretation, and it can be prone to the false negatives. Second, we have VIA, visual inspection using acetic acid, and colposcopy test. This is a low cost and more accessible option, but in but they have limited sensitivity and may miss some early stage abnormalities. Third, we have HPV DNA testing and liquid based cytology. They offer high accuracy and reliability, but they require like more infrastructure, more laboratory facilities, trained persons, and they are comparatively more expensive. So, despite the availability of these methods, manual cervical screening faces multiple challenges. Diagnostic sensitivity can be inconsistent, and result may vary between the observer due to the differences in their training and expertise. Factors such as poor sample quality, limited infrastructure, and processing delays can further affect the accuracy of the reports. Additionally, the workflow itself is very time consuming and susceptible to human error, which may lead to the late or the misdiagnosis, especially in the large screening process. So, talking why automation matters. So, to overcome these challenges, AI based automation offers a promising pathway forward, and machine learning and deep learning can enhance the diagnostic precision, ensure consistency, reduce the inter observer variation, and can support earlier detection. Most importantly, automated approaches can scale efficiently and cost effectively, making them especially valuable in the underserved regions where the burden of this disease remains the highest. So, now summarizing the existing works that has been done, there are many research that has been done. Like, for example, author Ilyasu et al. They propose a hybrid framework using QPSO and fuzzy KNN hybrid. They basically select 7 optimal features from the pool of 17 and were able to achieve accuracy of 85 F1 score. And then we have a paper proposed by Malietal. They develop a system using fuzzy semen segmentation with some 20 shape, color, texture, and features. Similarly, there are very papers. Basically, the prior research demonstrate the value of feature selection, segmentation, and handcrafted approaches, but they also show some variability and performance gaps, especially in multimodal and real-world clinical settings. So, building upon these existing methods, we have developed a new cervical cancer detection framework, integrated PSO. PSO is the particle swarm optimization algorithm with machine learning classifier. Our approach combines both the handcrafted features and automated extraction techniques to capture the structural, textural, morphological, and contextual information from the pap smear images, ensuring the use of both global and local discriminative features. We employed PSO particle swarm optimization to identify the topmost 50 informative features, thus enhancing the computational efficiency, minimizing the overfitting, and increasing the diagnostic precision or accuracy. And using the optimized feature set, we achieved an accuracy of 93.49% with the SVM classifier, which basically outperforms several state-of-the-art approaches and demonstrates strong performance. Now, explaining the methodology that we have used the Herleaf Pap smear dataset. It is a benchmark dataset for the cervical cancer, and it contains 917 cell images categorized into 7 cytological classes. For analysis for our work, we have further grouped these classes into 3 categories: normal, benign, and malignant. And then we designed a comprehensive set of 159 handcrafted features. Basically, these features are extracted from the images. We extracted texture based features, shape and morphology features, frequency and statistical based features using DWT variance, kurtosis, etc. After extracting these features, and to address the high dimensionality and to reduce the redundancy, we applied particle swarm optimization for the feature selection. Using PSO, we acquired top 50 informative features, which further improved the computational efficiency. Then finally, we trained several machine learning models, including SVM support vector machine and various ensemble models like random forest, extratease, XGBoost, his gradient boosting, and EDA boost. This basically represent our whole methodology that we have used. So now explaining the experimental test setup that we have used to train and optimize and evaluate our proposed framework. We used PSO algorithm for feature selection, and these some parameters are listed. Like for in PSO algorithm, we have to set the swarm size. We set the swarm size to 30, and the optimization ran for total 100 iterations, and we use a dynamic inertia way decreasing from 0. 0.9 to 0. 0.4, allowing broad exploration in early iterations and more focused convergence later. And both the cognitive and social coefficient was set to 2.0, meaning the particles relied equally on their own experience and the global best solution. For pre-processing, the features were normalized using standard scalar, and to handle the class imbalance among the dataset, we applied SMOTs, which basically generate the synthetic samples. And for training and validation, we use 30-fold cross-validation, which provide a robust and reliable evaluation. And to further enhance the performance, we use randomized search CV for the tuning of hyperparameters of a model, ensuring like efficient tuning. And to evaluate our machine learning classifiers, we uses multiple metrics including accuracy, precision, recall, FN score, and we also generate confusion matrices that were to visualize classification behavior across diagnostic categories and better understand where the misclassification is happening. Now presenting our results. So among all the trained classifiers, support vector machine demonstrated the best overall performance. It achieved the highest accuracy of 93.49%, along with the strong precision of 93.5, recall of 93.7, and FN score of 93.5. So this balance among the SVM across the evaluation method indicates that SVM is effective not only in correctly identifying the positive cases but also in minimizing the false negative and the false positive. And similarly, our other ensemble models like random forest extrabits were able to achieve an accuracy around 90 to 91 point range. Now, comparing our framework, our proposed scheme, with the existing studies to basically contextualize this result. So, compared to these works, our proposed PSO plus machine learning framework achieves the highest reported performance with an accuracy of 93.9, demonstrating a notable improvement. Now, summarizing the proposed framework and overall result. First, the framework combines multiple feature types with PSO-based feature selection and different machine learning classifiers. Among all the models tested, SVM performed the best with an accuracy of 93.549, while the ensemble models also performed well with results in exceeding 90%. Our method has some clear strengths. It captures the diverse information, selects the most meaningful features, and the results are clinically useful. However, there are some limitations in our work. We basically relied on a single data set, and it is quite and it requires basically high computational resource. And moving forward, future improvements could include using more deep learning methods, exploring hybrid optimization approaches, and validating the system across multi-center datasets to make it more generalizable. So these are the references that we have used in our study. Some of them are listed only. Thank you.
Yeah, thank you. Can you just go to your result screen?
Sure.
Results part. Yeah, I can see that you're getting a best accuracy with SVM, correct? That is almost like 2%. Right,
Yes.
1.5 plus 2%, nearly. Any specific reason like why SVM is performing that great compared to random forest or even XGBoost is like the least? So any specific reason? Is it something related to the data sets or something?
It can be happen because like it can be due to like hyper parameter tuning. Maybe the other ensemble models are not fine tuned very much so that they can give better results than SVM.
So what is your consideration? Like what hyperparameters you have done it because it is your work, right?
Like we have some time constraint, and to like reduce the computational cost, we have used randomized search CB. So basically, it randomly check the hyperparameters. So maybe due to this, some hyperparameters are not fine tuned in other models.
I would like to suggest you, like maybe what you can do is like you can just go with the SVM, try to do some kind of basic studies over the SVM itself. Try to use different types of kernels, and maybe because of that you can get to know that what features or what particular parameter is going to lead to that particular boost. It will
Okay,
be
okay, sure.
more inside details because getting these results is okay, but you should also be able to justify why these results are like that. Second thing is like
Sure.
your workflow. Like I didn't see a block diagram throughout your presentations. So how you chose, how you selected the features, and then how did you train it? What is the training size? What is the number of epochs and all? So that kind of distributions I couldn't see in your slide. Maybe you can just point out there.
What? Sorry, I couldn't understand. Can you repeat?
I want to see, do you have any slides on workflow, block diagrams of your complete proposal? Do you have that?
Uh, like this is the proposed PSO based framework that we have employed.
So here you can see
Talking
that,
about. Uh-huh.
yes. So this is a kind of like data set which has some images, correct?
This is an image data set.
Image data sets, and you have multiple sets of our features there, like feature extractors, so many feature extractors. Which one is the one which you have used? That kind of your proposed method algorithm is not present over here. You're using all of them.
No, these are like features that we have extracted from the image data set, like LPP, linear binary patterns, using some of the methodologies, and the algorithm, which is basically particle swarm optimization algorithm. This is basically an optimization algorithm used for the feature selection. So basically, from the pool of like 159 features, we have selected 50 features using this PSO algorithm.
Okay, I can see that part. My question is like in features extraction, which
Hmm.
method you're using, or are you using all of them and then concatenating that feature vector as a one single feature vector and then do the
All of these methods are used. Using all these methods, we have extracted 150 features.
any specific reason why all these nine features? Or
Basically,
just
like we were like exploring the feature extraction technique, like how features can be extracted from the images. Basically, like we have some texture features, like what basically related to texture based, the frequency based features, which is related to the images. So these are some methodologies that we find, and these are also methods that has been earlier used in the study. So that's why.
okay, got it. Why I'm asking all these things is because the methods which are showing in the feature extraction, they all are of different domain. DWT is a different domain, LBP is different domain. So if you get a feature vector of these and then you concatenate it into a one single feature vector, you have to do a lot of normalizations. Their values will be completely different. So your data pre-processed will be having a completely different dimensionalities. So that's why my concern was like, when you do this kind of feature extractions, are you also considering normalizations and making them into one single vector? So that,
We have used standard scalar for the normalization purpose.
okay, fine, fine.
Basically from the range 0 to 1. Yes.
Yeah, thanks.
You hear me? Right?
Yes, sir. Yes, sir.
I will also go with the points that already highlighted. Means putting SVM, there are different type of kernels there. I don't means. Can you tell us which kernel you have used in this experiment? So is it a linear kernel or something else?
It is an RBF kernel.
RBF kernel. So maybe
Uh,
there are more kernels you could have explored their performance. And
there are many kernels. Yes.
regarding this class imbalancing problem, except smoke technique, there are smotomac other techniques also. So you would also have explored those area and can check how this performance can whether you are getting more improved performance or not. Okay.
Okay. Okay. Sure, sir. Thank you.
Any participant has any question? Otherwise, we will move to the next paper.
Can you explain on data labeling and ground truth which is used in your work?
Sorry, sir.
Data labeling and ground truth. Have you
Data
used anything like
labeling.
that?
Uh, uh, I haven't done that. Like data labeling, we have basically three categories. Basically, our data set is divided into three classes: normal, benign, and malignant. What are
And
you asking?
what about the ground truth in the data set? Is it available or for the calculations of your matrices?
Ground truth is like actual label that is present in the data set.
Okay,
Okay, madam. Thank you. Thank you for your presentation. Uh,
Thank you, sir.
we will move to our next presentation. We have our next paper is paper ID 82, lightweight machine learning for real-time detection of swappable cardiac rhythms in pediatric patients using wearable IoT sensor data. Uh, who is presenting? Author?
Yes,
Author, sir, Ramesh, you are there?
yes, sir. Am I audible to you?
Yes, yes, you are audible.
Okay, so
You
can you
can
share
start.
my screen? Okay, so good morning to all. So I am Ramesh Maduranga. I am attached to the Faculty of Graduate Studies, University of Sri Jayawardhanapura from Sri Lanka. So today I am ready to present my recent publication, which is all about lightweight machine learning model for real-time detection of shockable cardiac rhythms in pediatric patients using wearable IoT sensor data. So under the today's presentation, I am going to these key points. So what is the basic background about my study, and what are the existing activities related to my topic, and what is my problem. Then how it's sorted using what is the methodology and the experimental setups, and then finally results and the conclude my presentation. So when it's come to the introduction part, we already know the sudden cardiac arrest in one of the major cause of death in world, and pediatric cases pose unique challenge as they are not same as those associated with adults, whereas ventricular fibrillation and tachycardia tend to be an antigens of adults sudden cardiac arrest. Respiratory failure to the circulatory shock is more likely to be the uh, attendant pediatric cardiac arrest, making it very difficult to recognize and shockable rhythms in time. Rapid recognition of times and immediate defibrillation is vital to survival outcomes, but manual review is electrocardiogram signal during the emergency like to cause delay and error. So early detection is shockable arrhythmia rhythm is very critical and survival, because already we know we don't have sufficient practices to detect the early. So the manual ECG interpretation is during emergency cases. We know that it take time, and it can be some error. So due to that things we identify, we should have a strong lightweight machine learning model for the which is accessible for the wearable devices. So during that my study, we focus several studies that is related to my research. So existing models, existing studies, they highlight some method that can be used for the adult-based system. So but most of research, they use machine learning, deep learning method to show high accuracy for the adult ECG shockable rhythm, but very few research actually they represent as the pediatric patients. So when it comes to the Sri Lanka, we thought we should have a proper system to diagnose, I mean the detect of the shockable cardiac patients. Like when it comes to the pediatrics, very uh, complex to problem. So according to our all the studies, we identify we should have a strong lightweight machine learning framework to identify the shockable cardiac rhythm. So existing models are too computationally intense for the wearable devices, Actually, pediatric ECG monitoring require real-time, low-latency interference because we are working with the pediatric patients. So if we can early diagnosis, that it's very benefit for their families and also that persons, then we can maintain a good health for them. So lack of validated lightweight solution for pediatric shockable rhythms detections. Due to that reason, we find a solution to how to develop that kind of solution for the pediatric patients. So when it comes to the methodology part, actually we don't have live data for this study. So therefore, as an initial step, we generated that ECG from the uh, simulation, and that simulation data used to pre-process and pitch extraction. Then we use say, six machine learning models, namely logical regression, support vector machine, random forest, Bayesian boosting, and k nearest neighbor. Those are traditional machine learning models. Then when we use naive Bayes and shallow decision tree as a lightweight machine learning model to evaluate both traditional and machine lightweight machine learning models with that generated data. So when it comes to the experimental set, we are split into data set. Our data set contains CSV data contain 30,000 of shockable signals and the non-shockable 30,000, altogether 60,000 data. Then the data we split to 80% for the training and the 20% for the testing. Then we are developing a machine learning model with that traditional and the lightweight machine learning. Then we analyze what is the relation between those things and what will be the best for our generated data. So when it's come to the results and analysis segment, so as I show in this slide, there are high accuracies are showing in the each every algorithm. So here the comparing with the all the machine learning algorithms, shallow decision tree is the best one. That is accuracy is 97.5 score of that shallow decision tree. So then we identify that lightweight machine learning algorithm is very benefit and very efficient than traditional machine learning algorithm that is very efficiently diagnose the shockable cardiac rhythms when it comes to the pediatric patients. The final conclusion, so our research provides the conventional or lightweight machine learning models are very effectively identify shockable heartbeat in children using wearable ECG records. So in our research highlight the practicability of light model like naive Bayes, shallow decision trees, which are comparatively terms of accuracy and consume much less calculation power. So then our system can be extended to detect other arrhythmia, AF, SVT, and bicardia. So in the whole, the result indicate that lightweight machine learning models can offer a reasonable trade-off between accuracy and efficiency to guarantee the presence of timely and correctly detect arrhythmia in pediatric patients during the real-life emergency situation. So these models need to confirm by work in future on large-scale real-world dataset of the pediatric ECG and research hybrid feature engineering methods to support greater robustness and noisy and the heterogeneous environments. So in future, we are planning to validate with the real-time ECG data to validate our systems. So these are my references for this study, and thank you.
Yeah, thank you, Ramesh. So just to have a quick so the data sets which you have mentioned in this are all collected by you or a public data set?
Sorry, sir, I didn't.
Is it a public data set?
No, sir, this is a generated data set because we don't have sufficient data. Therefore, first we generate the data and we analyze that data. Then nowadays we are collecting data from our hospitals.
Okay, so what kind of sensors you mentioned?
Sorry, sir.
What kind of sensors?
Actually, we are using wearable watch like Apple Watch. So using that watch, we are collecting the ECG signals and convert to the our system.
Yeah, that is only one LED sensors. That sensor, the device which you are using, that is only one LED. So that is not very much calibrated compared to the actual ones. So are you also doing the calibrations after collecting the data?
Sorry, sir.
Are you also doing the calibration after collecting the data?
Still not, sir, but we are processing of collecting the data.
Okay, fine, fine. So second thing is like how big your data set is now?
I
Oh,
yes, sir. Sorry.
how big is your data set?
So are you asking the capacity or the size of data set?
Pardon? Sorry, I couldn't get it. No, size no, a number of samples, subjects.
Actually, for this study, I am using 60,000 data set for shockable and not shockable data. But when it's come to the real world validation, we are collecting data. Still, we are collecting. So our sample size might be less because we don't have that much of reported patient who is with that shockable cardiac.
But the results which you have shown, that is on what? Might be means what? Like, what is your results on
Based on the generated data.
generated data? That is what I'm asking. Like, how many subjects you are using for that generated data?
Actually, the shallow decision tree is the best algorithm that is provide the 97.5 accuracy of that generated data set. So based on that, we are continuing with the real-time data.
Fine. In case of your tiny machine learning, there are many tiny machine learning algorithms available nowadays. Which one, after you design your tiny ML, are you also going for quantizations, pruning, knowledge distribution kind of stuff, or you are just trying to deploy it?
Actually, we are planning to deploy this system into a wearable device, and it should be going to the clinically validation process. Once that validate, then we can develop a device.
Okay, so for now you haven't deployed it, you have just a simulation-based
Yes,
testing
yes,
analysis.
sir. Just
And
simulate.
what is the computational cost for that? Like, say, for example, if I need to test it, what is the inference cost?
Sorry, sir.
Inference cost. The testing cost will be how much? How long it takes to diagnose?
Actually, still we are not consider about the cost, sir, because the thing is, initially we did was the generated data, and it's not that much of cost. But when it's come to the real time, it might be a cost. Uh,
Okay, fine, fine, no problem. So I would just suggest you, like, in case because you are working on a healthcare things, these details are very important for us to know, because they will actually lead to major significance.
okay, sir. Okay, thank you.
Right, so just calculate these things, like how long your model is going to take to diagnose something, and what is your data size, how many subjects, what is the variance. Because if you're taking data from some local regions, maybe they won't be having that much of variance. If you go to some different locations, it will be more generic.
Yes.
So try to club multiple data from here and there locations, so that it will give you more better generalized abilities. Okay?
Okay, sir. Thank you.
Yeah, bye.
Uh, I have a one question, which once you are collecting human data, so if you are collecting human data, there is a need to get it approval from your institute research and ethics committee.
Yes, sir.
Have you taken such approval?
Yes, sir, I already submit my proposal to the ethical clearance board in my university and also the hospital. Then during that their ethical review committee meeting, I get the approval to collect the data with the patient consent. But we are working with the pediatric patient. We cannot get their consent, but I already get the parents' consent.
Okay. So if possible, I don't know, it's if possible in your final version, you could have mentioned that reference number because often when we work on this such area, we used to mention that this is with this order number, this data is collected. Okay.
Okay.
Thank you.
Thank you, sir.
Audience, anyone has any question?
One question.
Yes, sir.
In your work, why you have focused only to the pediatric patients, like infants and childrens?
Sorry, sir.
Why you have focused to pediatric patients?
Actually, sir, when it comes to the pediatric patients, I already find some information regarding that adults, children, and the pediatric patients. But in our case, we don't have sufficient capacity to diagnose early diagnosis of the pediatric patients. There is a lack. So that's the lack. Then I am proposing a new method. I mean, I am trying to fill that gap through this study, sir.
And your work is also focused on lightweight ML models, so
Yes,
which is
sir,
like
lightweight.
tiny ML.
Yes, lightweight model.
And nowhere in your presentation you mentioned about the computation cost of running your model.
Sorry, sir.
Computational cost. It's
For
very
this,
important for tiny ML.
yes, but computation cost for this is basically generated data. Normally, the computational complexity of this generated data uh, less than I mean the traditional ML model less than the lightweight.
One more question is on the shockable rhythms. Since you mentioned that you are focused on pediatric patients, how you will give the shockable rhythms? Like,
Actually, sir, when we are gathering the data during the clinical process during the hospitals, once the doctor is identify that patient is with that issue, then we can collect that data as our record. Otherwise, we don't have idea about this patient with shockable or not. Once the clinical process they identify this patient as a issue, I mean that patient has that kind of issue, then we are report as our data. Otherwise, we are planning to collect the data set. Once we collect, then we are analyzing the same because this study we are using the generated data because we don't have data.
okay. Also think about from the real-time deployment perspective also
Okay,
for your
thank you.
future stream work.
Okay.
Okay.
Thank you. So we have our last paper of this session, design of Assamese diet recommendation system using machine learning algorithm. Kakoli Boisha, Jimmy Das, Uma Hajarika, and Mr. Prashanto Borba, paper number 130. I request all the participants to be online because once after this session we will share your certificate with you. Please don't leave this session.
মানুষ মাত্র কোনটা কোনটা করলে পারবো না মানুষ মাত্র পুষ্কিন করবো না
Have you shared your screen? Other participants, can you see this, find this presentation? Is it visible?
No.
No, sir.
Please share the screen. Yes. Yes, share. Right now, I think it is visible, correct?
Yeah.
Thank you. Present. Full screen. Three dot. Yes, fine.
Good morning.
All one.
Good morning, respected our honorable session chair and co-session chair, guests, and everyone present here. It's a huge honor to get the opportunity to present our research paper at the third ICTCON 2025, jointly organized by CIT Corporate IIT Goa. I, Trinidas, along with my co-authors Kakoli Basha, Uma Hazarika, and under the supervision of Mr. Prasanta Barua sir, our title of the paper is Design of SME Style Recommendation System using Machine Learning Algorithms.
ಬೆಲೆಗೂ ಪ್ರೆಸೆಂಟ್ ಪ್ರೊವೈಸ್ ಮಾತಾಡು ఎక్కువ లిమిట్స్ ಬೆಲೆಗೆ తీసుకురాము మన ప్రెసెంట్ ఇవ్వ
Here the agenda that will be covered in this presentation: introduction and motivation, literature review, problem definition, methodology, experimental setup, results and analysis, and lastly conclusion and references. Starting with the introduction and motivation, lifestyle diseases are increasing rapidly like diabetes, hypertension. That needs to be personalized and effective nutrition diet plan. Existing diet apps does not focuses on SME cuisine. They generally focuses on Western meal plans. But our ethnic cuisine also focuses on highly nutritious foods like jawar rice, tenga lai hak, or you can say a variety type of green leafy vegetable that is absent from modern diet apps. So people find it difficult to choose their perfect diet plans in Assam. So our main mission is to create an SME-led recommendation system that delivers personalized science-based meal plans rooted in authentic SME cuisine. This is the literature review we have gone through. Let me summarize briefly, starting with the author Das and Barua, published in 2019. He analyzed and documented the nutrient composition of traditional SMEs recipes and ingredients, but it remained academic research without practical application in digital platform. Author Goswami et al. Published in 2020, he investigated the glycemic response of jawar rice in type 2 diabetic subject, but it lacked the recommendation system. So our SME style recommendation system is very different from existing model because it successfully bridged a critical gap. Also, our system focuses on the authentic local dishes, and also it's affordable for the local people. Here are the problem definition. Existing diet rely on generic Western meal plans and ignoring cultural relevance. So the current system failed to manage multiple health conditions, example diabetes, hypertension, cholesterol, and allergy simultaneously. So the solution is to create an ADRS, a personalized diet plan that offers custom meal plans based on health goals, medical needs, preferences, and comprehensive allergy filtering. This is the system architecture of our model. The user gives input to the web interface and process to the backend server that creates profile manager of the user, then calorie calculator calculates the calorie of the user, then generate the meal plan, then disease filter filterize the diseases of the user, and the allergy checker also filterize the food according to the allergy, then the meal planner, and it stores in the food database and then gives the result, send later result to the backend server and display interactive dashboard. From this slide, I'll hand over to Kapil.
So here we have the methodology. It is the overall working principle. Firstly, we have input layer. Firstly, we have the input layer where the user gives details such as age, gender, height, weight, activity level, and the goals. We also intake multiple health conditions such as diabetes, cholesterol, hypertension, arthritis, etc. And with dietary preferences like veg, non-veg, or vegan, and allergies such as seafood, lactose, or gluten. All the inputs are synthesized and a personalized user profile is being generated. Next is the processing layer, where the BMI and TDEE, that is total daily energy expenditure, are calculated using formulas like Harris-Benedict, Mifflin St. George, along with the activity factor. The calories are adjusted based on the goals by adding or subtracting 15%. Disease-specific filtering is based on medical needs. For example, low sodium for hypertension, low glycemic index for diabetes patients, low cholesterol for heart issues. It matches the nutritional needs with our SME's food database. In the output layer, we have customized daily meal plan from breakfast, lunch, dinner, along with snacks and beverages generated. Each meal is being served with the serving size, calories, and macronutrient breakdown. Interactive macro pie chart and meal-wise bar charts are also displayed in the dashboard. Next, we have the machine learning models that are being used. Firstly, we have the random forest classifier, which we call the health filter. It predicts if a dish is suitable for a user-specific health conditions, for example, like diabetes, hypertension. It works as an ensemble of decision trees trained on our SME's food database. The majority vote determines the suitability. It is robust and accurate and also prevents overfitting. Secondly, we have the K-means clustering, which we call the meal balancer. It groups similar food items based on their nutritional profiles. It is an unsupervised algorithm that clusters foods into distinct nutritional groups. It ensures that each meal is balanced by selecting complementary dishes from different clusters, promoting variety and preventing nutrients overload. Here's the experimental setup, which is the dataset. Our dataset contains 75 plus SMS dishes. The nutritional value that it contains are calories, fats, proteins, carbohydrates, and minerals. Some of the few examples of authentic SMS dishes are jowar rice, aloo pitika, masoor dal, dal curry, poita and tenga fish. The dataset is collected from sources like Indian Food Composition Tables (IFCT), Food and Agriculture Organization, and also from research papers published by Dasan Burma. Here is the user interface and testing. In the user interface, we build a simple input form to create user profiles. The core part is the interactive dashboard, which generates meal plans along with nutrition charts. It is both compatible for mobile and desktop. For the testing, we have recruited 50 users from Assam. The people are from different age groups like 20 to 60 years with various health conditions like diabetes, arthritis, heart issues, cholesterol, etc., along with all the dietary preferences. The results are 4 out of 5 user satisfaction, 88% adherence rate, and 96% cultural acceptance. From here, Uma Hazarika will present.
Here is our resultant analysis. This is the interactive dashboard, very user friendly. We took a 35 years old man with diabetic disease and diet preferences vegetarian with no allergic. Then the output is brown rice, Kerala, and herbal tea, lemon water with no sugar for breakfast, and brown rice, masoor dal, and lai hak, which is mustard greens for lunch, and brown rice, kosu hak, and masoor dal for dinner. And our dashboard contain a health tip, which is like diabetic management recommendation. Here the points are choose low glycemic index food, johar rice and brown rice, etc., etc. Next, here is our interactive visualization, which contain a bar chart of daily nutritional goal and a pie graph for macronutrients distribution. And here is the random forest classifier, and
The conclusion is ADRS is successfully bridged the gap between personalized nutrition and cultural heritage by providing a scientific backed, culturally grounded solution for healthy living with using a Assamese cuisine. The integration of random forest for multi-disease filtration with K-means for nutritional balancing and ensure recommendation are both health and aware and allergies conscious. Here is our future work. Expand the food database with no more regional and tribal dishes. Integrate real-time health data from wearables. Develop a mobile application for wider accessibilities. And these are our references. Thank you.
Okay, so can you go back to your diagram where you mentioned the different rice and other things? Breakfast. Next slide. So say in lunch I ate 10 kg of brown rice. What will happen?
Sir, this is a 100-gram value.
You have to mention what will be the quantity for a particular person.
Yes, sir.
Correct?
Yeah.
Only mentioning that you have to eat, you should go for brown rice. Parallelly, you have to mention the quantity and go back again in your diagram. There was a flowchart, it's an architecture, something like that. Back. Yes. Again, why these things are too much separated? Calorie calculator has a relation with profile manager. There, the arrowhead needs to be bidirectional. Otherwise, how it will come? Correct? Your calorie calculator, generate plan, every arrowhead must be bidirectional. Finally, it may go to your food database. Okay, that is my observation.
Thank you. Can you go to the conclusion part? Here you have mentioned two things. One is your supervised random forest, and one is your unsupervised, which is your K-mean. So why we need two different types of approaches over here? Why can't we use random forest for the nutritional balancing, or vice versa?
Sir, we have mentioned here in the methodology part that the random forest is used as the health filterer. Like our model can predict dishes for multiple health conditions, and the K-means is the like meal balancer, which like it will the calories, proteins, carbs, and fats are there. The clusteration is done by K-means.
Also, right? Because it's mostly customized things. So the calorie which you are taking might not be good for me. So it will be like more supervised. That's what my assumption is. I think that is one thing. So, and you have shown some screenshots also. Is that real working platform you have already?
Yes, sir.
So have you tested it also?
Yes, sir.
Within the internet, or you have also given it some and then got the feedback?
Sir, like we have tested with some family and friends, like they tested her, and our family, there are patients of diabetes, cholesterol, they tested and like they found it's mostly accurate. As feedback, sir, we don't have, it was verbal.
Because like, it's better to feedback in format. You can just have a yes, no, fine. And then submit it. That will help you a lot to put this for the next task.
Yes, sir.
Otherwise, if it is only verbal, आपने याद रखा फिर भूल गया, so it's difficult for us.
So we'll work upon that.
Sure. Do you have something?
Features you can include, daily tracking features with a history, so that whether the goals are achieved or not. That will be helpful.
Thanks, sir.
Thank you for the very nice presentation, and it's a very good work actually, specifically focused towards Assam. So being a native myself from this place, I want to just one small observation. Are you also thinking towards integrating these results towards making an app which will not only recommend within the Assamese cuisine, but also healthy items outside the Assamese cuisine? Because nowadays, if I saw you mentioned about patients of hypertension, but mati mahar dal is a very common item within us. But the problem is for hypertension patients, it's almost like poison, right? So for that, your recommendation system might also be extended in a manner that it could extend to some food items which are outside the authentic Assamese cuisine. So are there any plans of extension?
Yes, sir. The future what we have mentioned is like working with different data sets will integrate more food items.
Okay. Then that would make the utility of the app much better. Yeah. Thank you so much.
Thank you, sir.
Sir, thank you.
Um, Okay, thank you, Kakuli and your team members. With this, this session is over. We are going to present your certificate. Those who are in online, you will check. Someone please come. I also have a. If possible, can you write your email address in chat bot? Sorry, in chat box, so that we can share it. The participant, please write your email address. I request all the participants to write their email address in the chat box. Otherwise, it is difficult for us to share. Okay, in such case, we will send it by email. Yes, sure. Okay. Thank you, everyone. Thank you for your valuable time. Hope we will meet again. Those team had some announcement. Yes.
So the certificates to all the presenters present here via online mode will be provided very soon. So here, just a minute, just a minute.
What we can get.
So first, we'd like to felicitate our session chair. First, we'd like to felicitate Dr. Shitala Prasad sir, which he will be felicitated by our BTech 4th student H. Rohit Singha. And also a certificate. So next, I would like to invite Dr. Ranjan Madi sir, and he will be felicitated by Mona Lisa Roy. Thank you, sir, for your valuable time and your advices. Here is the end for our session 4 paper presentation. Now we will be certificates here. It will be provided.
Next up, we have keynote talk 3 delivered by Dr. Sheetala Prasad from IIT Goa.
Yes, I'm going to.
Dr. Sridhara Prasad is an assistant professor in the Department of Computer Science and Engineering at IIT Goa,
with expertise in deep learning, pattern recognition, and computer or drone vision. He holds a PhD from the Indian Institute of Technology, Roorkee, and has previously worked as a scientist at Institute for Informed Research under ASTRAR in Singapore. Dr. Prasad also held research fellowships at Nanyang Technological University (NTU) in Singapore and CNRS in France. As a senior member of IEEE, he has made notable contributions to the field and has received the Young Scientist and Niche Skill Award in AI. I would like to welcome Sir to start the keynote session. Please give a huge round of applause for Sir. Is a volunteer. Yes, sure.
So could you please place it in a specific folder here? I'll just put it in this. I'll just place on the. Oh, this is not Microsoft. No. There you go. I think it will not run the.
no? So be careful if socks sometimes. Good to go, sir.
Yes, let me check. Can I get that hand mic? Hand mic. Sure.
Hello.
Yes.
Okay, sir. Stand mic, do you need some? Currently not sharing this.
Yes, I'll share it.
Is it visible? Hello? Hello? Is my screen visible online? Confirm? Okay, fine. So, hello everyone. Good afternoon. This is Sheetal Prasad from IIT Goa. So, I will be talking about AI-enabled 6G and future of artificial intelligence, how artificial intelligence is going to look, and mostly we will be focusing on vision things. So, how vision is going to point out artificial intelligence based on 6 generations. So, everybody will be wondering, like, we are still working with 5 generations, and now we're talking about 6 generations. So, just to give my updates, like I'm working as an assistant professor in IIT Goa. Prior to this, I was scientist in A-Star, Singapore. And prior to that, I was working as a postdoctoral in Singapore, France as well. So these are several other details which already was being addressed by people. So I'll start with a very quick recap. Like we all are aware of third generations, fourth generations, fifth generations. Now we're talking about 6 generations. Maybe this is not the first time you might have heard of 6 generations, which is going to come in near future, when and how, with what capabilities. We'll talk about all those details in later sense. But for fifth generations, you can see that there are connectivities. So if we talk about fifth generations, we mostly deal with the connectivities only, public with extended private, encrypted securities, analytics, and so forth. So these are the limitations, or these are the benefits of fifth generations, which is going to be replaced based on sixth generation facilities, where the connectivity along with the sensing capabilities is going to be added on. And that sensing capability will help us to take a service of artificial intelligence, where public and private networks are going to be connected together. That means your network and this network will be sharing the data, will be doing some kind of services, and then it will process. So in that case, we do not need to depend upon the encryptions. Now we are going to depend upon the trustworthiness. So I need to trust this network, and then that's how I will transfer my data, let her process, and then send it back to us. That way we are going to do it. So we are also doing this kind of technological trustworthiness based on the database. So I will believe you only when I'll check your history based on. Second thing is like networking and computing infrastructures. So in current situations, what happens is like we have base stations, and every network, every users are going to be connected to the base. But in coming days, we are going to use open access or kind of like network which is private, but can be in collaboration with the public, so that it can help another private networks. That kind of flexibilities are going to be added into this. It can work with the integrated trains, and also with. So why we are talking about artificial intelligence in more details? Because now artificial intelligence is nowhere a future. It's like with us now. It's not like futuristic. Everything is now driven by artificial intelligence. Starting from the day today, like yesterday we had a opening ceremony. For majority of the tasks, we depend upon the, say for example, if you want to connect with another speaker, we try to use artificial intelligence to cover up the missing data. Say for example, if some speaker has said something, and because of that there was some break in the voice, the voice was being rectified or was being created based on the artificial intelligence. Images were generated, images were reconstructed with the higher resolutions over the wireless transmission. So that's why starting from day, we are using artificial intelligence in our day-to-day scenarios. So that's why AI is going to drive force for the fourth generation, like as Sir has already mentioned about the industrial 4.0 and 5.0. It's in healthcare, it's in agriculture, it's in finance, education, and space. Everywhere artificial intelligence is going to be there. So why not in part of our services as artificial intelligence? Because sixth generation is going to provide that thing. So if we talk about artificial intelligence in sixth generations, these are the services which we can think of as not as a only, but some of them. Here you can see that artificial intelligence enabled sixth generations is going to help us in channel estimation. Say for example, if we are going to connect with someone, and by mistake if there is a break, that channel can be reconnected or will be recommitted. We can also do some kind of intrusion detection. Say, for example, I'm communicating with someone, suddenly that voice was being tapped by someone else. Our network should be able to identify whether that voice or that data is being transmitted to some other third party or fourth party. That way we can do. We can also do some kind of energy optimization. That means persons can not only use the network for communication, but also can use the networks for optimized communications. We don't have, say, for example, if we are talking about the hologram, so in that case, I will be projected there as a three-dimensional, but if I'm not moving, there is no point in transmitting that kind of data, right? So those kinds, in that way, we can optimize it. We can also do some kind of radio source management, network fault management, intelligent routings kind of systems very easily. Correct. So these are all big words. Looks like correct. Whether it is feasible right now or not, we are not very much sure, because if you talk about five generations, fifth generation is still not yet fully implemented in our country. We still have some kind of limitations. So before we dive into the fifth generations, sixth generations detail, let me talk about the artificial intelligence, because majority of you are from different backgrounds. So you might be aware of deep learning, you might be aware of machine learning, you might be aware of artificial intelligence. But just to give you a glimpse, like these are the details where artificial intelligence are going to act as a kind of intelligent machines and programs, whereas machine is going to act as a kind of like ability to be programmed, to be intelligent enough to act on those kind of situations where the network was, or where the program was not was not being programmed. And deep learning is mostly based on it's a kind of like machine learning algorithm only, but there the learning is based on the deeper features, or where the learning is based on the neural networks or neurons. So if we talk about neurons, our how many neurons do we have in our brain? Any idea? 36 million. 86 billion. These are some of the facts which is yes, projected by the Google, of course, but nowadays we have even more than that, because at that time the counting was not so. So here this diagram, maybe you might have seen this image before or not, but just to give you a glimpse, like these kind of images are going to tell you how our brain actually works. Right. On this image, you can see that there's a person who is wearing a pink shirt and walking in a beautiful environment. There is a waterfall, butterfly, listening to a music, correct? And has a shoes of which color? Dark blue and white, right? Everybody will agree with this. But in case if I show you this image and ask you like, what is that? It will be difficult for us to identify any of the object, because we have never seen this object before. And our brain is never trained based on that, because what we see, our brain is trained based on the object's informations, three-dimensional informations, not n-dimensional information. So here, human being, three-dimensional informations, shoes, three-dimensional informations. So if any object is kept over there, whether you have seen it before or not, you will be able to identify it very easily, very quickly. But in case if I convert that object into a feature or into a feature dimensions, that is my digital world, then it will be difficult for human brain to recognize those kind of objects, correct? So for that, what we need to do is we need to bridge them all together. So we are in Assam, so majority of the sector diet is like your fish. So I have taken a fish example over here. You can see there are so many fishes over here, correct? You can see fish image. Can you identify any of the fish? Or can you identify what is this? Oh, sorry, it's not visible there. What is this one? Is it a fish? So now you can think like your brain is taking more time to process this feature. Your brain is not accepting these kind of details to correlate with any kind of objects which has already been seen by your brain before, past 20 years or 25, 20, 24 years. Right. So for that, what we need to do is we need to try to understand the brain concepts, like how our brain actually works, how it takes the information, like the first one is your biological neurons, second one is your artificial neurons. So there is a replica of biological neuron, that's what we call as an artificial neuron. So similar to our biological, we also have an input. We have a cell body. Similarly, we have a function which is going to collect all those informations together to process it. and then after doing that processing, it will pass it to the next neurons, which is also the concept of axons in the biological neuron. So if we connect them all together, it will form a network. And that network is, in a biological case, we have a brain. In artificial intelligence, we have a artificial neural networks. And if you talk about the neurons, then it is a neural networks. That is deep neural networks, if you call. So here the experiment shows that the diagram shows that the light is going to be passed from the eyes, and then you're going to get some kind of informations on the retina. Retina will have some kind of hairy-like membranes. They will generate some kind of impulse. Based on that impulse, the signals will pass through one layer to the other layer. It's basically like clusters of neurons. So each clusters of neurons will have their own dedicated work or task. So this cluster will do some work, then another set of neurons, and then at the LOC, it will say that, okay, this particular wave signal or this particular wave pattern is resembling to a, maybe Pankaj sir. Okay, and if I change the wave to the longer one, maybe that resembles something else. Maybe, what is his name now? Someone else. Okay. So this way, the brain actually tries to identify what neuron, what signal is there, and based on that signal, the object is correlated. Same way our deep learning also does. It will take the image. Here the image, so eyes is basically replaced by a camera lens. Camera lens is going to generate some kind of image. This image is a digital image, so every single pixels will be converted into a pixel values. That values can be converted into, will be having three components, which is your red, green, and blue in case of RGB cameras. So that will be converted into a matrix format. So matrix will be there. That matrix will have some kind of intensity values, which is equivalent to your retinal signals. Right now, we are going to extract those signals into some kind of fashions based on some set of neurons. This will filter it out. Like we have a filters, right? The bigger particles will be filtered out. The smaller particles will be gone through. So we are going to extract the key features of this information step by step, one after the other. And at the end, the last layer will be able to identify that what object it was there correlated to. So for identification of a cat or a dog or any creature, we do not need the color information. We do not need the age information. We do not need the weights information. So if it is a cat, it's a cat. उसके weight से कोई फर्क नहीं पड़ेगा. So why should I need that kind of features? I will reduce those kind of features, right? So that is how we try to do it over here. So now, since you are aware, since I tried to make you aware of artificial neural networks and how deep learning and actually vision works, now let's try to come back to our sixth generation. So in sixth generation, as I said, everything is connected. So each and every mobile will be connected. Federated learning will be a key concept which is going to be executed everywhere. Sensors, IoTs, this mic is connected together. So when I switch on both the mics together, there is a beep sound, right? Very loud sound. That we can add some kind of intelligence over here. It will automatically switch it off or will cut out. That kind of intelligence will be added up. So this is the connectivity where augmented reality, virtual reality, or Internet of Things is going to be acted as a major key player, and that will change the industrial industrializations or healthcare, whichever you want to talk. So here now let's try to find out when the sixth generation is going to be expected. So sixth generation is expected to be launched in around, it's not visible there, 2030. So that's like researchers are saying, but since the technology is going to change, the infrastructure has to also be tweaked or changed. So it might take some more time, but in India, definitely it will not be in 2030, but might be in 2032 or so. And the features of this sixth generation will be like it's an ultra fast speed, which will be having 1 terabytes of transmit rate. Then the operations will be on terahertz. The latency will be less than 1 milliseconds. And of course, AI and ML will be a part of communication, will be part of your services in the network itself. So just to give you a glimpse or a recap, because since you are very young students over here, so you might not be aware of one generation, two generation, third generations. So here you can see just a graph over here. In your first generation, we were having only a voice. So your ANN was actually being proposed because of that only. So the ANN was being proposed to be incorporated into telecommunication companies so that the voice which is being broken can be rectified or will be reconnected or will be generated. So there, the voice was started from first generation, then the second generation SMS was started. Now you are able to send some set of, like I think 160 characters, I guess. That was the word length of your message. We started transmitting that. Then third generation was Java came into the bigger picture, so web applications started. In fourth generation, mobile application came into the picture. Now we have so many applications designed. In fifth generation, we are talking about IoT and smart city, virtual reality, augmented realities, and so on. So this is my fifth generation. What we are going to see in my sixth generation is everything will be autonomous, and you will be having this kind of multi-sensory XR. So now you are going to see that sensitivity will be there. So my mobile can sense some data. That data will be used for some kind of processing. It can sense the heat, it can sense the moisture, it can sense some other things, and then also can sense the threat. The person who is coming near to you might be, because on his mobile data, based on his mobile data pattern, we can my mobile data or my network can communicate or can sense that okay, that particular person is not good or can be suspected. So in that sense, we can create it out. So it is going to be a kind of like wireless brain for us. So your device will also try to help you for some kind of computing, but also will try to help you to protect you to from the person which is not in good. Okay. That is the brief description of sixth generation. So now let's try to see how sixth generation is going to work in terms of network infrastructure. So here we talk about dual network approaching. That means suppose we have this kind of IoT network, old or present network, and a distributed network, some kind. And there is some requirement of my IoT to perform some kind of operations over the old or previous network or present network. But since it is a separate private network, what we can do is they will connect to this sixth generation infrastructures, and everything is connected to the sixth generation infrastructure. That is the communication belt. So based on that, they will try to connect. They will try to build a kind of trustworthiness between these two connections. And similarly, between these two connections, there will be another trust buildingness. So whenever this guy requires some kind of assistance, this particular network will be part of that same network. It will try to help you out by creating a new services, new network, and then once the network service has been performed, the network will dissolve. That is what the concept says over here. So this will add more kind of flexibilities in this. And this artificial intelligence is not only going to help in this way, but also is going to reduce or minimize the wireless challenges. What are the wireless challenges which we have? The first challenge is like hard to model the problems. There are many problems which is very difficult to tackle it out. So for example, over the communications, we can have multiple packets floating. Might be possible that he and me together we floated the packet, and the packet was broken into multiple sequences. My first packet reached to that, but his second packet reached to the person whom he and me both are sending together. But since the packet sequence is same, maybe the encryption, because it's all trustworthiness, so there will be a problem of hard to modeling that, because identifying will be a difficult things. Similarly, the computational infrastructures or infeasibilities will be a problem. Dealing with a nonlinearity will also be a problem. So if we can add AI as a service, these all challenges will be rectified, or it will actually strengthen the network's performance. So wireless network will be more stronger if we use artificial intelligence part of all these kind of communications, right? So since we are going to use all this as part of communication, then what will my network will be? It won't be a digital world with some kind of real scenarios over here. It will be a kind of like a hyper connected. Everything will be connected to each and every. How can you visualize these hyper connections? Can be something like this. Hyper connected digital world. So here you can see machine learning, deep learning, visions, reinforcement learning, and NLP. These are the cup of my teas. So that's why I put it over here. But there will be many other technologies going to come into this picture. So this hyper connected world is basically connected to each and everything. That's what we are trying to project it out. Right. So why we need all this hyper connected world, everything connected to each other? Because in today or tomorrow, like even today also, devices are going to be increased abruptly, exponentially. So here you can see we have a fog devices, which is more than billions in current situation. In over days, over next 5 years, this will be even more increased. And once it has been increased, they are connected to the network. And once they are connected to the network, they will transmit some kind of data, right? And when they transmit some data, there will be always challenge of bandwidth and so on and so forth. That's why sixth generation is going to help us in that sense. Next, once we transfer it, say for example, there is some kind of limitations over this edge device, then we transfer to the fog device. Fog device will solve that problem. If it is not capable, then it will transfer to the cloud service, which is the even giant machine compared to that one. So this is how the architecture looks like, where step by step we'll try to dive in. So here the problem comes is like when we talk about cloud computing, everything is possible by cloud computing. Why should we deal it with edge devices and fog devices? But the problem is like when we try to when we have billions of edge devices, the data transmission will also be a billions. There will be lot of traffic on the network. So problem is like when we do all this kind of transmissions, there will be always a high latency, limited bandwidth, and also security concern. As I said, the example like transmitting the packets. So because of this, it's better to deal with edge computing, or it's better to deal with onboard computing. That's your edge computing. So we can process the data closer to the source. We can also, in that case, we can reduce the latency. We can improve the responsibilityness. We can also enable the real-time decision because now we don't have to wait for transmitting to and fro the data and the conclusions. We can also increase the efficiencies. So these are the things. So once we have this kind of facilities in our edge device, we can say that that edge device can act as a HPC computing. So as I said, like my mobile can act as a computing source for your mobile or your device. So that way we can say that HPC for edge device. So it's going to help us, and it will help in these kind of solutions. Like ultra low latency will be there first, enhances the reliability, improves the security, increase the scalability. Because you are not going to transfer anything, that means there is no security concerns. You don't have any kind of limitations. You can scale it up. You can have multiple billions of devices more, and they will be computed on there. So if you see it as a big picture, it will look like this. So you have a kind of like AI services where the automation, security, and radio communication is going to happen. You have a base stations; they will be having their own artificial intelligence. You have a user, that means your, say for example your mobile, you will be having your own intelligence in your mobile. Just to communicate between these two, we can have a kind of joint intelligence. My intelligence can deal with his intelligence, and then we can have a mutual understanding. Say for example, writing a proposal, and I need to write a proposal for interdisciplinary subject. So in that case, I'm also not expert for all these topics. He's also not expert for all the topics. Then his intelligence, my intelligence together come up with a very good proposal which is interdisciplinary. Similarly, we can think in this direction also. Local AIs for both UE and BS, we are going to have a joint AI. Similarly, if we take end to end, like means from one end to the other end, like your application servers, code networks, BS, UE, everything all together, we will be having kind of like end to end computing. So your end-to-end artificial intelligence will be aware of joint AI as well as also will be aware of local AIs, depending upon their requirements, not always. Clear? Sixth generation's concept is a little bit clear. What we are going to see in near future. So once this is there, let's try to focus into vision. As I said, we'll try to see how sixth generation is going to make a role in a vision things. So in case of vision, this is what we are going to see. Recognition, object detection, imaging, these are the challenges which we are going to tackle with in vision. So at the time of recognitions, why we need this kind of vision processing is because since we added multiples or millions of or billions of edge device, they will be also equipped with cameras, they will be also equipped with some kind of sensory things, the data. So once we transmit this data, the camera data or the image data are having the largest size, so computing is also costlier. So in that case, enabling a real-time processing on 4K, 8K streaming on the edge processing is a real challenge. That's what we are trying to do over here, a small set. So for that, deep learning came into the, you can get help of it. This example is very simple. I think people who are not aware of this will also be able to figure it out. Suppose I have an image. As I said in the previous case, that image will be a matrix. Matrix is going to be represented with some kind of limit. And this limit is going to be defined based on the hardware requirements. Say, for example, I have a mobile which is of 64-bit. That means I can represent a number from 0 to 2 to the power 64, right? That is the range of it. So if I need to represent 231, suppose 231 is there, I want to represent it. How many bits I need? Minimum how many bits I need minimum? 0 से लेकर के 2 to the power 8. Right. So that means each and every pixels will be having a roll of 0 to 2 to the power 56 because my range is from 0 to 2 to the power 256. Right. So I have RGB, so that means I will be having 3 into to the power 8 number of bits. Depending upon your hardware, this bit will be also changed. Suppose my I have a smartwatch which is only 16 bit. So that means it cannot handle this that big sequence. So in that case, I need to optimize it. I need to quantize it. So that is a different story. I'll talk about that in later feature. So suppose I have taken an image based on my DSLR, based on my mobile, based on my VGA camera. They will be having a different type of indexes because their bits are different. So I have 56, 231, 24, and 4. This is my image. Only 4 pixels I am taking for simplicity. And I want to classify into 3 categories. That is dog, cat, and sheep. So how I'm going to say that my input is fixed. I'm not going to change my input. My output is fixed. I'm not going to change my output because I want to categorize into these 3 categories. So to say that this is a cat image, I need to get a higher score at cat category, right? Then only I can say that this is a cat image. So what I will do is I will add a kind of W and a bias. This is W and bias is going to be multiplied with your input image and then we'll give you some kind of scores. That score has to be maximum for cat category because my input ground truth is cat. So based on that loss, I will try to update my W's and update my bias so that I can compute it. So to multiply with the input vector, sorry, with the W, I need to convert my image into a vector format. That vector conversion can be user's choice. In generally, what we do is we will start from the left top corner, zigzag, and then we'll create a vector. So basically, 56, 231, 24, 2. If you use this, this will be the score. But if you change the sequence, your score will be completely different. So that's how the network is. So we cannot change this this X. What I need to change is W and B. Such a way that I can get a maximum score over here. This is how my machine is going to learn. The changing or updates is basically my learning process. Got it? Okay, fine. Okay. So next thing is which I want to point out. In deep learning, there is a concept of kernel thing. Like say for example, I want to identify someone. Suppose I want to identify a person with a red muffler. So in that case, I need to have a kernel which is having similar kind of pattern. Right. So that kernel is over there. Then you can see that I need to identify or I need to extract the features which is horizontal. So given an image, I will multiply my kernel and I will try to extract the horizontal features. If I change the kernel, my horizontal features will be converted into a vertical. So my filter is changed, flipped. I will be getting a vertical informations. But here you can see that along with the information, this is correct. But along with the information, we are also getting some kind of values over here. It's not completely black. Black means 0. If it is not black, that means it has some value. And if it has some value, that will contribute into the decision making, like in the learning process. So what I need to do is I need to make these details black. So for that, I need to add some kind of nonlinearity over here. So for this case, I am using a ReLU over here. So you can see whichever value is not important, that is -1, will be converted into a 0. Right. So if I apply that nonlinearity over here, all the informations will be converted into a pure features and redundant features or irrelevant features will be removed out. That's how we do it. Other than this, there's also one concept which is called as a pooling. So in pooling, this is what we usually do. So have you seen this thing before? In a eye test, you might have seen this case. So can you figure out what is the big number? 24, 21, 21. How many 21? 74. 1, 2, 3, 4. Okay. Any other number? 24. 24 is also okay. 84. Any other number? So why do you have this confusion over here now? Color. And along with the color, your task is to identify the pattern. And our brain is not very good in that case. So what I can do is I can help you out, lower down your vision. एक आंख से देखने की कोशिश करिए. एक आंख से क्वेश्चन मतलब just lower down your vision, you will be able to get the correct answer. If not, then try to focus the bottom one. 74. The answer is 74. Correct? So this is what our brain tries to do. It tries to remove or filter out those information which is making me confused. Right? Say for example, if I want to call out, if I want to point out someone, and suddenly I forget his name, then what will I do? On the spot, my brain will say that don't call his name, just try to find, hey, hello, red colored shirt. I'll try to find out some kind of other features, right? So that's what our brain also, artificial intelligence also try to do this. It will try to reduce the informations in such a way that only key features will be highlighted. So the changes will be there. I will try to give you a simpler problem over here. In this case, is there any problem to identify any of the shape? Pehla wala? Any confusion? No? Again, the same problem. Is it visible now? Audible? Am I audible? Yes. Okay, fine. So I was talking about all these features, so I'll just skip these details. So these are some of the results which you can see where my multi-loss and progressive learning actually played into the concepts, and they include the baseline methods to extent. But there's another problem that if we learn these things step by step, might be possible that my brain, my network, or my model will try to recognize the current view more clearly, but forgets the previous view, or try to forget the previous view. In that case, what we'll try to do is we'll try to learn all the features together, all the views together with multiple networks, so and so, C1, C2, Cn networks. They are the same networks, but multiple types. Then we'll club them all together by using a max tool. That means we'll all the features from the multiple networks will be clubbed together to compute one single features, and that features will be guided by the cam, and then we'll be able to recognize that object. So that is one way. It will improve the recognition accuracy, but the problem again comes with it will be very costly because we have multiple. So if we have 12 views, then 12 models will be there running for the same task. Now let's try to see like how well the network will forget. Suppose in this case, how many of you are dog lovers? 1, 2, 3, 4, 5. Few of you. Yeah, good. So almost like 50% of you are dog lovers. So maybe you can answer what this dog is trying to do over here. He's trying to climb on terrace for. Okay, so here the dog is like trying to climb on the terrace, as someone said, but that's not the correct thing. When we change the view, that dog turns to a cat. Right. So here, majority of us were confused, like whether this dog is actually a dog, and if it is, then why the dog is trying to climb over there on the terrace. Usually, cat does that behavior, right? If you know that thing. But remember, I also played a trick game for you. I asked how many of you are dog lover. That means I tried to brainwash you. I tried to not to think about that this is not a dog. I tried to make you think that this is a dog, and then you decide. So that's how our features also going to trigger. If you have too many features, if I give you a question paper of 10 pages, and if I give you a question paper of only 1 page, likely what is the possibility that you will pass in first one and the second one? If I give you too many informations, it will be difficult for your brain to absorb those informations and then come to a conclusions. Right? There's too many details, 10 pages details, just to answer one single point. That I can do it in a one line problem also, right? So that's how we do it over here. And if I try to deal with this, how we are trying to deal with this, I'll come to that picture. So for that, we'll try to come to a drone topic first, as our previous speaker also was talking about the drone things. So we'll talk about these drone things in a little bit more detailed way. As you know, majority of you might have played with the drone. Yes or no? Then you can come to IIT Goa, then we can play with the drones. So there we have several sets of drones available. We are doing some kind of boot camp. We are also doing some kind of assembling, designing, programming, and so on and so forth. You can just try to explore it. So drones are basically categorized based on 6 categories: wings, size, payload capacity, range, power source, and motors. We'll talk about the first category, that is your wing. So different types of wings will define my drone. So one is your multi-rotor wings, fixed rotor wings, single, and hybrid ones. So in case of multi-rotor wings drone, we have this kind of anatomy where you can see that the drone has a frame where the motors will be fixed, where the power distributors will be fixed, and then a flight controller, speed controllers, and the battery. And in case of my task, we have a camera, that means payload. That is not necessary. Not every drone has a camera. If it is required for your task, you will be having a drone camera as a camera. right? So these are the common components which we need to have in our drones, every drones. And based on the number of wings, based on the number of motors, the drones can be called as a helicopter, tricopter, quadcopter, octocopter, hexacopter, hybrid flights, and so on and so forth. Right? Everybody will be having the same things. And if they have a camera, then the camera can also be of multiple sorts. One can be of Visual Studio, one can be of laser based cameras, one can be a monochromatic cameras. And if we have these cameras, why we have these cameras? We can have different types of tasks. One task can be your optical cameras that can be used for identifying or counting the head counts over here in the classroom, maybe 100 head counts over here in the classroom. We can also use IR cameras that can be used for night visions. We can use thermal cameras. Say, for example, in COVID situation, I don't want to come to patients close to the patients. Then what I can do, I can have a thermal camera, measure the heat temperature, and then based on that, I can decide whether I should take a hand with him or not. I can have a multi-sector cameras for example, if I want to work on the agriculture things, drone for agriculture, then I can use a multi-spectrum. Different fields will have different types of spectrums. So based on that, we can identify lidars for different kind of applications. Say for example, surveying and mapping the things. But if we use this kind of different types of cameras, there is four major criteria. One is your resolution, how good resolution your cameras are going to have. What is the view field, whether I'm going to see like this or like this, wide angle. Then the weight, because if the weight is very heavy, drone cannot lift it. Or if it lifts, then the drone flying time will be reduced. And the cost. Of course, you can't go for a LiDAR camera because it costs like more than 1 lakh rupees. Then your budget is not that much. So even if your task is to survey or to create a map, you will be going with some cheaper versions of that. Right? Cost is important. But if you are rich, go for anything. Okay, so there can be different types of drones for construction sites and agriculture. I'll just put it over here on the screen. Firefighting. There can be drones for construction, 3D printing, pattern deliveries, traffic monitoring, and law and order, water monitoring, and underwater drones also available nowadays. Drones can also be there in nanoparticles that they can go into the blood and do some kind of operations and then dissolve. So this drone doesn't have a motor. This will be based on the proteins. So it will have some kind of spikes, string, and it will drill the cholesterol, and then it will pass. So this is not my study. It's Harvard Medical School study. So based on these kind of studies, we also come up with some kind of drones which is feasible enough for us to play with. So this is 2000 drone, 2000 rupees drone. You can design it from scratch. They are very simple. You can deploy some kind of artificial intelligence over there to navigate it. Like some author was talking about PSO. So particle swarm intelligence can be deployed over there. This is complete video with all components and how to collect them all. It's available on our YouTube channel, so you can just go through and then design your own drones. And then once it is designed, you can just try to figure out like how it works. One mistake we have done it, like in this case, what happened is like we did not calibrate it very well. So instead of going up, it actually started skating. So there we added a barometer. So after adding a barometer, now it started working. There was an air wind also. Now it started flying, and then we were able to do it. But the stability is still not good. You can see that it's like a football. Like you kick a football and then it will bounce back. So here you can see that once it lands, it will take a bouncing effect. So based on that limitations, we come up with various other things, which is like GPS based. So you can lock your drone over the air based on that GPS coordinates, and then you can do some kind of automated surveying. You can also do some kind of landmarking and then let the drone fly itself, do the operation, and come back to your. So basically, we can add some kind of mission planners over there. Right. We can also do some kind of communication between, say, for example, I want to communicate with Dr. Pankaj, but he's not here, he's somewhere else. So I can convey through my drones, and then he can go there and then communicate. So I can have this kind of communications over there, and then do. But there's also a problem that when drones fly, they can fly very high or they can fly very close to the object. So here, you can see this object. Can you recognize this object? Can you recognize this object? Any blind guess? Dant hai? Teeth? Robot? So what you need more? Clear image. That means clear image means zoom out or zoom in. I'll zoom in. Tiger Cub. or you want more details, more extra features, more extra features, more extra features? Which one is more clear? This one. So that means feature is also useful, but previously I said if you have too much of features, you will be getting confused. Correct? That's what we need to make a balance, that we need to have features, but we need to have a limited number of features, but that should be good enough to recognize an object or should not make a confusion. I will ask you one more simple question. Maybe you will be able to recognize him or her. Just do it. जो बंदा है वो मत बोले बस. Who is that guy? Just do it. First of all, you need to find out where that just do it is written. In the center. Who is that guy? No, he is raising his hand by himself. Was it easy for you to recognize him? No? Same way, my network is also not able to recognize a person who is he based on his back view. So in that case, what we need to try to come up with is, I need to come up with multiple views. So I need to generate the multiple views of that person such that I can reconstruct them and make a key points. So these two persons, blue and white one, is this blue and white one? How can we make sure? Not based on the biological feature, but based on the non-biological features. Like the color, height, and these are the shapes of the body and so on and so forth. I can make sure that this blue is this blue only. Right? Just do it. If he give his t-shirt to someone else, might be possible that I will misclassify him that, okay, this is the one who is I was talking about. But based on the height and weight and width size, I can do some kind of minor details. So this kind of multi-view is like not limited to this view, but can be of multiple views also. So that the challenge is a big one. Okay, so this is one of the hostel area where we have logged the drones, and the drone is trying to find out some kind of pedestrians, whether they are following the proper path or not. And then based on this concept, we have carried it for traffic challenging, where our drone is able to identify helmets and no helmets, and then challan accordingly. So better wear helmets. Right. Otherwise, so we are also using drones for border monitoring, not real border, but a farm border. So I don't want to spray fertilizers to someone else's farm who doesn't have the same crop. Otherwise, it will be a difficult thing. So over there, this kind of algorithm is running live, and then border detection is happening. Another approach, another case study is what we have done is like we have also tried to come up with RGB and IR. So this RGB and IR is going to be blended together to form one single model, so that my model should be, or my drone should be able to also recognize a person in daytime as well as in a night time. Not only person but objects, multiple objects also. Right. This is one case. Second case is we'll try to move to some more applications so that it will be easy for you to connect, and maybe you can think of your future projects also. So sir was talking about smart cities. So we also work on this kind of things where not only smart cities but smart parking we try to focus on, because smart city everybody talks about it. Smart parking is something like this, where your system, your vehicle should be able to recognize a parking slot, free parking slot, and then tries to guide to that particular parking slots, because we should as a driver we cannot come out and then check the parking slot and then take my car there, because it's not very easy. So in that case, each and every parking slots will be indexed with some kind of IoTs, and that will be communicating with our cars in the 6 generations, and then they will be navigating that, okay, this particular slot is free, so navigate from there, take a turn, and then park it over here. And also at the time of parking, it will also sense the nearby objects. So in China, we had a chance there. So we visited one car. They actually stopped when suddenly there was a person. So even if you give a race, it won't work. So we also come up with this kind of approach. I'll show you that. So this is one of the way we can find out whether the parking has been properly done or not. We just use drones to monitor. Right. So we are now using a generative AI also in this case. So I'll just try to move to that specific things. This is how we are going to optimize my model. I think I'm running short of time, so I'll just quickly wind up. So we have a trained model. We try to optimize it, quantize it, then try to deploy it, and then try to test it. After getting the data, I will train my model so that I can make it more better, and then again quantize it. So the cycle keeps on. repeating. So we can actually test it in our real world. So these are some of the edge devices which you can use. So one of the examples I can show you over here is, you can see on the top corners, green color is safe and red color is not safe. So that means a vehicle which is in front of me, whether that distance is safe or not, the car will be knowing it. So based on this algorithm, the car will know that okay, that distance is safe or not safe, depending upon the car's speed. If my car is 10 km per hour, then 100 meters is safe enough. But if my car is 100 km per hour, that 100 meters is not safe enough, right? So that way the network will try to decide and then will give you the alert message. Raspberry Pi was being used for this kind of operations. So we also used our microcontroller for arrhythmia detections. So here you can see that we deployed a tiny ML algorithms in the microcontroller, and then we try to measure the details for any kind of alert systems. So this is all real-time things, right? So after this, we also use some kind of LLM based or VLM based basically to identify a person who is not having any or who is having some kind of bags or something carried. So you can see the detection is working only for those people who have some kind of handbags or newspapers or something. Then further we carried further for human mimicking case. So this is also some of that. So in one case it is like sidewalk, the robot wants to do a sidewalk, and in other cases like jump and turn. Right. So these are the two small tasks. These are the takeaways which you can take. I'll just give it to you. What you need to remember is human-centric. Whatever algorithm you are going to design, you have to always consider human as a main factor. You should not ruin that one. Right. So with this, I will stop over here, and I'll let you to ask any question if you have over here. And that AI has generated me this thing. So this is yesterday's picture. And it has recognized me from the front side and the back side. It has generated a 3D model of me, and then I added over here, just for your help. And these are my students who actually worked on this kind of projects. So you can also reach to them. The websites are available for okay, so if you have any questions, just let me know, or you can also connect me over my email ID. So for any kind of possibilities or interns or any kind of master programs, you can just look for. So if there's a position, we'll try to solve it. Yeah. So any questions from the audience, online audience as well as offline audience? Yes, please.
Are there any potential health risks in
Till now, it is still in, experiment purpose. So of course, if there is a radiation, there will be some kind of significance, but nothing is recorded on right now.
When 6G words were out there, when 6G was first implemented from 6G, words were out.
6G or 5G? 6G is not yet.
Not implemented, but words were out there for implementing 6G. So it was all over the internet of the potential health risks. Like, so it will be using it in some higher frequency.
Correct. Because 6G is using some kind of terahertz frequency, so which is like very, very fast. So of course it is very, very fast. That means it can be obstructed by a small obstacle also. So if it is very fast, like say for example radio waves and your 6G. Radio waves can go even longer distance, but 6G cannot go longer distance. So for 6Gs to maintain and do some harm, you need to have nearby objects which is strongly connected to 6G, and they can generate there or replicate it. So I don't want to point out anything right now because it's still in experiment purpose. But yes, if it is high frequency, the object which is nearby will be affected. But for data transmission, yes, we need it because nowadays devices are increasing. In my pocket also, I have 2 mobiles. Majority of the people will be having 2 mobiles or more than 1 mobile. So you can see that the scale we are going to increase nowadays. The edge devices are increasing day by day. In your house, you will be having another few sets of mobiles available. They are working or not working, but still they are radiating some kind of. So in developed countries or developing countries, we definitely have this kind of challenges available. But as a health hazard, we do not have any kind of serious things happen. But yes, brain stress, anxieties are there recorded, which maybe in near future can be rectified. We can have some kind of noise canceller like we have. We can also cancel out the signals, waves, and so on and so forth. But that is a matter of. Yeah. Any other questions?
Firstly, thank you for the very informative talk. Sirs, as you are working in the 6G aspects related to vision and 6G, as we understand, is a very heterogeneous kind of a network comprising of number of technologies. So, since I am working in the communication-oriented domain, so I wanted to know that actually, so one of your earlier slides you showed regarding the spectrum as not a continuation, a different question actually. So, terahertz, like in the communications domain, actually, terahertz as of now is not the finalized spectrum for 6G. Terahertz is one of the primary contenders. Millimeter wave is also there. Even sub 6 gigahertz is also there. But as we know, as we increase the frequencies, the target latencies you have already pointed out, less than 1 millisecond for 6G. So I just wanted to know that are the researchers in the other domains like vision and signal processing, are they also keeping in mind while working on the researches the latency levels, because they might ultimately have to incorporate those vision systems not in terahertz but rather either in millimeter or maybe in sub 6 gigahertz, for which again the delays will be different. So,
Definitely, there are research going on there. Definitely, there is a research going on all these directions, but majority of the people or majority of the community is going towards the terahertz because we have an image which is nowadays, as I said, pointed out, 4K, 8K, and so on. So data is very huge. So millimeter might not be a suitable option. I mean, of course, it's a matter of experiments and research. It's still going on. People are more biased towards the terahertz because they want to compute very fast. Otherwise, the latency will might be a question. Yes. Yeah. Good. Thanks for the good questions. Yeah. Any other things? Online participants. Okay. I think there is no question. So. You can put your laptop here.
Thank you so much, sir. Uh, Thank you for expanding our perspective on the future of 6G and AI. And University guest house for lunch. We will be having lunch from 1 p.m. to 2 p.m. Please return on time for the next keynote session. Yes, sir. At all. Thank you.
Uh, the session will start shortly in 10 minutes. I request all the online people available to stay.
Anuj? Anuj, am I audible to you? I think he is not there. He's not here. Nobody is replying.
Bro,
Microphone, sir. Sir, mic use कर लीजिए.
Hello. 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 Dr. Anuj, can you hear me?
Sir.
But he can hear, right? Yes. Okay. Maybe he is then not nearby. Yeah, hi. How are you? Hello.
So you can come here. A camera on कर दो.
Yeah, hi Jonathan. How are you? Can you hear me?
I can hear you, but the quality is not so good. Can you hear me?
Yes, we can hear you.
Okay. Yeah, yeah. I see you now also.
Yeah, so hi. Good to see you.
Nice to see you, Shitala.
Yeah, but it's not so long. 2 months.
So, then it's webcam.
Yeah. Am I visible now? Yeah. Okay. So we'll start in 2 minutes. People are coming in.
You can just go there.
So we just wanted to check like the mics and other things are working or not. So we'll start. We'll try to brief your biodata first, and then we'll ask you to start your presentations. Okay.
Wait. Why I cannot share the application? Wait a second.
So there is a icon with arrow mark. So there you are talking. Yeah.
Wait a second. Then I need to. How do I share screen here?
So on the bottom side you can see my camera, and then there is a computer icon with up arrow.
Yeah, that I know, but there is different kind of. Let me. Okay, then I have to maybe do something like this.
So let me bring it over here again.
I don't understand. Oh, window. Okay, I share the window.
Yes. You have to share the window. You can select your window or you can select entire screen.
I cannot share.
You cannot share? Wait, you
No,
have the right, right?
the button is not active. I don't
Uh,
understand why.
no,
I
we
can
have
wait.
we have
Okay, okay. I have to select it. Okay, 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 okay.
yes. You just click on the icon and yes, we can see your screen. Yes,
All
yes, we
right.
can see your
Yeah.
correct.
Okay, then.
Yes, yes. Okay, so we'll start in 2 minutes. Yeah, over to you.
Yeah. Just let me know when I can start. Yeah.
Yeah, yeah, sure, sure.
कैमरा कैमरा रहने दो कैमरा रहने दो अरे तो बस में वहाँ पे बैठ सकते हो बैठ जाओ सेवा टाइम Enjoy. Move back to honest after. Huh?
In 10 minutes or no, 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 just ask him to click the stop also. The stop there, hide, hide. He has to click that hide. Oh, yes, sir. This is something you see. Yes, sir. Or with the position will start. And ask him to click that hide.
So we are going to start now. Welcome back, everyone. Can unmute yourself and hide your hide button.
Click the hide button.
Click the hide button, please.
बीच में ऊपर दिख रहा है सर का स्क्रीन
In for the screen, please click the hide, sir. Hide, hide.
Click the hide button, so please.
Hello, Professor Jonathan.
Yes.
So we'll start now. So we'll read your biodata and then we'll start your presentation. So before
I cannot hear you very clearly. Can I start now?
Sir, no, I will read your prior data first. So, just a second. We are about to start shortly. Yeah, yeah. So, welcome back, everyone. We have Mr. Professor Jonathan Chan with us. He will be joining us online. He is a part-time professor at DUB, focuses on hyperspectral remote sensing and advanced machine learning or deep learning. His research centers on satellite image enhancement and applying algorithms from tensor theory and sparse theory to remote sensing data. His career includes work on NASA global mapping projects using machine learning and European projects for humanitarian demining. Currently, he focuses on environmental applications like ocean plastics detection, biodiversity mapping, and climate change mitigation, and is actively involved in the IEEE IGARSS conference on super resolution. Sir, you may continue now.
you can cross it, Professor Jonathan. You can cross that. You can cross
I
that.
can.
Cross.
Yeah, I want to take out
Yes,
this
just cross
dialog
it.
box. I don't know how to.
Just click
I
on
can close
cross.
this one.
Yes,
If I close it, I will still be connected.
yes, yes. You will be connected. Cross
Okay.
that. Yes.
All right.
You,
Okay.
can you just also hide that? There is a on the bottom side. There is a Google Meet stop share. You can also hide it.
Like
Yes.
this. Okay.
Yes.
Yeah.
Now good to go. Okay, sir. You can start. Over to you, sir.
Okay. All right. Thank you. Thank you, Sritala and colleagues. Good afternoon. I hope your stomach is not too full. Otherwise, it will be difficult to follow a talk. Um, thank you for the introduction. So I will get onto it. Uh, I will share with you the title Super Resolution Enhancements for Hyperspectral Imagery. Uh, I will spend some minutes to explain hyperspectral data and mainly from the perspective of satellite images, mainly from the satellite images. Um, the potential of a hyperspectral images for different kind of applications, the market related to hyperspectral sensor and data. And then obviously nowadays we cannot do without AI. We have to talk about the influence of the development in AI in different kind of implementation of classification, modeling using hyperspectral images. And then after the introduction, then I will talk about the one very specific topic related to super resolution enhancement. For satellite image, I think nowadays we are very familiar with. So the animation I'm showing is just that for all the satellite images we are doing is from about the Earth on the orbit 700, 800 kilometers away. And here I'm showing the Landsat missions. This is the one of the legend, the first global data that has been gathered since almost half a century. And this is the benchmark of global Earth observation. And as you can see, that it would take some time in order to cover the whole world. In this case, some years ago, it would take almost 10, 11 days. Today, there are collaboration cross-Atlantic with the Centennial mission, mainly the Centennial 2, if we are only talking about the passive sensor, the multispectral data. So with the collaboration with the Copernicus and then the Landsat mission, I think now we are narrowing down to maybe a couple of days. And then also with the side looking, we have a repeating time much shorter. So what we are dealing with this kind of data, some background that to the left-hand side, you will see the schemata of what we are trying to do with the passive sensor. So you see a sensor up there in the orbit, and then what we are trying to do is to acquire or measure how much of the incoming irradiance or energy coming from the sun is being refracted from the Earth's surface. All right, so we are trying to gather this data from at different wavelength. And obviously here you can also see there are some atmospheric interference. So the ultimate result we want to have is the surface reflectance. Using the surface reflectance, we are able to use it as a kind of a fingerprint or what we call a spectral signature to define different objects on the Earth's surface and to facilitate monitoring purposes. And in this figures, we will see there are a lot of interference in the atmosphere. What is incoming will at different wavelength, there are different absorption window. You see the solid light, then you will see a lot of ponder with ozone, O2, H2O, etc., etc. So that is the atmospheric interference because of this moisture, water vapor, as well as different greenhouse gas. So when we design the sensor, then we have to maximize the signals we are able to get. And obviously, this would be the visible range between zero point 0.4 and 0.75. This is the visible wavelength with the highest transmission. To the if we look at the x-axis, those are the wavelength, and then you will see this transmission rate or the intensity of radiation will go lower and lower when the wavelength is long. And in fact, after 3 micron, then the signal is very low for passive sensing. So what we for optical remote sensing, we are always focused uh, for visible part, near infrared, and then short wave infrared. Short wave infrared, we are referring to a 1 micron to 2.5. So after that, then it would be, longer wavelength in the microwave section and radar, etc., etc. Yeah, again, to reiterate this terminology, which is what we are scanning to the far left-hand side from 0 0.4 to 2.5. That is the most of the optical remote sensing we are targeting. So that include the visible, near infrared, and short wave infrared. But with the Landsat mission and other remote sensing mission, we are also interested in the thermal infrared. And here you will see the two red block, 3 to 5, 8 to 12, sometimes 8 to 14. This is the thermal infrared. The process at the thermal infrared is not refractance, so it's the kind of a emissivity we are measuring, and scientists or engineer will use this as a inferral or proxy to understand the surface temperature or the temperature in the city canopy. So this will be to define where in the wavelength we are trying to sense. So first, if we look at the top left-hand side, you see these little color blocks. They were the spectral bands carefully designed by the Landsat mission. So first of all, you will see 234 for Landsat 8 and 9, 234 the visible band, and then before we have ultraviolet. And then band number 5, you will see this is the near infrared. 9 is in the absorption zone. Band number 9 is for detection of clouds. Then we have two bands in the short wave infrared between the 1000 and 2500 nanometer, 6 and 7. And then there are two bands in the thermal region. So these are you can say the state of the art of open source, openly access satellite images. So we have 11 bands from the NASA Landsat mission. Yeah. So with that, we define this kind of data as multispectral data. So you see that the design is not continuous, so it avoid a certain absorption window, and then they were sampling, kind of a sampling within the wavelength that we will say can maximize the information acquisition. So now if we take a field measurement, so if we look at the lower left-hand side, so this is a person who is carrying the field spectrometer, and then the bar that he is holding with a pointer, that is an optical sensor. So this sensor is a kind of ground truth we measure to match with what we measure from space. as this is a field measurement, you can see that the spectral resolution is really high. So it is a measure in all the wavelength. If you look at the graph on the right hand side, this is the measurement of a typical grassland. You will see it's like a curve, but actually it's not a continuous curve. It is a point. It measures at 2,400 times. And then if you put the dot on the graph, on this graph, and then it looks like a curve. It is not a curve. It's just 2,400 measurement. And then we also see in 1400 and 1900, these are the absorption window. Actually, these are actually we don't have any reflectance from the Earth's surface. Those are just noise. Now on top, we have established the understanding of multispectral. Now we go to our topic is hyperspectral data. So hyperspectral data is a continual acquisition. And then if for 400 to 2400, then we are talking about contiguous bands over hundreds of bands. So it is a continuous bands. So it compare with the multispectral data, there are 11 bands. We are talking about over hundreds of bands, depending on the sensor, depending on the spectral resolution. And in this case, it's the average sensor. We have 224 bands. And with 224 bands, we are able to kind of simulate or closer to what we have in the ground measurement. And to the bottom right hand side, if this is a sample signatures from a kaolinite, a kind of a mineral outcrop, and then you will see that this is also like a curve because we have hundreds of measurement. So makes it much closer to what we are measuring at the ground level with optical sensor. So why are we using, what is the advantage of hyperspectral data? So in this slide, we want to compare the signature we acquire for multispectral data in the top, the lens set. We have, in this case, we have 1, 2, 3, 4, 5 from the earlier lens emission. Let's say that now if we have a lens at 9, we have 11 measurement. If we increase the number of bands, here we show that from different sensor we have increasing number of spectral bands until the average we just saw 220 something bands. And then you will see these peaks and troughs are the sometimes very important features to define an Earth a surface object. And obviously, the more bands we have, then the spectral information is much more powerful compared to multispectral data. So in this case, we can say that for anything, for any application, we do application in terms of monitoring the Earth surface, environment, etc., etc. Anything multispectral data can do, hyperspectral data presumably should be better because it's a much more powerful and much more spectral information. And that's why it is more advantageous if we can have hyperspectral data. So just a little bit background on how we can prepare a sensor for hyperspectral data. And obviously, if it is so good, everybody would like to do it. But it would be a little bit more difficult in terms of a sensor design. So here is a graph that we all know how we can use a certain diffraction grating to separate different wavelength from the some kind of a sensor design, and then we will have to have a computer for this digitalization of the analog data or signal we have. For hyperspectral data, if we are talking about the full stretch from 0.4 to 2.5 micron, then normally we have to employ two sensors. For the visible and near infrared part from 0.4 to 1 micron, then we always use silicon because of this material is good for the sensitivity or the signal to noise ratio is good enough, very good within this region. But if we are talking about over 1 micron, over 1,000 nanometer, then silicon is not as good. And normally we have to employ another kind of material like the indium gallium arsenide. So this is for specific from 900 to 2,500, or sometimes it's shorter. So if we are talking about the full stretch of optical remote sensing with hyperspectral data, we always need to have a two sensor. So this is an illustration that the typical silicon, and then this sensitivity in terms of A per W watt would be increasingly lower the what we have the signal. And this is why we always have two sensor, and then in the measurement we always have some kind of overlap wavelength so that we can harmonize or collaborate to harmonize to have a full signature from 400 to 2500. So that gives us a little challenge if we are getting from satellite hyperspectral. So this is one illustration. If we go to a company, here it is a Nordic company where they were just employing the hyperspectral on a drone, and then they have to use a two sensor. In this case, this is for the visible near infrared is the V1240, and then for the short wave infrared, about the 1,000 nanometer to 2,500 is a S620. So it's always two sensor. So this is just an illustration the complexity of acquiring full stretch data. This is the prototype in the early 90s to the year 2000, somewhere in that time. It is a Belgian Swiss collaboration to define a high quality or the state of the art hyperspectral sensor, which is mainly for as a demonstrator, which is used in many airborne missions campaign. So what I want to show is just the time that they need to do in order for this sensor to materialize. So it was initiated 91, and there were different discussion with the European Space Agency able to fund. After the funding is confirmed, then the concept was identified 98, and then all the specification, all the engineering phases, when it come to being, it was already the mid 2006. So it takes quite a long time. And when it was the design phase is finished, and then there are also other steps to approve all the quality. At the end, it only became operational until now, since 2011. So it's a very long process. Between 2000 and 2010, there were a lot of testing, a lot of projects. A lot of projects were using the data acquired by Apex to test whether or not the quality of the instrument is good. And luckily, at the end, it was quite acceptable. So that is for the Apex was a prototype for airborne sensor. And then now I want to illustrate the time that is to design for a satellite hyperspectral. So this is an NMAP from the German Aerospace Center. So the nmap short for environmental mapping and analysis program. This data is available to everybody. You can just write the proposal and then to get this data. So the idea was initiated in 2006, just about the time that the Apex is launched, getting data. So when the sensor was final, we were waiting. There were a lot of delayed. When it was finally launched, is 2022. Uh, not too long ago. Now we are in 2025. So 5 years ago, it was launched. Sorry, 3 years ago it was launched. But even though it takes so much time to prepare this, and it was successfully launched, it the commission time is only 5 years, because the machine itself is like a human being. Over time, it will degrade, and then it is not supposed to last forever. Okay, so this is just to give you a little bit the background of the time that is needed in order to have a Earth observation hyperspectral full stretch sensor. And then in the middle, this graph is for colleagues or audience who didn't have remote sensing background. In fact, there are different level of processing that is incorporated into the implementation. So there are the raw data, and then it has to be pre-processed to energy level. That the unit is radians, and then this has to be corrected to the top of atmosphere reflectance, and then at the end, the ultimate at 2A level, it is the after atmospheric correction is the Earth surface reflectance. So there's a lot of not just the hardware, but also the correction, geometric correction, atmospheric correction that is embedded in this whole program. So for all this effort, of course, there must be some good that we can take out of it. And I will show very quickly some application that is rather useful. For example, in this case, it's a very um, conventional application, detail surface mapping. Using hyperspectral data, we can analyze the age of the road, find the material of a different roof material that is for a city planning or a smart city, etc. And then in the bottom, you can see that if for figure A, if we are using multispectral data, we probably can see only one color. But if we are using hyperspectral data, using forced color composite, we can see that in fact the rooftop is built with a different material that is contrast in different color. Again, for detailed land cover mapping, hyperspectral data can help us to identify much more different species of vegetation. To the left-hand side, it is one project I was involved using airborne hyperspectral data to identify certain grassland. For us, they look probably the same, that we will go picnic, but there are certain grassland for ecologists. They would define certain grassland have better environmental benefit. Okay, so they call this biological valuation map. So in this case, we are classifying 16 class, 6 class, different kind of grassland, from more homogeneous to more diverse, more biodiversity, and then 10 class of trees. So to the right-hand side is just another example and legend of using hyperspectral data to define many different kind of vegetation. Mineralogy it is another common application of hyperspectral data. Due to its absorption windows in the shortwave infrared, they are very useful for define certain material. In the legend, on the left-hand side, you can see the kaolinite, calcite, cerussite, dialsite, different kind of minerals. These cannot be done very nicely with multispectral data. To the right hand side is an example of using hyperspectral data to find the oil spill, different percentage of oil spill in the sea. Then recently, hyperspectral data is also used in the shallow water research. To the left-hand side is some archaeological residual. In the past, researchers are using hyperspectral data. To the right-hand side is some work that I did with hyperspectral data to see if we can define the different water depth, different habitats in shallow water, and that is the something in Maldives. Hyperspectral data can also be easily fused with other data such as LiDAR. We know that LiDAR data can help us to have a 3D reconstruction of the Earth's surface or objects. So here we can easily, if we have a map of a different species, we can have a very good visualization with a different class of trees. To the right hand side is also to assess the health situation or if there is a vegetation stress. Yeah, again, this is the 3D reconstruction of classification. So now we would like to ask, so if hyperspectral data is so good, can we have it? Actually, there are not many. So far, there's not many. For open access is only Prisma. I highlighted Prisma full stretch. There are 237 bands, and it was launched in 2019. Normally, it's also 5 years commission, but now they are extended. NMAP, Prisma is the Italian space agency, and NMAP is from German's aerospace center. I just mentioned, so it will supposed to last until 2027. So there is a limited availability of this hyperspectral data, let's say from space. In particular, if we are talking about a full stretch from 0.4 to 2.5. Now I have to mention some private company, in particular Pixel. Pixel, probably some of you have heard, it is an Indian company, and they have launched already six satellite, high definition hyperspectral data from 5 meter resolution. The one that we mentioned, Prisma and MMAP, the spatial resolution, the ground surface distance for each pixel is 30 meters. 30 meters. The 30 meters is actually following the benchmark legend of Landsat. Landsat is 30 meters, and then so they want to have a continuation and easier to compare. And also for global map, for global coverage, if you have a too high spatial resolution, there is also the data volume that you have to deal with. Now for this private company, Pixel, they are having hyperspectral data. I believe it's full stretch at 5 meter. So there are much more details that is available. I think already we can buy the data now. Let me see if I have one. Yeah, this is the Pixel. So that you see the satellite is very compact, very small. It's around 50 kilogram only, and it was launched. It's a constellation. There are 6 of them launched at a low Earth orbit at around only 500 kilometers. So it has 135 spectral bands at 5 meter resolution, and with a swath or coverage of around 40 kilometers. But this you have to pay. You have to pay. If I'm correct, then for each month, I think you have a certain coverage at maybe less than 200 US dollar. So you can multiply it yearly, the license, the different license. I think there is also a certain security. You have to pass a certain security check and then you can get this kind of data. So we have something that is new, really, really new. It is the updates is as August, so it's only this year. All right, so I present all the background. I am sorry that I think the time is really, really running. Now I have to go to the AI part. I put the deep learning. So today we are using AI very loosely. Uh, so I would say that the deep learning is part of machine learning. And if we are doing machine learning, I think we can also claim that we are doing something related to AI. And obviously, the deep learning has been really applied to processing of hyperspectral data. And this is one kind of a recent paper by Professor Hong, um, 2024. So it is using a foundation model to process remote sensing data in different dimension. You can, in theory, you can use multispectral data as input. You can use hyperspectral data as input because it's dealing with tensor, so it's three-dimensional. And then it is pre-trained. It's a generative pre-trained encoder. So they call it spectral GPT. So in theory, you can actually use this in any remote sensing data and for different purposes. To the top right-hand side, you can see some application like single label. So it's a classification. Single label is a 01, and then multi-label. So it's you can see these 5 classes, or segmentation or change detection. So these are pre-trained model. The input is actually unlimited. You can use any remote sensing data for to manipulate any kind of data. And the model is based on 2 kind of data. Top left-hand side, you see the FMOW stands for functional map of the world. There were millions of images gathered from different parts and then combined with the big Earth net. And these are the distribution of the data. And we understand for deep learning model or they call it the foundation model or spectral GPT. You need to have a lot of data from different part of the world. I think they are doing really, really well. Okay, so they use close to 1.5 million images in this training. Of course, it's still very initial stage, but I think this is the trend. We have to this data set is open. I think all of us can access, but not hyperspectral data, not hyperspectral data. And then the other very recent presentation. So the title is AnySat, One Earth Observation Model for Many Resolution Scales and Modality. So it was presented in the European Geographical Conference. And then you can see that similar approach. So the model actually, you can use any very different kind of input images, multispectral, hyperspectral, and then it can, as you said, any set, and then you can do land cover mapping, crop classification, deforestation detection, flood segmentation. So you just input any kind of remote sensing data, and they also have many different kind of input data for the training. So the AI, the deep learning model or GPT model is already have a lot of common data set. All right. So what it need is the fine tuning. Now we are talking about the fine tuning for specific application. So there are challenges. So I will not go through it. Obviously, you need a lot of computing power if you want to implement a certain AI approach. The coverage if we are talking about hyperspectral data, is still not really available for the global coverage. And if you are talking about temporal resolution, is still very lacking. And looking ahead, I think the general trend, as I mentioned before, is towards a scalable, real-time, and vector hyperspectral system. So there will be a smaller sensor, and then a constellation of sensor, not just one, but maybe 10, maybe some mission have over 100. And this it would be there will be embedded the system that will do some initial task classification, segmentation, etc., etc. So this is the background in terms of AI development, as well as the hyperspectral data development. So there is one. Now we go to the main issue we are facing now. We have hyperspectral mission. We mentioned Prisma and NMAP, but they are at 30 meters. So we will not have higher resolution data in the near future. I believe there will not be any data um, at least another 10 years. That will give us more than 30 meters global coverage. So this to the right hand side is just to tell us future mission. On the X, that is the number of bands is locked. So it's over 100 bands, though so and so and so. But in terms of the spatial resolution, if you look at the y-axis, it's also locked. So it is about 30 meters. We do not have something that is a finer resolution. If we are talking about open source, that we don't have to pay. So over the years, there were quite a lot of effort to see if we can have a way to break through this kind of constraint. So this is a one early, like a classical paper, which is over 7,000 citation, is from Park and Khan. It's a super resolution image reconstruction, the technical overview back in 2003. So they were using some kind of interpolation to enhance the spatial resolution. So this is one classical non-uniform interpolation. But I will not go into the detail of this technique, but just to show there are some way that was proposed in around the 2003 2005. That is the first how to say the first effort to deal with to try to apply some of the super resolution method in a satellite image. And this is one example. If we have a low resolution image, let's say we have P, a number of a low resolution image, and we can use some kind of method called iterative backpropagation to define or to reverse engineer to find the hyperspectral data. Basically, there were three. If you look at the top left figure, and then this was the flow chart to to describe the relationship of the input low resolution image and the expected high resolution image. So it will go through the process of undersampling, the blurring, which can be defined as a Ponspat function, and then the warping is the translation rotation that's mainly related to co-registration. So these are the classical approach for super resolute enhancement. And for the IPP, the iterative backpropagation, it is a ill-post, and then the solution can be many, and that's why there was also a total variation approach to put constraint so that your solution is a little bit more stable. We were using input Chris Popper satellite image. They have 63 bands, but it is only between 0.4 to 1 micron. So it's not to the shortwave infrared. It was a demonstrator. At the land mode, it acquired less number of bands, but at the higher resolution at 80 meters. So they were acquired at plus and minus 30 degree and plus minus 55 degrees. So we were using this as the input low resolution image. The first is the bicubic, it's just upscaling. And then we apply the non-uniform, the IPB, as well as the total variation. So this is the early effort to apply some standard super resolution method. And then we compare the before enhancement and after enhancement. So whether or not the spectral signature, you see they are still quite the same. So that means that the super resolution has not put in error. And there are other methods that was around 2005. Now we are approaching the 2015, 2019. And there were a lot of development. This one slide is to show the possibility of using fusion enhancement. The fusion is to make use of high definition multispectral data. That is in the middle, Centennial 2, 10 meter, fused with a hyperspectral 30 meter. And then the output is a 10 meter hyperspectral data. So this is some kind of extension of a pan sharpening. There are different way of this fusion. The one we were showing is SFIM, or smoothing filter-based intensity modulation. If we look at the recent development, so this is a one paper, advancing image super resolution technique in remote sensing. So this is going to be published, but it is already available. They see this very, very big increase in terms of research paper in image super resolution technique in remote sensing. So they also quote a couple of paper I did with my student before. And the latest one is 2019. So you see this a big jump in super resolution enhancement. That means there is a huge demand in the market, as it is also a very exciting and hot topic in remote sensing. And in their review, they put this into supervised, like machine learning, unsupervised, supervised. And then for each strategy, there were traditional, and then you can see, if you look at the right-hand side, unsupervised, you can see traditional that include interpolation, POCS, IPB that I briefly mentioned. And then there, of course, there are deep learning based. And then for deep learning based, there are many different kind of neural network based model, and as well as to the left hand side, the traditional supervised method. And then you have CNN, you have GAN, generative adversary, different kind of a model transformer, etc., etc. So there are quite a lot of momentum in terms of image super resolution technique. But here is in remote sensing in general, it does not, it include also hyperspectral, but not just hyperspectral. So there, of course, there are many challenges. Let me see if my time is almost up. The challenge is, well, there are high demand. We have more hyperspectral data, but the full stretch, we have a quality issue. There are also no regular revisiting mission compared to Landsat Centennial. They are not existent. Normally, we have to book, we write a proposal, and then they will do the revisit. Even though it is possible, but it is not, how do you say, it's not very convenient. A very, very solid validation. The ground measurement remain a critical challenge. We are critically lacking of any validation to improve, to verify that the enhancement method is very, very good. So in general, scientific community are skeptical of the enhancement approaches. Maybe I should stop here.
No, sir. Actually, we are a bit short of time. You can take 5 minutes if it's possible. Hello?
5 more minutes.
I cannot hear really well. Can you repeat?
Hello, sir. Can you hear me? Hello?
Can I continue? Can I continue?
Can you hear my voice?
Sir, can you wind up in 5 minutes if it's possible? We are actually running out of time.
You can tell. Like what? No, Professor, can you wind up in 2-3 minutes? Can you conclude your presentation? Can you
Sorry?
hear my voice?
Yeah.
Wait a second. Because I cannot hear you.
Just take 5 more minutes. That's enough. When you want to
Could you please wind up in 5 minutes?
No, no, please wind up. Don't. He is ready to go. Please complete back 5 more minutes, sir.
Hello.
Hello,
Sorry,
sir.
I think I just talked too much. Can I cannot hear you. Can you yeah, can you
Can,
repeat?
So could you kindly check the text?
can you
It's
hear
not
my
very
voice?
clear.
Yeah. Sir, we have sent a message. Your talk was very, very much interesting. We have listened. So now I think you can take 1 or 2 minutes for your conclusion, sir.
You mean I can continue?
Yeah, no, no, conclude, sir. Conclude it. Please conclude.
5 minutes.
Yeah, fine.
Okay, I tried. Sorry. Okay. But not much more. Indeed. Let me again share my screen. I have to share my screen. Can you see me?
Yes.
Can you? Okay.
Yes. Visible.
Yes.
Let me. Okay. I will just go really fast. So there are some example that we were using super resolution enhancement to see if we deal with some real problem. And one of the initiative in Europe in the last few years was a plastic, marine plastic, in particular those were in the food chain. So we understand the microplastic is a very serious problem. And in certain choke pond, you see this not very nice picture about this uh, all this rubbish. We throw our rubbish without thinking sometimes, but actually they will end up to affect us. Um, so there were campaign to ask for remote sensing scientists what we can do. Can we help with this problem using satellite data? So it's a very big challenge, and obviously there were some objection about more likely in the mouth of the river or maybe coastal area. And then how these plastic are being transported with the ocean current, climate, etc. And then to see if we can monitor with some countermeasure. And then I was actually proposing using hyperspectral data, and obviously the hyperspectral data we have cannot find because of the 30-meter resolution. So I was proposing using super resolution hyperspectral to see if we can do something. So first of all, we were proposing some method. We did some earlier. I think it's 2016, 17. The first paper we do with hyperspectral enhancement is already 2000 maybe 13. So this is already we adapted to use CNN base, some of the uh, 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 more advanced approach. And then we have two branch. One is focusing on the pixel, the signal, the spectral signature, and then the other on the two-dimensional on the image level. So to enhance sorry, I mix up. Not this one. This one is actually the fusion. Sorry, I will talk about that in another method. So this is actually a fusion. Remember, we have a coarse resolution hyperspectral data, and then we have a high resolution multispectral data. So this is a CNN model to fuse them, and then we have a high resolution hyperspectral data using CNN model. It is, I mentioned about the difficulty of getting ground truth. So this is one the project they mimic as they put the usually find the plastic waste. Uh, so these are really the plastic bottle. You see the circular object, and then they also use some wooden plank to have another object. There are two objects somewhere in Greece. So to the left-hand side is a 30-meter resolution. Now, if we have hyperspectral data, then in Prisma, there is a one panchromatic bands, we is a 5 meter. So we can actually use a pan sharpening, and then we go to 5 meter. But to the right-hand side, we have a multispectral data worldwide. That is a 2 meter resolution for multispectral. And then we can go even more detail at the half a meter resolution with a panchromatic band. So we were trying to push the limit. So from 30 meter to 5 meter, and then we fuse the 5 meter hyperspectral data with the fine resolution 2 meter. And then we convert the high resolution into half a meter. And this is the sum of the result of these two objects. And to the left-hand side is the plastic mesh, and then to the right-hand side is the wood planks. So you can see that, of course, there are some difference when we have the 5 meter pan sharpening. But when we mix with the multispectral data, I think actually the discrepancy is less. Okay, so we are still investigating, but there are certain possibility. You see the spectral signature is actually, we still have the similar shape, even though the intensity is a little bit different. So that is some example of pushing the limit of spatial resolution with multispectral data and fusion. So that's a new perspective, and the new perspective is not spatial enhancement. The new perspective is spectral enhancement. So instead of dealing with the spatial part, how about I can turn a multispectral data into a hyperspectral data? So if you give me a free RGB band within a certain wavelength, can I interpolate and make it 200 bands within the same wavelength? And this is actually what we did in 2019 paper. So it is called spectral enhancement. So based on the sparse theory and certain more improvement using a spatial preservation strategy, we were actually enhance the multispectral data to hyperspectral data. And what you now see is actually the result. So we input about 13 I think 11 bands from Centennial 2. And then we use the sparse theory to over 160 something bands. So what you are seeing here is the result of spectral enhancement or or spectral super resolution. I would already show you the result, but this is something that we merge with some real lab data of the common found marine plastic, and then we merge them into with water because it's marine, and then try to use a mixing to see if we can find the error rate of different kind of marine plastic. So the results are quite good for most, except the three class. Some class are more difficult: gray clothes, green rope, and transparent foil. But this is simulation result. So this is not. There's still we need the more investigation. So the most current work we are trying is to apply the first prize in a conference competition. That is the MST++ or multi-stage spectral wise transformer for spectral reconstruction. So we have data from different part. This is a very small project I do with some of my PhD students, and these are the input. So now it's entirely different. When we are using transformer, we just put the input and the output from all the data we have, and these are the some of the simulation results. So this is the last line. Let me see if I can. Yeah. So you can see these are the results that for the these are 224 bands. We input a multispectral, and then we have the very visible near infrared from band 1 to 90, and then shortwave infrared band from 91 to 224. Yeah. So these are the result of comparison between the real Nmap data and our simulation. And then you will see that the grassland, bare soil, trees, they are quite good, in fact, quite. But surprisingly, we have some differences in water. Building, yeah, we know that because the building environment is the intra-class, the variation is very big. We know that the simulation is not so, can have problem. But water, uh, because probably is a different part of the world, so there are something that we are currently looking at this discrepancy. Um, so I would just have some observation in the last point. So what we now need is actually ground truth data because for specific application, this is critically lacking. But now the trend, the global trend is we have big data, and then also using this AI or deep learning approach that can have many different kind of input to generate result. So I will stop here. Thank you.
Thank you so much, sir. We are honored to present you an e-certificate of appreciation as a gesture of gratitude for sharing valuable insights with us today. Thank you. Please give a huge round of applause for sir.
Thank you. Thank you.
Thank you so much, sir. So you will be taking a picture now. Thank you so much, sir.
This is just a token of appreciation for you for your presentation.
Thank you very much. Thank you.
The wonderful talk and so inside details and lots of words you have highlighted, and yeah, because of the time constraint, we cannot further extend it, but yeah, the insights were really, really very well. Thank you very much.
Thank you. Thank you.
Thank
All
you,
right.
sir.
So I hope if there is any question, I think you are welcome to send me emails. And yeah, there's question. Sorry.
Yes, sir. I have one question, Professor. It's a
Please,
very
please.
yeah. So I have one question regarding as you mentioned, super resolution enhancement. Why can't we go for the multi-resolution? Because multi-resolution we have different level of the resolution. So multi-resolution data will not helpful in that regarding compared to super resolution.
I cannot hear very clear. You have what?
Uh, Sir, I am just question asking, multi-resolution can we replace this super resolution? Multi-resolution data?
Oh, high resolution data.
Yeah.
Yeah. Yeah, no, yeah, cannot replace. Now,
Okay.
I mentioned the private company. Yeah, the private company Pixel is an Indian company and already successful launched. I think now you can get data in 5 meter, right? 5 meter. So it's already very high resolution, but still it is not enough for certain application. Yeah. So I think the trend in the future is we are actually because 5 meter actually we can already have in some way we can apply the pen sharpening with Prisma. There is a one panchromatic pen in 5 meter. So 5 meter is all is a benchmark, but I think in the future we are pushing this limit. We are pushing this limit. The user they're asking now, can you give us 1 meter? Can you give us a half meter? So depending on the application, I believe the enhancement, this research would still be very exciting. I think.
Okay, sure, sure. Thank you, Professor. So we'll take a quick picture for this. So we'll just be online with the camera on. We'll take a picture over here.
Yeah, good.
So can you just take बस कर दो बस कर दो like you are this you like this
Please say one, two, three. I don't know. I cannot see really.
One, two, three.
One, two, three. Thank you, Professor. So hope to see you soon in physical mode.
Yeah, hopefully one day we meet each other physically. Yeah.
Yeah. Definitely there in Hong Kong.
Thank you for the invitation. Ciao,
Yeah.
ciao, bye.
Ciao. Let's start with the So, dear recent authors, I hope you are there in the meeting room. So, we'll start with these sessions immediately now.
You are in the camera software. 360 camera. Yeah. वहाँ से वो बोल पाएगा ना
So, good afternoon, everyone, once again. So, now we will begin with our panel paper session. So, now it's session 8, Technology Trends and Robotics, which is taking place in Hall 1, BKB Seminar Hall. So, now I would like to introduce our session chair for this segment, Dr. Anuj Abraham. Anuj Abraham is currently working as a research associate at the Indian Institute of Digital Science Research Center, Technology Innovation Institute, Masdar City, Abu Dhabi, UAE. Prior to TIL, he was working as a scientist at the Institute for Infocom Research, a research entity of the Agency for Science, Technology and Research in Singapore. His research interests are in systems and control with a strong background in the modeling of complex systems, optimization and control of a large-scale system with applications to intelligent transportation systems, autonomous systems, computer vision, and process control and instrumentation. He has several years of expertise in the field of control engineering, computer vision, and smart mobility. He is skilled in traffic simulation, control theory, C++, robot operating systems, MATLAB, VISSIM, and VTD. This encompasses the use of modeling and control to solve science and engineering problems. He earned his PhD in the Faculty of Electrical Engineering and master's degree with a specialization in electrical drives and embedded control at Anna University in Chennai, India. He has finished his bachelor's degree in the Department of Applied Electronics and Instrumentation, Rajagiri School of Engineering and Technology in Kerala, India. Moreover, he was a postdoctoral fellow at and Smart Mobility Experience Lab of the School of Electrical and Electronic Engineering, Nanyang Technological University, Singapore. He has been a recipient of the Anna Sanitary Research Fellowship for 3 years and a scholarship for an exchange of PhD of 6 months mobility period at the University of Pardubice, Czech Republic through Erasmus Mundus Action 2, which was funded by the European Union. In addition, his technical paper won the Vincent Bendix Automotive Electronics Engineering Award in 2021, funded by SAE International. He has teaching experience of more than 5 years as an assistant professor in the Department of Applied Electronics and Instrumentation at APJ Abdul Kalam Technological University in Kerala, India. He has authored several papers in reputed journals and conferences and contributed 16 book chapters and one book as an editor. We are honored to have him as a guide and lead this research paper presentation session. So next also we have in our co-session chair, we have Dr. Sabyasachi Bhattacharya. So it's my pleasure to introduce Dr. Sabyasachi Bhattacharya from Barakveli Engineering College, BBEC, which is in Karimganj, Assam. Dr. Bhattacharya has brought academic rigor and local institutional insight to this session. As a member of BBEC's faculty, he contributes to shaping engineering education and promoting development of technical talents in Assam, aligning with BB's mission of producing professionals skilled professionals equipped for modern challenges. So with his background and commitment to engineering education, we are honored to have him as our co-session chair, guiding this session with a strong regional and academic perspective. So first, we have paper ID 42. So we have authors Monica Mishra, Lal Bahadur Prasad with their paper titled as A State-of-the-Art Review on Issues, Concepts and Applications of Interval Type 2 Fuzzy Systems. Monica Mishra, ma'am, are you there?
Yeah. Hello. Am I audible?
Yes.
Just
Okay.
before the commencement of the technical session, I would like to request all the author participants, considering the time constraint, please limit your presentations to 10 minutes of presentation, which will be followed by around 2 minutes of interaction. I request all the participants to kindly adhere to the timelines. Thank you so much. Ma'am, you can start.
Anuj sir, are you there?
Yeah.
Okay, sir.
With the permission of the session chair, I think we can start the session. Dr. Abraham.
Yeah, sure.
Yeah,
Yes,
thank
sir.
you.
Session is yours. Thank you.
My excuse me, my screen is visible, sir.
Yeah,
Yes,
continue.
it is visible,
Oh,
madam. Thank you.
okay. Thank you so much. So, good afternoon, everyone. I'm Monica Mishra from Madan Mohan Malaviya University of Technology. So today I'm presenting my review paper titled A State of the Art Review on Issues, Concepts and Applications of Interval Type 2 Fuzzy Systems. So this work is co-authored with Professor Lal Bahadur Prasad. So this presentation covers the motivation behind Type 2 fuzzy systems, a focused literature review, the problem definition, methodology, comparative analysis, key challenges, applications, future research directions, and finally the conclusion. So coming to this slide, in modern intelligent systems, we deal with the data that is ambiguous, noisy, incomplete or inconflicting. So traditional type 1 fuzzy systems actually use crisp membership functions and therefore fail to capture uncertainty effectively. Hence, interval type 2 fuzzy systems were introduced as a more robust alternative, and they use a footprint of uncertainty or FOU, which helps in modeling variations in expert knowledge, measurement noise, and environmental disturbances. So this growing need for handling real world uncertainty is the primary motivation for this review. Coming to the literature review summary, let me briefly highlight the key developments. In 1975, Jarrett's Foundation introduced the fuzzy logic and later typed fuzzy sets to represent uncertainty more realistically. Then late 1970s, Du Bois and Truett added mathematical depth to the fuzzy logic operations. Coming to 1998, Kernick and Mendel provided computational algorithms, especially type reduction, making type 2 systems practically implementable. And in 2006, Mendel simplified interval type 2 systems, enabling the widespread use. Coming to the recent era, recent researchers shows IT2FS outperformed Type 1 system in control, pattern recognition, autonomous system, and other uncertainty-rich domains. So this historical progression clearly shows the increasing demand and capability of IT2FS. Coming to the problem definition, actually in real world systems, data are often contains uncertainty. So this may come from sensor noise, some measurement errors, some expert variations or environmental disturbances like this. So traditional type 1 fuzzy sets are fixed membership grades, which means they completely ignore this uncertainty. So this creates a major limitation. So type 1 systems cannot model ambiguity within the membership functions. Therefore, the problem we address is how can we design a fuzzy system that can represent uncertainty more effectively while also maintaining robustness and stability. So the objective of this review is to analyze the concepts, challenges, applications, and research opportunities related to interval type 2 fuzzy systems, which are specifically designed to handle uncertainties better than the type 1 fuzzy systems. So this is the methodology for this review. We followed a structured and systematic methodology. First, we collected 50 high quality papers from IEEE, Springers, etc. Second, the literature was grouped into key sections like historical developments, some concepts and mathematical foundations, computational challenges, applications, and some future research trends. Then next, we carried out a comparative analysis between a type 1 and interval type 2 systems to highlight the next advantages and the limitations. Finally, we synthesized all insights into a comprehensive review that identifies research gaps and potential opportunities. So, this step by step methodology ensures that our review is complete, reliable, and academically strong. Although this is a review paper, we present a conceptual framework to explain how an interval type 2 fuzzy system processes uncertainty. The workflow begins with uncertain input data being mapped through upper and lower membership functions, creating a FOU or footprint of uncertainty. Next, fuzzy rules operate on this bounded uncertainty region. The key step is the type reduction, which converts the type 2 output set into a type 1 set. Finally, the defuzzification step produces a crisp, stable output. So this framework helps visualize how interval type 2 systems provide more robust performance compared to type 1 systems, especially under noise and uncertainty. So this is the comparative framework which provides a clear comparison between a type 1 and the interval type 2 fuzzy systems. Type 1 fuzzy systems are simpler and computationally efficient, but they cannot model uncertainty within the membership function. On the other hand, interval type 2 systems offer better accuracy, robustness, and noise tolerance because they use a footprint of uncertainty. This makes them ideal for applications such as autonomous systems, renewable energy, and medical diagnosis. So but however, the main drawback of the IT2FS is its computational complexity, especially in type reduction. So, from this comparison, the conclusion we draw is interval type 2 fuzzy systems are superior for uncertain environments, but they require more computational resources and some careful designs. Coming to the key issues and challenges, although interval type 2 fuzzy systems offer clear advantages, they also bring several challenges like the first and the most critical challenge is the computational complexity, which I already said, especially due to the type reduction step. Traditional KM algorithms or Koenig-Mendel algorithms can be slow and iterative, making real-time implementation very difficult. The second challenge is the FOU design, for which there is no standard for which there is no standard methodologies are applicable. So designers only rely on the intuition, expert knowledge, or limited tuning methods. Another issue is the rule explosion problem, where the structure becomes large and difficult to manage because the rules are trial and error mostly. Interpretability is also limited because the FOU makes the system more complex, making it harder to explain decisions. Additionally, we face a lack of tools and benchmarking datasets. Unlike Type 1 systems, IT2FS do not have rich software systems. So, finally, the parameter optimization is also the major challenge. The presence of UMF and LMF doubles the tuning effort. Applications. Despite these challenges, interval type 2 fuzzy systems have shown excellent performance in many real world applications, in autonomous vehicles and robotics, for smoother and more reliable control under uncertain environment, in renewable energy the photovoltaic MPPT and wind turbine. This, so this improved the efficiency under noisy and fluctuating conditions. In the field of medical diagnosis and some imaging, this helps in imprecise symptoms and uncertain measurements. They are also used in financial forecasting when market data is highly uncertain. For smart grid operations, this also used for fault detection and energy management. In NLP and emotion analysis, this also effectively deals with the subjective linguistic variations. Finally, in industries also, this enhanced decision making in noisy industrial environments. So across all these domains, research consistently shows that interval type 2 systems outperform type 1 systems where the uncertainty is very high. Coming to the future scope, looking ahead, the future of the interval type 2 fuzzy system is very promising. The major trend is the data driven FOU learning, where deep learning, reinforcement learning, and the clustering algorithms. So, this is actually these are the future scope where we can use the IT2FS very efficiently. Coming to the conclusion part, the interval type 2 fuzzy systems provide a powerful and advanced way to model uncertainty in intelligent systems. Compared to type 1 systems, IT2FS also offer better robustness, accuracy, and adaptability, especially in noisy and dynamic environments. But however, they still face some key issues such as computational complexity, difficulty in FOU design, rule explosion, and some limited interpretability. But the future research, especially in automation, hybrid AI integration, standardization, and lightweight architectures, will help overcome these challenges. Based on the literature, it is clear that the IT2FS will continue to grow as a crucial technology for autonomous vehicles, smart energy robotics, medical systems, and advanced AI applications. So, these are some of the references which I have shortlisted. So, thank you so much. Thank you for your time.
Thanks for the presentation. I got a couple of questions. One is in your literature review. The latest paper you have shown is in 2006. So now it has been like 19 years later. Like, what is advancements you have seen there? The breakthrough simplification is 2006. After that, what happened? Like 19.
Yeah. In the 2006, what we got, sir, is the interval type 2 systems are not so much of use in autonomous vehicle systems, where the type 1 systems are mostly used. No footprints of uncertainty, no LMF and UMFs, no bounded regions are especially highlighted. But in recent eras, recent papers, we saw the 2 degrees of freedoms or 3 degrees of freedom systems are also implemented in the type 2 fuzzy systems analysis.
And also there are hybrid models like IT2FS along with artificial neural networks, convolution neural networks, and also using LSTM. So have you come across these hybrid models in your literature?
A little bit, sir. I'm actually combining the neural network models as well as the T2ANFS, T2ANIFS is combined in type 2 fuzzy logic with neural networks for adaptability and learning capabilities. Right now, I am in the progress of complete depth literature survey.
Yeah.
Uh,
So you
so
should also has to consider these hybrid models that improves accuracy and also handles the non-linearity uncertainties within the system.
of course, sir. Of course, sir. Thank
And
you.
you said one of the challenge is large rule base and scalability issues. So these hybrid models also will tackle those rule based issues also in that.
Thank you, sir. Thank you for the suggestion, sir. Of course.
Any other questions from the participants, from the audience?
Any questions from any offline participants or online participants? Please. Yeah, if not, then I have a couple of questions. Madam Monica, thank you for the nice presentation. So one thing is, if you can go to the comparative framework for your system, actually, you had one slide on the comparative framework, right? So if you can go to that.
Of course. This one, sir.
Yeah, so here I can see that in between the type 1 and the type 2, when you are comparing, you are mentioning about some features, some specific, some features in a textual manner, and the comments that you are mentioning or the performance that you are emulating, that is like only categorical attribute, right? Suppose uncertainty handling is limited for type 1, for type 2 it is high, interoperability again it is high, medium, low. So like how do you, is this done only like a categorical attribution, or or there are specific parameters that you can use and numerically tabulate? Are there any numerical measures for those actually?
Yes, sir. Actually, basically, we went through some simulation techniques, easy simulation techniques like PID over type 1 fuzzy over type 2 fuzzies. So those are mostly the trial and error fuzzy systems we already applied in our MATLAB systems. From there, we got the type 1 fuzzies interpretability a little bit high and the interval type 2 medium low. Like this, we sir evaluated. So these are not these are the data which we already derived over some controllers that we already did simulation in our MATLAB.
Okay, but throughout your presentation, I did not see anywhere any sort of numerical attribution to the performance. Rather, everything was mentioned only as categorical in terms of some words or attributes. So I would suggest that in your upcoming work, you should try to numerically tabulate the details as well to help us to understand your system better.
So of course, this is a literature review actually. So I
Yes.
plan to work on some hybrid fractional order systems like 3DOF or 2DOF model. Plus interval type 2 fuzzy controller will also be implemented. So this is actually a review paper. So basically the exhaustive literature review is being shown for what are the key challenges and what are the issues we are facing and what are the best innovations we can be drawn. So these are only highlighted.
Yeah, but in that case also in the review you could have include, instead of using the categorical attributes, you could have included some numbers which are mentioned in your reference papers actually, some numerical values actually. That would be more insightful.
Sure. Okay.
Okay,
Okay,
okay.
sir.
Thank you, madam. Thank you so much. Over to my session chair, Dr. Abraham. Any other questions, or else we
Yeah.
can move to the
So
next
just
topic.
adding to what you have said, you could have added some matrices like for your evaluation from the state of the art, like FOU, which is known as the footprint of uncertainty around a membership functions and other matrices. So these things can add value to your literature and state of the art work.
Of course, sir. Of course,
Okay,
sir.
we'll move to the next presentation.
Thank you,
Sure.
sir. Thank you so much.
Okay, thank you, Monica ma'am, for your
Thank you.
wonderful presentation. So next we have Joseph L. Pachau, Nomaikapam Rajavir Singh, and Anish Kumar Saha with your paper titled as Design and Analysis of Quantum Circuits for FRQI and NEQR Image Representation. Anish Kumar Saha, sir, are you here?
Yes, am I audible?
Yes, sir, you are audible.
Okay, so I hope my screen is also visible at the same time.
Yes, sir.
So, okay, I can start my presentation.
Yeah, you can start your presentation, please.
Okay. So, very good afternoon to the respected session chair, co-chair, and organizers, and all other attendees. So today I will be the presenter. My name is Joseph El Pacho for the paper ID 1, uh, which is titled Design and Analysis of Quantum Circuits for FRQI and NEQR Image Representation. So this is the outline of my presentation. So first I will be discussing a small bit about quantum image processing and FRQI image representation and EQR representation. And then we will see the circuit design for both this image representation and our simulation and execution results on offline simulator as well as the quantum processing unit, the QPU. So first of all, for introduction, I would like to talk about the quantum computing a bit. So in quantum computing, we use what is called as a qubit or a quantum bit as opposed to the classical bits. So this representation matters a lot in the sense that it takes the properties of if it is it utilize the process of quantum mechanics, which allow us to use properties like superposition or uh, entanglement to have a more efficient processing power. So here in this paper, we are dealing with specifically two types of very well-known image processing, uh, image representation technique called the FRQI and the NEQR. So FRQI and NEQR, usually they store images by following the 2D structure of a classical image, and they incorporate quantum entanglement between the the location and the pixel qubits so that for more efficiency. And in this paper uh, we will be giving an algorithm so that we can design we can give the encoding design for any image to FRQR or NEQR, and we run this experiment on IBM quantum platform. So I will be discussing the results from our execution. And so first of all, this is what a qubit looks like. So a qubit, here we can see the state kept psi. So kept psi, it can have the state of 0 or 1, but it can be also in the state of superposition, which is denoted by the coefficient A and B. So basically, vector in Hill, it is a vector in Hilbert space. It is a unit vector so as to preserve the entire probability of the system. So a qubit may also represented it in it's in vector polar form as represented here as cos theta by 2 ket 0 plus e raised to I phi sine theta by 2 ket 1. And whenever we need to manipulate any information that is stored as a qubit, we use a quantum operator, which is represented as a square matrix. So the square matrix, the rule of the square matrix is that u dagger I is equal u dagger u is equal to I. So u dagger here represent the the conjugate of the matrix. So that means u dagger u is equal to I, which shows that it should, uh, when you multiply the same operator with the conjugate of itself, it should always give you the identity matrix. So this is the rule for any quantum operator, and it ensures the reversibility features of of a quantum system. So now these are some example gates that we will be employing in our circuit. So we have a Hadamard gate, which gives us uh, which makes the qubit into equal superposition of 0 and 1, and we have the control knot, which is a NOT gate on one of the gate with a control from the one of the other qubits. And we have an RY rotation. So RY rotation allow us to prepare the qubit in any state of superposition based on the rotation value, which is theta. And we have an X gate. So this is somewhat similar to the classical NOT gate. It reverses the bit. It reverses the bit of that particular qubit. So now, first we will see what is the FRQI image representation. So FRQI image representation, as I have discussed before, it takes inspiration from the classical 2D image structure. Now, in this structure, it uses two sets of qubit, which is known as the one is for storing the location qubit, and another one is for the uh, binary qubit. So it places them in a superposition between 0 and 1. So now if we see in this equation here, this xy represents the uh, location. So if we have the x location and the y location as it is in 2D. And so uh, the the pixel qubit is a single qubit. Only one qubit is used, which is in the state of superposition between 0 and 1. And uh, the the probability is determined by the theta value here, and the theta value is nothing but the one-to-one mapping of the pixel value, the pixel intensity of the image, which is mapped to theta. So this is how we store images in FRQI image representation. Now in now if we want to store an image given here in this example as I. So here the image is stored by converting this 64 into the theta rotation, and its pixels are placed in according to their location qubits. And in any QR, instead of using uh, rotational gates, we use deterministic value similar to the uh, classical images. So here, this is the location qubit followed by the binary bit representation of the pixel values. So now this is the circuit design for the FRQI image. So here, these are the two location qubits which are placed in a superposition of all possible states. Now, for the states of 0, 0, 0, we apply the rotation of theta 1, which is the corresponding pixel value. And we apply an X for 0 state, and we leave it blank for the 1 state. So here we have
Mr. Joseph, sorry to interrupt. Keeping in mind the interest of time, there are other papers to be presented. I request you to kindly speed up or try to conclude your presentation.
Sure. So now we have for the remaining, we have the 0, 1 state, 1, 0 state, and the 1, 1 state. So this is the algorithm that we have designed for constructing this circuit structure. Now the same structure is followed in the NEQR, but instead of the RY gate, we have a bunch of X gates or the NOT gates to flip the bit from 0 or 1. So now this is the algorithm for the NEQR image preparation. Now here in IBM quantum platform, we have considered two backends, which is one is the AER simulator and another one is the IBM Brisbane. So AER simulator is a general purpose simulator. It is an ideal simulator, so it can support any type of unitary matrix. If you give any unitary matrix, it will take it as a quantum gate. But in IBM Brisbane, which is an actual real quantum computing device, it is a QPU. It supports 127 qubits, and it has some native gates which are given here. So any gate you want to represent, you have to break them down into these sets of gates. Then only you can implement in the actual hardware. And it uses a heavy hexagon lattice qubit coupling for coupling together the qubits. Now, these are some of the circuit that we have achieved after transpiling uh, the the proposed circuit. We have transpiled them for the AER simulator. So AER simulator, since it supports any unitary matrix, it looks almost the same. But now when we when we transpile them into the actual quantum device, we have to map them according to the quantum hardware that we are mapping. So in IBM Brisbane, this is the circuit after transpiling the proposed circuit uh, for the quantum hardware. And now here we can see in the measurement FRQI, since it is a rotational gate, it has more states for the same image. So this is an example for a 2 by 2 image. So we need 4 pixels. So for 4 pixels in FRQI, since it is in superposition, we have 8 states. So this decreases the accuracy in rebuilding the images. But in NEQR, we have, since it is deterministic, we have 4 states for the 4 pixels. And these are some of the comparison between the FRQI and the NEQR. So one important observation I wanted to highlight is that in the FRQI, although the circuit is smaller, and in the simulator we see that trend because the simulator it supports any unitary matrix. So the simulator in the simulator case, the uh, in the QPU we see that the NEQR grows along with the image size as we increase the image size. But in the simulator we see that the NEQR initially it is smaller, it is larger, but it grows less because this is because the complexity of uh, breaking down of the uh, breaking down the rotation gate. As rotation, it allows you to put any superposition values, so which is complex when you break down into images.
Just,
So
yeah,
yes,
continue.
in as I'm getting to the conclusion now. So now the conclusion is that uh, image representation in quantum computing, although we may have the ideal situation as the uh, simulator where we can put any kinds of unitary gates, but this is not the case when we put it into uh, real devices, as we need to map them to the hardware. So we have seen even here that NEQR uh, may be less efficient in terms of the gate building, but in terms of measurement and reconstruction of images, we can see that it can be more useful and it can provide more accuracy. So these are my references. Uh, Thank you. So if there's any question,
Yeah, Joseph, thanks for the presentation.
yes,
Just couple of questions. One
yes, sir.
is, how does your implementation actually address the circuit depth issue, which is commonly found in your FRQA and NEQR approaches?
Uh, yes, sir. So in this case, we have given this this conceptual circuit. So we are measuring them in terms of the implementation in the real quantum device. So although we have not solved the depth issue ourselves, we have reported the depth measurement. So what can be the depth based on the back end that we are using? So in order to highlight that the back end plays an important role when we actually implement any quantum circuit. So it is important to choose the gate design properly based on the back end that we are using.
And did you face any circuit depth issue in your work?
Uh,
Just
s- so an issue in the sense that, sir, we are trying to find out what is the circuit depth uh, in these cases. So here we can see that the depth of NEQR is increasing very fast. This is mainly because of the more gates it takes to realize. So here we have shown this is only for a one cube, a single pixel encoding. So here also, if we see compared to the simulator where it is an ideal simulation, we have this is a 4 by 4 image, sorry, a 2 by 2 image, and the circuit depth is quite low. But compared to a single pixel in the actual quantum device, so uh, the depth it really increases. So this is the issue that we are facing, and as such, we highlighted in this study that the hardware, what is the role the hardware plays in the depth issues.
okay. And also, what are the standard quantum image formats, like what you have considered in your work?
Sir, here we have taken two image format, the FRQI and the NEQR. So in current literature, actually, there are a collection of uh, image encoding, but it is usually based on these two. These two are the foremost representation.
Have
And
you tried on MCQI and GQIR formats?
uh, s- so we have not run the experiment on MCQI and GQIR, but although we have studied them, and so basically what we're concerned here is whether it is in deterministic or in probabilistic state. So we want to compare the deterministic state or the probabilistic state. So if it is a deterministic or probabilistic, it should be somewhat similar to these results that we are finding here.
Okay. Yeah. Any other questions?
Any question from any offline participants or any online participants? Any questions? Okay, I have two questions actually. Firstly,
Yes, sir.
uh, why for this quantum circuit design and analysis, only specifically these two representations, FRQI and NEQR, have been taken into consideration? Can you elaborate me, Mr. Joseph?
Yes, yes, sir. Actually, just as I have just recently mentioned that we are focusing on FRQI and NEQR because most of the common representation that we have found are somewhat improvement or a derivation of FRQI or NEQR. So the backbone structure, if we see it, it is somewhat similar to FRQI and NEQR. And the most thing that we are interested in here is that when we rebuild the image, is it deterministic or probabilistic? So FRQI we have chosen as the model for probabilistic measurement, and NEQR we have chosen as the model for the deterministic uh, reconstruction. So this is why we have chosen these two specific.
Okay. Okay, and if you could kindly go to your, there was a comparative table for different parameters.
Yes, sir.
Yeah. So in this regard, when we are talking about the parameter n, n basically represents what here? The number of qubits, I guess.
N is capital. Yes, N
Not
is
the
the number
capital.
of
Saying about small n, because I
the,
didn't find any definition
the
of
small
it.
n. Oh, sorry. Yes, n is the number of qubits that is used for the pixel representation. So sorry, for the location representation. So if we go back to this image here, so this two x and y, this shows as the n.
So you are mentioning about n as the number of qubits. Then again, if you go to the table, again here the second parameter you have mentioned qubits. You are mentioning qubits is 2n plus 1 for FRQI.
Yes,
So
yes, sir.
that n the number of qubits or something else?
Sir, n is specifically the number of qubits for only for the location qubits for the x and y. So what are the other what are the
Okay.
is
Okay, I
the whole thing
understood.
is giving us the entire qubit. Like there are pixel values that we have to represent. So this figure is giving us the qubit for the full image.
Full, this qubits
Yes,
for the full.
yes,
Okay, fine.
yes.
In your complexity analysis, what is it only the Vigo notation that you have considered, or you have considered other forms of notations as well for your complexity analysis?
So
Because this is because quantum is a very new regime, so
yes, yes.
analyzing it in depth is necessary.
So yes, sir. In quantum complexity, what we generally mean is the gate complexity. So how many? Suppose if we break down the gates into simple 2 by 2 matrix, then how many primitive gates would we require? So this is if we simply say a complexity, we generally mean in terms of gate complexity. So we can measure them in terms of depth complexity and other things as well. So in this particular example, we have taken gate complexity.
Okay. And after doing this, since this is on the design of quantum circuits, just a general observation I'm asking you. Basically, as at present our nation is going through like evolution in terms of quantum, like we are trying to develop quantum circuits. So, do
Yes.
you think that the dependency on the IBM Q scale can be removed if these kind of designs are implemented, or the dependency will still be there?
Uh,
What is your opinion on that?
yes, yes, sir. Actually, yes, sir. IBM is, as the current state, IBM is the largest provider for, if you want, real quantum devices. So, as as far as the research is going on, we basically do some theoretical simulation. So we are not concerned with the hardware. So in a way, we still need to depend on some hardware provider. Either it's IBM or other companies.
Okay, so I think for the development of the one, it would be also good as a suggestion to look into the hardware deployment also parallelly, because otherwise we have to be dependent on the quantum hardware providers, right?
Yes, 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 sir. Definitely, sir. Thank you.
Have a look in that direction as well.
Yeah,
Good.
thank you, sir. Thank you for the
Understood.
suggestion, yes, sir.
Dr. Abraham, any further questions? Or else we can move to the next one.
Yeah, we can move to the next one.
Thank you. Thank you so much.
Thank you, sir.
Thank you.
Yeah, thank you, Joseph, sir, for your wonderful presentation. So up next, we have Dr. Prashant Udavan, Disha Sharma, Sanskriti Kumar, and Gaurav Sanigra with paper ID 47 and paper title as ML Techniques for Hairstyle Prediction.
Is it visible, sir?
Yes, sir, it's visible.
Thank you, sir. Uh, Good afternoon, one and all present here. Respected session chairs and all. Actually, this is machine learning techniques for the hairstyle prediction. This is the review paper we have written, and we studied the different techniques here. So, for this, uh, is slide changing, sir?
Uh, can you put in full screen mode?
So, agenda is introduction, literature survey, problem statement, system architecture, methodology, result analysis, conclusion, and references. So basically, if you see in nowadays in the age of this uh, modern age, the hairstyles matters a lot. That if your looks is not good, then it affects so many things. So that is the idea that uh, we have taken this topic in our for the review that it uh, we thought that if we work on this, definitely it will give us the positive results and it will help for the different societies like barbers also, and for the uh, different organizations where it's like film industry is there and so many things are there where the people's uh, look and their hairstyles matters a lot. So for this, we did the different, we refer the different papers. Uh, Here, the Schroeder says that motivates the needs for the authority and the validation in the style output. Whereas the Tao Yang has said that uh, using the GAN, it will be, if we use the GAN, then it will enhancing the facial clarity before hairstyle overlay. And there are so many papers we referred. We referred near about 35 papers, research papers. Uh, yeah, and from that, by referring the different papers, we decided that choosing the right hairstyle is often difficult because we cannot say that whenever the people choose to go to the barber shop, that they get confused that what kind of the barberist also get confused that what kind of hairstyle will suit for this face, and the person also cannot explain properly. So that is the real problem, and users lacks reliability system to preview the hairstyle suits to their face and shape. So there is no such app also available, no yet in market, no suitable app which will suggest a proper hairstyle for a person. That's why, based on this, we refer the different papers, and uh, this is the system architecture we propose that if we give the initial input, then the pose alignment should happen, that the facial, because we are giving the uh, passport size image or the facial image of that person, and from that the pose alignment, that the it should be get aligned properly, and then shape alignment, color alignment should happen. And after the shape alignment means that the exact what kind of hairstyle will suit to that face, it should be get identified. And then definitely the color also matters a lot, that if we are checking the shape of the uh, uh, hairstyle, apart from that, if the person is black or the person is white, accordingly the color also, the hair color also should be should be what I will say, that it should align with that. That's why color alignment is also very important. And after that, the fusion, when we are combining and we are doing this alignment, after that the fusion should happen, and then the final refinement means final texture should be get. So that's why we refer the different algorithms we use. This study the style GAN, then ADA, then we combine this and unit for the final refinement. We tried this. So when we did this experimentation, so for pose alignment, you can find here in the figure that in pose alignment, that exact where what is the object that we can focus on, that with the help of GAN. The shape alignment models, that if we see that the exact the shape should be get curved, that where you can find in the fourth image here, that the exact shape has been uh, identified, that it has been curved, and where the new what I will say, that the hairstyle can be get predicted, that is we can identify using the shape alignment. Then color alignment, as I said, that we can transfer the realistic hair colors, adjust the tint tone shades, and look which should look natural, you know, so that we can do. And in fusion, it is actually faster hairstyle transfer system, uh, and what uh, it helps that it combines all this, and finally uh, fusion will help us to make it realistic, means whatever the image we have framed by using the shape and our original image, when we combine these two, after that whatever the new image should be, that it should look like a real. So fusion will help us for that, and refinement will help us that to do the some aging, do the proper aging, and some impurities might be there, so to remove that impurities it will help. So if we do, we tried this at basic level, because it's not all, we are working on it. So it is identified that direct GAN, if we go step by step, so instead of direct GAN, just adding algorithm was giving the better results, whereas when we merged this and we got this, the result was a little better. And after final refinement, we got a little bit better figures here, and the intersection of Indian noise to PSN are ratio, then SSIM, FID, and relaxer. So from this we can conclude that the system enables realistic facts, personalized hairstyle previews using AI, combining CNN plus GAN encoder-based latent editing gives high-quality styling suggestions and improves user confidence before selecting a hairstyle. Whereas it is very important that each stage of the pipeline, align color alignment, style GAN 2, shapes alignment, hair fast hair fasten GAN fusion and UNet refinement progressively reduces the artifacts and improves the realism. realism. The final refined output achieves the best performance across all the metrics, especially FID and SSIM. Showing this over multi-stage architecture produces highly realistic, well-aligned, and visually pleasing hairstyle try-on results. So, as I said that we have referred, a few I have enlisted here. We are referring actually the many papers. Still, our work is going on, but yet not. We have not yet implemented it finally. We are just working on it.
Yeah,
Thank you, sir.
thank you, Prashant. Some couple of questions. One is you never mentioned about the data sets you have considered in your work. Is there any publicly available data set for hairstyling?
Yes, sir. We downloaded it from the free resources.
But why not explained in your presentation about the data set, number of images, how did you train?
Actually, sir, for taking these results, we use the publicly available data set, but you can see these faces. So we are creating our own data set, and we are also trying on this because these are the images collected by me, our team only. So we are working on simultaneously on that, but yet our data set is not finalized. So we are simultaneously working on this.
Okay, in that case, how can your model adapt to the hairstyle recommendation to user preferences?
Pardon, sir?
In that case, how can your model adapt to hairstyle recommendations to user preferences?
Sir, yeah, that is a good question. Actually, uh, 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 user preferences because the problem is that user is also not having the idea that which hairstyle will suit to me because that's why our model will just by the face cut by identifying the face corners face cuts the model itself will suggest that this hairstyle will suit for this human or this person actually whatever the right now the results we are getting that it is showing only one result but we discussed with other members also and they suggested that why not to give the options 4 5 options that out of this the hairstyle should one of the hairstyle can the person choose from that so that we are working on that because rather than suggesting only one hairstyle if our model will show that 4 5 options that out of this you can choose so it will be
Yeah,
a better model.
you should consider the gender, the race, ethnicity, the cultural styles, age groups, all these things has to be incorporated into your model design.
Yes, sir.
One.
Right now, few of our we have taken the images of girls also. The for that also it is showing the better result. I will not say that it's the best result because some improved results it is showing, but still we are working that it should give the more precise output.
Okay, and in your results, why you have showed the metrics SSIM and PSNR? Actually, that is used for the image enhancement quality of that images, right?
Right,
Why?
sir.
Mm. What?
Structural similarity index we are showing here because we are working with the images only, sir. That's why.
Yeah, that is okay. Your task is not to find the image quality. Your task
Right.
is to find the best preferences, like the hairstyle recommendation. Then why
Right, sir.
you're showcasing that metrics in your results?
Actually, we are showcasing because, sir, though I agree that we are working on that, but we have to show the output in the image form only to the users, whoever is seeing. So the image quality also should be good, so that it should attract him or it should influence him.
Okay. Maybe you need to consider some more matrices, like appropriate ones
Yes,
in
sir.
your work. And also you could think about integration with the augmented reality
Okay, sir. Sure.
for the 3D modeling so that it
Okay.
is like good for the users.
Okay, sir.
Yeah. Any other questions?
Any questions from any offline participants or any of the online participants, please? Any questions? Okay, let me move to a couple of questions that I had, Mr. Dr. Prashant.
Yes, sir.
Yeah, so based on your title, which is ML Techniques for Hairstyle Prediction. So if
Yes.
it's actually hairstyle prediction, you are trying to aid, what I could understand from your presentation, you are trying to aid the any user or any client with what would be the
Sir,
best
I'm not able
hairstyle.
to listen properly, sir.
Yeah, am I audible?
You are audible, but voice is a little bit, broken.
Okay, maybe we can check. Just a minute. Is it okay now?
Yes, yes, sir.
Yeah. So, Dr. Prashant, from your title, what I could understand is you were mentioning about hairstyle prediction, and also from the presentation, what I could make out is you are trying to develop a model which would support a system which would support the users or the clients to see that to get the best hairstyle that would suit. Am I right? Am I
Yes, sir.
right? Yeah, so in that regard, if you are training a ML model for that, the inputs to your system should actually, like as you mentioned, the users are themselves, or the clients are themselves confused. What are the hairstyles that will best suit them? Maybe each of them will have around 3 to 4
Sorry,
hairstyles
sir.
in
I couldn't understand, sir, because the voice is a little bit very low and slow, broken voice. Sorry, really sorry, sir. I couldn't
Yeah.
understand.
Yeah, is it fine now?
It's fine. Right now, it's fine.
Okay. So basically, just to put it in one sentence, what are the kind of inputs that you have considered in your system? Have you taken from, if you are guiding the user to the best hairstyle, have you taken 2, 3 best possible hairstyles that a user would like to use for him or her? Have you taken those type of inputs in your model?
No, sir. Right now, we haven't done that because we are working on that. That the best possible output should be given to the users only. Right now it is just giving us that the whatever the model we are doing, because right now we have written only review papers. We are working on that because while doing the review we are trying to implement it also, so that we can correct the results. So right now, whatever the best possible output, to show the best possible output, we are working how to improve the results. Not yet.
Okay, okay. So in that case, for hairstyle prediction or for the hairstyling, the inputs to the users or the input to the model are not the preferences of the users, right? You are working on it, basically.
Yes, sir.
Okay. Okay, so you, in that case, you would need to actually look into that part, because without that, I do not really think that it would be a helpful hairstyle prediction or recommendation system, basically. Okay, so you can maybe look into that aspect. Yeah, sure. Sure. And also, just as a continuation of what my session chair, Dr. Abraham mentioned, I am not really able to understand SSIM parameter, PSNR, okay, but still
Sir, your
SSIM,
voice,
why this
really
parameter is
sorry,
there?
sir. I cannot understand actually what you are saying because it's broken. Really sorry, sir.
Okay, there might be some network issue. SSIM, why this parameter is there?
Yes, sir. Yes, sir. Yes, sir.
Yeah, why you have used SSIM parameter?
Sir, actually we can use, but right now, as I said, that we are working, we are reviewing, and we are trying to implement. So at initial stage, whatever the thoughts came in our mind, whatever the research papers we found in the current research papers, that only we implemented. But as we will proceed in this work, we will definitely go for that also.
Okay, okay, thank you so much. Thank you, Dr. Abraham. Any other questions, or we can move to the next paper?
Yeah, Prashant, lot of things you need to consider in your work. First thing is the input section, like you need to first prepare a questionnaire or something, which has to be filled by the user preferences, and based on that, you have some data, and based
Yes.
on that, try to do
Okay, sir.
some work. Okay, because your title doesn't match with your results, whatever you have said. Okay,
Okay, sir.
yeah, thank you.
Okay.
Yeah, we can move to the next one.
So thank you, Dr. Prashant sir, for your work. So up next, we have our fourth and the last paper for the day. So we have with us authors Pancham Singh, Manish Kumar, Ayushi, Shivam Singh, and Shivans Tiwari, with their paper titled as Smart AI Traffic Management System.
Hello,
Yes, sir.
am I audible, sir?
Yes, sir.
Yes, you are audible. Please start your presentation.
Okay.
Good, sir. Can we start?
Okay, well, good evening, judges. Myself, Pancham Singh. I am from Ajay Kumar Garg Engineering College, Ghaziabad. I am going to present my paper titled is Smart AI Traffic Management System. So, what is the agenda? Basically, we are presenting about the introduction, motivation, literature review, problem definition, methodology, experimental setup, result analysis, and conclusions. So basically, why we are choosing this topic for our research paper? So there are different types of challenges in surrounding us. Before we are living in Delhi NCR region, so we are facing different types of challenges. On the basis of that, we have finalized this paper because we are living in urban cities and face several traffic congestion, especially at intersection, resulting in delay, fuel wastage, and higher emissions. So these are the basically challenges during the traveling areas. Manual or fixed time signals fail to handle dynamic and unpredictable traffics. Emerging AI and IoT based technology, they are efficiently managing all the things, like we are managing the traffic routes and managing the accidental areas which are generally occur inside your road, and we are not aware about what is the reason behind this. There is a traffic, and maybe GPS is detecting this type of showing the showing the gathering of the traffic, yeah, red signal, but we cannot find out what is the reason behind this. There is a traffic and there is a lot of traffics. So real time traffic management system. So the motivation behind this: enhancing transportation efficiency, reducing human intervention through automation, providing faster emergency responses with green corridor, because using the green corridor, let's say we are using the ambulance system, fire brigade, and by using the green corridor we can shift the uh, traffic to that areas, and we can remove the traffic business, creating an ecosystem where users, auto authority, and AI system communicate seamlessly. The system aim to integrate camera-based detection by using the YOLO V8, either CNN model, either YOLO V8 model. So in paper, I am using the YOLO V8. RL-based control system. This is a control-based system, reinforcement learning control-based system we are using, and it will dynamically controlling all the things. GPS is detecting and predicting the exact location of the traffic on that particular route, where maximum traffic is there, and where is a traffic is not there. So automatically it will give the signal to the another vehicles, you can convert your route to another lane, yeah, another areas red light, and you can remove the traffic. So these are the basically introduction and motivation. Now these are the literature review. I am not going to discuss in detail. So we have taken 22 around from started for 22 2022 and 2024. So we have added many references in the our literature review literature section, but we have taken a few of the literature review here. Problem definition is: existing traffic systems are static, inefficient, and do not adapt to real-time traffic conditions. So these are the static way, like police is controlling all the traffic, but somehow it is not more efficient because due to the increase of the traffic, and we are not awareing about what is the reason behind this. There is a traffic jam, yeah, somehow there is accidental areas. Due to that, traffic is going to increase so much high. So by using the automated system, we can easily control the traffic management, as well as we can shift the route of the traffic to another red light. so we can easily manage all the things. So lack of the integrated accident detection, vehicle density estimation, and emergency response prioritization. So these are the challenges. Current system fail to combine vision based detection, GPS tracking, RL based signal optimization into one unified framework. So there is a need for a cost effective, scalable, and real time adaptive traffic system that reduce congestion, emission, delay, and improve safety. So our target is to provide these types of challenges which we generally use by the static way, and we are going to remove these challenges by the using the dynamic traffic management system. So this is the methodology part. This is the flow diagram where we have discussed about the proposed model. So basically, in the traffic management system is centrally located inside our image by image, and by using the ML based IoT based technique. So we are collecting the data from different sources. We have collected data Kaggle, and there are many sources, NASA repository, and many sources of data. We can train our model. On the basis of that, we can route the traffic. So traffic lights is there upper side, upper first boxes, traffic light management. So we are adaptive traffic signal control. So adaptive traffic signal control, basically this is our model. Basically it will work on the basis of training data, and by using the ML technique, and it will route the traffic in another light red light areas where less traffic is there. So this is the actual block diagram. Maybe it can be depend upon the feedback basis. Maybe it can depend upon the mobile app. So because we are integrating with the mobile app for the accidental part, accidental areas, it will give the signal there is an accident, so we can not moving to that area, and we are moving to another red light area. So these are the overall diagram. So the experimental setup described in the paper for the smart AI traffic management system includes the following key points: simulation environment, vehicle detection module, reinforcement learning controller, because we are using the reinforcement learning controller, it will dynamically controlling the uh, upcoming and upgoing of the traffic. GPS based emergency vehicle tracking, because some vehicles are very emergent, because like ambulance, yeah, fire brigade, these type of vehicles are very needful to move to the destination. So we will give the more priority on that particular vehicles by using the green corridor. And mobile application, it automatically indicate that where is the area where the accidental area is there, and automatically we are not moving there. Maybe some vehicles, they are collision to each other, due to that there is a lot of traffic is there, so we are getting the previously information ki there is a traffic, huge amount of traffic, so automatically dynamically we are not moving that area, and we are shifted to the another areas. So performance based matrix. So these are the some results we are showing, but not showing all results, but we are showing some results. So first table, basically vehicle throughput per 5 minute cycle. So we are taking 10 10 slabs for 5 minutes. So every row is showing the 5 minutes cycle. So in first row, 5 minutes, we are getting 212 vehicles in the four land one, land two, land three, and land four. Similarly, for 12 cycle, we are getting total 2,435 vehicles in an hour. In an hour, we are getting total vehicles 2,435. In our model, our model is proposing this one, the same, using the concept by using the adaptive AI traffic management system. We are going to increase the number of vehicles as well as managing the all traffic. So total calculation of the vehicles is 2,997. So per 5 cycle, we are going to increase around 48 vehicles per 5 cycles. So total, we are approximately, we are going to 30%, we are going to increase the vehicles in the every cycle. So this is the result part, and this is the simulation where we are simulating the results by using the previous is the current current and proposed. So our proposed uh, comparison is upper side. So we are managing more vehicles compared to the existing या previous vehicles या static way में whatever you are managing. So both graphs are, they are bearing accordingly number of vehicles and we are passing per hour, as well as we are how you are going to manage this dynamically and uh, reducing the emission as well as wastage of time. So these are the result analysis. Sir, am I audible?
Yes.
Okay, so these are the results and analysis. 23% throughput we will increase by using the our model, adaptive AI based model. The adaptive AI based serves 2,997 vehicles over 12 cycles versus 2,435 in a static control. So around averaging 48 more vehicles per 5 minutes we are going to increase. 30% fewer stops, reduce stop and go traffic by optimizing signal timing with the reinforcement learning and real-time YOLO V8 detection. So this is the object detection model through which we are detecting how many vehicles in a row, and on the basis of that we are reducing the stop timing of the vehicles. 10% emission reduction, because if there is a vehicles, a huge amount of vehicles is there, traffic jams is there, though definitely we will increase the emission part. So 10% emission reduction. So we are reducing the emission part also 10%. And for the emergency green corridor, for we are giving the prioritize for the ambulance as well as fire trucks. They will pass, they will use that route to move on the destination. So overall efficiency gains, integrated AI model overperform baseline in flow, safety, sustainable, and promising for smart cities. So these are the conclusions. So the AI-based adaptive traffic system significantly improve traffic flow, reducing congestion and vehicle wait time through real-time signal adjustment. So by using this technique, because we are integrating AI model combining object detection, reinforcement learning, and GPS tracking delivery system, so it will dynamically manage all the things by combining with the mobile app, as well as mobile app, and with time to time we are getting the update accordingly traffic system to where is the traffic and where is not traffic, and on the basis of that automatically we are routing the traffic from this area to that area, nearby area, not moving for more area, more distance. We are moving to nearby areas through which we can easily manage the traffic signals, yeah, traffic management. So these are the references, and thank you.
Yeah, thank you, Pancham, for your presentation. I have actually a lot of questions in your slides, but I'll just restrict to very few. The first one is, what are the technologies you have used in your approach?
Sir, I have used YOLO V8 for object detection and reinforcement learning for the dynamic adaptation, and I have used um, IoT, yeah, you can say ML based techniques. They can easily give the prediction of the vehicles ki location of the vehicle by using GPS and IoT, sir. So we have basically we have used a three in a combine. First is
Okay.
the oh, yes,
Okay,
sir, yes, sir.
understood. And you mentioned about the green corridor. So what about the V2X technology being used there? Vehicle communicating to the infrastructure, vehicle communicating to the vehicles itself. What about the technology?
Sir, pardon, sir.
The
Can you
vehicles
repeat once?
communicating to the infrastructure. You need a green
Yeah.
corridor, right? So there will be
Hmm.
an onboard unit on your vehicle, and there will be an RSU on the traffic light. So it has to
Hmm.
communicate for you to get the green corridor. So you didn't mention anything on this.
Yes, yes, yes. Sir, actually, basically, if you are using the same route for the like ambulance, yeah, fire vehicles, so it will create the problem because no one is want to leave that lane. So how you will pass that particular vehicles for emergency purpose? So definitely we will give by using the uh, priority base. We are creating the that section, the green corridor, and that can be used on the basis of priority, and that vehicles will move. But because we are using in our uh, proposed model, we are prioritizing such. You can see the diagrams are actually, it will be more clear, this one. So we are prioritizing that vehicles which is important. Okay, sir. So on the basis of that, we can prioritize that vehicles on the basis of the route. Maybe sometimes we are not specifically separating all the vehicles, but on the basis of the higher priority, we can give the more priority that particular land for that
Okay.
vehicles.
And what is the simulator you being used? The simulator for traffic simulations. You
Sir,
mentioned the lanes, numbers, many things, right? What is a simulator?
sir, we are using actually we are using the NS3. Yeah, yes.
NS3 is for communication aspect. It's not for your traffic simulation. I'm asking,
Uh,
have you used Sumo, which is smart urban
yes,
mobility?
yes, yes. One minute,
Carla,
second.
you have Carla, you have Visim, you have VTD. Many simulators are available. In that, which one you have used?
Um, 1 second, sir. We have used Carla. Yes, sir.
Sure.
Yes, sir.
Okay. And what about the shortest path? You mentioned in this diagram. The
Sir,
short.
we are focusing on the Dijkstra algorithm. Basically, somehow we can use the optimal path for routing that particular vehicle. So we can use Dijkstra algorithm and Dijkstra.
Okay. And final question.
We have
What is
mentioned uses this Dijkstra algorithm in this paper actually.
Yeah, you can use either Digistra's algorithm or A star or combination of both. Okay.
Yes,
And
yes,
last
yes.
question is, what do you mean by current system? The current system, according to me, is SCATS and SCOOT. SCOOT means a split cycle offset optimization technique, and SCATS is Sydney coordinated traffic control system. These are the two widely being used globally everywhere. So, what do you mean by current system in your results?
The current system basically current system we are talking about the current system. uh, current system is previous system, sir.
What is it?
Our model.
Your model is previous, propose is also your model.
Yeah, yes, yes. So actually, in the previous approach, we are using static. So somehow we are unable to control the actual feasibility of the traffic. Actually, sir, maybe I am not giving the more drawback on that particular model, because that model is also effective. But by using the integration of three, we can more optimize the traffic as well as increase the number of vehicles per hour. So we are focusing on.
Okay, but anyway, you need to compare with the state of the art techniques, not with your own techniques. Okay.
Sir,
Yeah. Any other questions from the audience, offline, online?
Any questions from offline or online participants? Okay, I have a couple of questions. I'll be very quick since we are running out of time. One thing is, firstly, the results that you have shown, Pancham, what I could understand from your results is in this traffic management system, this graph basically, you are trying to show that you are able to manage more amount of traffic per 5 minute cycle. Am I right?
sir, actually, we want to manage the traffic as well as we are going to increase the number of vehicles.
Yeah,
I
but
am
managing
actually,
the traffic and increasing the vehicles is supposed to be like, if what is the difference between that actually? Basically, in your traffic management system, your results are showing that you have managed that basically, right? Or are these the different parameters?
sir, actually, in our proposed model and existing model, basically, the reason behind that traffic is one major concern. It's okay, but how we are going to manage increase the traffic size? Sorry, increase the number of vehicles per hour and also reduce the traffic. So we are targeting that one because somehow there is a traffic. So definitely we are stuck in that area and we are not. increasing the number of vehicles from that particular red light. So how many vehicles are passing that particular red light at the same time in an hour? So we
Okay.
are managing both traffic management as well as we are increasing the throughput also. So
Okay, and
and
how are you claiming, as shown in this results and analysis slide, how are you claiming that you have 10% emission reduction in that previous, the results slide actually? The next one, next one, next one. No, please come now. Yeah, yeah, this one, this one. The next one.
this one.
No, the next one. Slide 10. Yeah, 10% emission reduction you are claiming here. How do you claim that? From where you are getting that?
So by I think on an average we are calculating on the basis of number of vehicles. Sir, actually we are calculating on the emission as a neutral. Let's say traffic is there, traffic is there,
No,
and vehicle is
no, no,
stop
no,
that
no.
particular.
You are getting me now. What is the parameter? When you say 10% less
So
emission,
parameter
what is
is
the
this.
parameter for that?
The parameter is this one. What is the emission rate of the per vehicle per minute? Yeah, 5 minutes. So on the
Okay.
basis of that,
But
yes.
in that case, in your presentation, you did not show anywhere actually how you are computing the emission reduction actually. So
Sir,
please take me
actually,
out.
sir, emission is actually we are calculated on the basis of the what is the normal emission of a vehicle at the standing position. So on the basis of that, we have calculated ki how many vehicles we are past that particular point. On the basis of that, we have calculated 10% emission reduction we have on the basis of that. Yes, sir.
Okay. Okay, thank you so much. Thank you. So Dr. Abraham, any further clarifications or we can maybe wind up the
Yeah,
session?
we can wind up. Just one final suggestion to him. You need to go through the literature very in depth to progress in this particular domain because I see a lot of gaps to be get filled. Okay.
Thank you so much, sir, for your suggestion. Definitely, I will add, and in future, I will definitely do this month. Thank you, sir.
Thank you.
Thank you. Thank you so
Thank you,
much.
sir. Thank you, sir.
So
Thank you so
thank
much.
you, Ashram Singh sir, for your wonderful presentation. So now we have come to the end of the paper presentation session for the ICTCON 2025. So for that, I would like to thank
Sir,
all
can I
the
leave?
session chairs and the co-session chairs who were present with us, and also to all the authors and presenters who were with us both offline and in virtual mode, and also to all the audience present here. So now we move to a special moment of appreciation. So first, we would like to extend our heartfelt gratitude to our session chair, Dr. Anuj Abraham, for his valuable presence and contribution to this session. Since Sir is joining us online, he will be felicitated with an e-certificate of appreciation.
Thank you.
You're welcome, sir. So we also take the privilege of honoring our co-session chair, Dr. Sabir Sachin Bhattacharya, who is present with us here today. So I would like to invite sir on the stage. I'd like to request our felicitation team to kindly proceed with the honors. So can we have a group photo for the, I would like to request all the authors who are present here in the session to kindly turn on the cameras so that we can take a picture with you.
यहाँ पे खड़े हो जाइए इन द कैमरा where is the camera?
Sir, the question is taking zeros. Sir, we taking from zeros. Thank you so much. Thank you so much, sir. So here we are ending the session. So thank you and have a good day. I would also like to request all the authors who are present with us virtually to stay for a few moments as we will be proceeding with our valedictory session right now.
Good evening, everyone. I kindly request all respected dignitaries, distinguished guests, faculty members, researchers, participants to please take their seats as we are going to begin with the valedictory session of ICTCON 2025. Good evening, respected dignitaries, distinguished guests, faculty members, researchers, students, and all participants. It is my privilege to warmly welcome you to the valedictory session of the Third International Intelligent Computing and Technologies Conference, ICTCON 2025, organized by the Central Institute of Technology Kokrajhar, CITK, in collaboration with IIT Goa. Over the last 2 days, we have witnessed a remarkable convergence of minds, discussions on cutting-edge technologies, stimulating keynote lectures, insightful workshops, and high-quality research presentation. ICTCON 2025 has successfully provided a platform for researchers, industry professionals, and academicians to share knowledge and explore innovative solutions in areas such as artificial intelligence, data science, natural language processing, and intelligent system design. We are deeply honored by the participation of eminent speakers and experts who enrich the conference with their ideas, their experience, and their intellectual depth. The hybrid participation of authors and scholars from across India and abroad truly reflects the spirit of collaboration and global engagement that this event seeks to promote. As we begin the valedictory session, today's session is a moment to reflect on the outcome of this conference, acknowledge the contributions of our guests and participants, and mark the successful culmination of this academic endeavor. I extend a cordial welcome to all the dignitaries on the dais, respected faculty members, our invited experts, student volunteers, and each participant who has been a valuable part of ICTCON 2025. Thank you for joining us this evening. We look more into this session. Now let's get a summary of conference highlights and technical sessions. The third International Intelligent Computing and Technologies Conference, ICTCON 2025, jointly organized by CITK and IIT Goa, successfully concluded after 2 days of productive academic exchange. The conference received 136 submissions, out of which 36 high-quality papers were accepted for rigorous peer review. The event featured 4 keynote talks, two invited speakers and their sessions, and 8 technical paper tracks. Topics range from AI in healthcare, computer vision, NLP, cloud security, IoT, smart cities, robotics, and 6G technologies, reflecting the diversity of research in intelligent systems. International experts, including Professor Bashir Ladeva from Spain and Professor Jonathan Chan, along with distinguished speakers from leading Indian institutes, delivered insightful lectures on AI, data science, hyperspectral imagery, and cyber-physical systems. The conference fostered strong engagement from faculty, industry professionals, and students with enthusiastic participation in hybrid mode. Overall, ICTCON 2025 successfully created a platform for research collaboration, innovation, and meaningful dialogue on emerging technologies. So let us give a round of applause for ourselves as this ICTCON 2025 was a great success. Now, it is now our honor to felicitate our distinguished guest, Dr. Sangram Brahmo, the Honorary Secretary of Assam Football Association. I will request the felicitation team to felicitate Sir. Sir, please to come on stage. The Dr. Sangram Brahmo is a noted educationalist, librarian at Waterland University, sports administrator, social worker, and public service professional from Waterland who has made impactful contributions to community and youth development. He served as the officer on special duty OSD to the Chief Executive Member, CEM. He played a vital role in administrative coordination, public outreach, and policy facilitation across key departments. As a visionary sports leader, he has been instrumental in transforming the Waterloo territorial region into a classic football hub by successfully bringing major national tournaments to the region for the first time, including the interim sixth scheduled Premier League (ISPL), the prestigious Durham Cup, and the historic Santos Trophy. His initiatives have strengthened grassroots sports ecosystem, enhanced sporting infrastructure, and created unprecedented opportunities for local talent, reflecting his deep commitment to social empowerment, institutional development, and regional progress. Now, I would like to request Sir to share a few words with us. Let us welcome Sir with a big round of applause.
If you excuse me,
Yes, sir.
I want to add one thing. Probably, as many of you are may not be aware, Sangram has a also relation earlier with our CIT. He once upon a time he used to stay exactly behind, opposite to my quarter. Hello. Uh, Good evening to everyone. First of all, I thank you, Department of Computer Science and Engineering, Central Institute of Technology, for inviting me here and to be a part of this third international. I. This is the problem. This is the case of intelligent computing. Wherever you are, that gets you. So thank you so much. Pranabji has called me, and last year also he called me. Whatever the event is, I cannot avoid the event of CIT because I am deeply touched with this institution, especially because I was given opportunity to serve this beautiful institute. Uh, Conference chairs, conveners, and especially from IIT Goa, Mr. Prasadji, Dr. Prasadji, all the faculties of CIT, and students and research scholars. So this ICTCON, as I heard just a few minutes ago, it was conceptualized within the state or in a regional level or in a national level. But later on, after with due consideration and consultation, it was the concept was sent to international level, and you have done it successfully. And I congratulate for this, uh, for making this event and taking this to the international level. So thank you so much once again. And the institute, Indian Institute from Goa has taken up to collaborate with the department, with the institution that is located in such a remote place. So special thanks. I am deeply connected with, as of now, with the sports, and I have seen computing intelligence is taking part in sports also. Nowadays, you see in shooting practice like Ronaldo and Messi, they practice with the robot goalkeeper. It's not easy to beat robot goalkeeper. It's very hard. Even Messi and Ronaldo cannot beat them. So you are taking place everywhere. And I just a few minutes before, I had a discussion with your professors and faculties. I had a huge fight with beautiful girl, Myra. Myra, you know, the girl who came in, who comes in, make my trip. So I kept asking question. She was replying on her behalf, but I was not satisfied. I kept uh, what do you tell me, scolding. ये क्यों ऐसा हुआ है, आप लोग झूठ है, हाँ आप लोग हमको फंसा रहा है. It was the case of cancellation refund. वो क्या जानता है, वो रिप्लाई देता है, लेकिन मुझे क्या चाहिए, she doesn't reply. So I scold her like anything. Last में number देना पड़ा कि you can call this number customer care में, otherwise she didn't. Number ही नहीं दे रहा था. And nowadays what happens, most of the agencies don't have call center numbers. नहीं मिलता है आजकल. कॉल करने से भी उसी पे ही जाता है. So we normally don't get call center numbers nowadays. First of all, you have to resolve with this chat box or whatever robotics or whatever in your terms. So वही जमाना आ गया है. This intelligent computing, this computing has taken the major role in our day-to-day life, and computer science people are the main persons. आप लोग ही सब जगह में. So once again, I thank you for inviting me. So next year, hope again I will be here. Pranabji will call me again. So I'll be here. I don't know the topic and depth. I don't have the depth,
knowledge of computing. I hate computing actually. Mathematics, physics. Why I hate? Why I hate? मैं क्यों बुरा पाता हूँ मैथमेटिक्स? क्योंकि nobody taught me मैथमेटिक्स से क्या होता है. मैथमेटिक्स पढ़ के क्या होता है? Nobody taught me in the high school level, any middle school level. Nobody. I thought लाइफ में चलने के लिए टू रन माई लाइफ प्लस माइनस डिवीजन डिवाइड वही तो काफी है. 1+1 2 हो गया बस. एडिशन पैसा काउंट करना है वो काउंट करना है जो भी करना है. प्लस माइनस डिवाइड वो 3 काफी है मेरे लिए. 2 ये ऊपर के ऊपर जाता है क्या था ये सब. कितना ब्रैकेट होता है किस स्टाइल का. ऐसा होता है इसके बाद ऐसा होता है इसके बाद ऐसा होता है ना. और उसके बाद ऐसा होता है 2 क्या होता है और ऐसा होता है लैम्डा होता है इंफिनिटी होता है. अरे क्या है यार ये सब. ये तो मेरा जीवन में हम के लिए तो है ही नहीं. इसलिए एज ए लेमैन दिस इज कुछ भी नहीं है मेरे जीवन में. बट फ्लाइट चलाने के लिए तो वही है. कंप्यूटिंग वही तो करता है. रास्ता फ्लाइट का रास्ता वही तो डिफाइन करके लेके जाता है. अभी पता चला आपको. तो ये अगर हाई स्कूल लेवल में हमको बोलता, एमी लेवल में हमको बोलता कि भाई बच्चों ये फ्लाइट जो उड़ता है ना इसमें भी मैथमेटिक्स काम में आता है. नोबडी टॉट अस. सो स्कूल लेवल से एमी स्कूल लेवल से हम लोग शिक्षा को सिर्फ एग्जाम मार्क्स वही पे रही. हम लोग क्या किया छोड़ के आ गए. पढ़ा के आ गया. इट्स नॉट. पढ़ाना मतलब इससे क्या होता है. डिवीजन से क्या होता है. इस मैथमेटिक्स का इतना भी वो होता है. इससे क्या होता है मतलब समझाना पड़ेगा. मतलब ऐसे टीचर अगर कंप्यूटर साइंस पढ़ाने के बाद इसका मतलब ही हम लोग नहीं समझाता है. कंप्यूटर साइंस पढ़ने के बाद कल भी आप पूछिएगा क्या ये बेकार है ना. दोस्त हमने सीखा था बहुत पहले. दोस्तों अभी काम का नहीं है बट स्टिल प्रोग्रामिंग के लिए काम में आता है. कोई कोई उनको यूज करता है. बड़ा बड़ा डिस्क का आप लोग तो देखा कि नहीं. और अभी का स्टूडेंट्स लोग अभी तो पेन ड्राइव आ गया. पेन ड्राइव भी धीरे धीरे गायब होने लगा. तो देयर इज ट्रांसफॉर्मेशन. और हम लोग ऐसे टीचर एकेडमिशियन वी शुड टीच स्टूडेंट्स विथ पर्पस. क्या होता है इसका मतलब. बिना मतलब जाने टीचिंग का कुछ भी मीनिंग नहीं है. सो वंस अगेन आई थैंक यू and congratulate once again the Department of Computer Science and Engineering for making it a grand success. Next year, I hope this event will far more better. Thank you so much. Thank you. That was very nice. Thank you.
Thank you, sir, for your very valuable words. Let's give sir once again a big round of applause. I now invite our respected conference convener of ICTCON 2025, Dr. Apurulan Senapati sir, the HOD of CAC department from CITK to address the crowd. Let's welcome sir with a huge round of applause.
Respected Sitola Prasad from IIT Goa, respected Sangramji, my colleagues, and my students. Uh, with this conference, it is not an event, our emotion is also involved. This is because this conference is generated in CIT and gradually it is accelerated. So we do not know in future what happened, but hope it will be a sustained. The importance of the conference is, I just give few example. So now we live in in the age of artificial intelligence. If you see the term artificial intelligence, can you tell me where did it come from? Where this term artificial intelligence come from? Can anyone tell me? This term is also generated in a conference in 1956 in Dortmund. There was a conference, many people get together. For example, John McCarthy, McKinsey. So all these things, people came together in a conference. Before that, what artificial intelligence? It's clearly defined by Alan Turing in his Computer Machinery Journal, and what it can be done, he defined on that time. That means theoretically he said what it can be done, and he gave a very simple experiment. What is artificial intelligence? So in class I have I maybe mentioned this thing. Very interesting experiment. Thing is that there are two rooms. One room there is a person, another room there is a machine. If you throw question, getting answer from the both the room. If you do not distinguish who is the machine, who is the person, then we can say it is intelligent system. Okay. So Turing gave this very interesting definition, but on that time, term artificial intelligence did not come. It came 1956 in Dortmund conference. After 10 years, 1966, first chatbot came, Elijah. It is also still live. You can go and check. Today, if you interact with this Elijah, you will laugh how teeny is or so many wrong information is given. But on that time, 1966, people become wondering. Machine can interact with human. I am giving query, he is returning. So technique was very simple. That there was some template kind of things. Template, its answer was that kind of thing. If you throw a query, it matches the template and corresponding answer it returns. Okay. But after that, people try to improve it in laboratory. So while in laboratory you are doing something, how it come in market, how it come to people. So conference is the platform to come it. Okay. So if you see the ChatGPT, how it is improved one by one, gradually, and today its capability almost like human in many senses. If you see all these things, most of the come in a conference or through a conference. Now see the importance of the conference. So it is a global platform, open platform to share your knowledge, to learn, to publish. And as a student, especially for PhD student, if you do not involve with this, I feel it is incomplete. You can get your PhD, but it is incomplete. So hope I convey my feelings or importance to the conference. Second thing, to conduct a conference, it is the effort at least 6 months. It is not for the 3 days. Now for this conference, we have received 136 papers. You have to judge the paper, to sending the expert, receive their comments. So one paper sent to 3%. So 136 into 3, how many people? So you have to search that person, that many person. You have to talk personally. You have to send the paper. If it is late, you have to knock him. So, sir, please send it. Okay. Now see the effort. Needs lots of money. CIT is not providing any money based on my knowledge, I think. Okay. But you see the arrangement. Why are you getting? You must have that much of contact, that much of faith to collect all these things. Next, you have to publish all this paper. You need a platform. So last 2 years, it will publish one of the leading publishers. So I think this is the first in CIT. So many events already happened. Second thing, as a reviewer, we did not help much. Just some official signature I have done. I have reviewed some paper. But as a reviewer, feeling is paper are much better compared to earlier. So this is a very good feeling as a conference convener. And a big thank to Pankaj sir. If the conference you consider as a rail gadi, so Pankaj sir is the engine, and Pranav sir is the backbone.
Thank you, sir, for your knowledgeable words. I now invite our respected conference convener of, um, thank, sorry. Now, as a gesture of our gratitude, we would like to present a token of appreciation to Dr. Senapati sir, conference convener of ICTCON 2025, for his valuable guidance, support, and contribution to the success of this conference. Sir, sir, please do come on the stage as we are presenting you a token of appreciation. Let's give a big round of applause. Sir, we are truly honored to have you with us. It is now my honor to invite our conference chair of ICTCON 2025, Dr. Shitala Prasad sir from IIT Goa, to address the gathering and also to do the announcement of the guest paper and certificates. Let's welcome sir with a huge round of applause.
Yeah. Thank you. Thank you for inviting me. 2 days busy. So finally, it's a obligatory day. Thanks to all of us, not only to we as on the desk, but also to all the participants as well as the volunteers. Without you, it's not possible. So can you just check it? So, as a vote of thanks, I will invite Pranav sir later. So prior to that, I'll just try to summarize the conference. Can you just put it on the screen and share it? Is it visible on that screen?
Yes, sir.
Visible. Okay, great. Fine. So, yeah. So this is ICTCON 2025. Group photo of all of us on the first day. Starting from the first day, you can see the energy and the participants, members, and so on. So you can see. So special thanks to CIT for hosting it into their own campus, providing all the facilities, the infrastructures, and the arrangements for food and hostel.
So where's the presentation? This one, yeah?
This one. Okay, fine. So as our anchor already mentioned about the themes, majority of the topics were healthcare, computer vision, were also related to IoTs, and we were also talking about something related to smart cities and the future developments of LLMs. So these are some of the glimpses which you can see over there on the screen. You can see our keynote speakers. We had four keynote speakers and two guest speakers. We had a workshop for AR and VR. So all the participants, students as well as CIT members, they had a chance to interact with them and they got all the knowledge. So we had general speakers from within India as well as from the abroad. Along with this, I will just try to summarize the list of total papers throughout the nation. So here we have different types of institutions which I can just point it out for you. Total number of papers we received from private college was 32, where the distribution was mostly from West, 8 papers, and South, that is 16 papers. There are the total major thing. East, we did not get any paper, but that's okay. Next time we'll definitely introduce that. Uh, Private universities, we got almost 64 papers. From government engineering college, we got 6 papers. Central universities, we got 3 papers. State universities, that is, we got 5 papers. CFTI, we got 5 papers. IIT, we got 4 papers. NIT, we got 11. And IIIT, we got 1 papers. Overall, overseas, we got 5 papers. That is, outside India, we got 5 papers. That's a good significance improvement compared to the previous. Yes. I think previously we had 2 papers, right? We had 2 papers. This time we had 5 papers out of India. In total, we got 136 papers as was summarized. 26 was the acceptance ratio. And based on this acceptance ratios, we had, for this acceptance ratios, we had struggled a lot. As our Kanran also mentioned about this thing, getting reviews done is not easy task. Finding reviewers, knocking them all each and every day. We remember me and Pankaj sir, we had sent several mails, reminders to them, even personal calls that can you send it us. So after finally all those hard work we come to a conclusion that out of 136 we'll be selecting 32 papers, 36 papers, which is counting 26% of the total. So based on that, the best quality papers we have selected it, we were presented it, and based on the presentations, their review comments and the scores, we also selected. We this time we are introducing a new trend that we'll be announcing the best paper as well as the best application papers in this track. So for that, the criteria, just to make it familiar, is mostly based on the review comments. The comments, if it is positive, we'll total them, and as well as how they have presented over there in the throughout the sessions. So based on that, we have categorized it into 2 categories. I hope. How many of you have attended the papers? Any guess, like best paper? Any idea, like which paper can be the best paper if you have attended any sessions for this? Okay, any theme you can think, you can remember, any key paper which you can remember or recollect? Okay, so I'll just flash it over here. So the best paper we got at 135, paper ID, advanced fake news detections using hybrid CNN and bi-LSTM with class silencing. That is what we received the maximum score, and also the presentation was well addressed. So congratulations to the authors. So along with this, we are also going to announce 2 best application paper award. Here, one application belongs to the palm leaf disease identification, that is paper ID 139, classification and interpretation ability of palm leaf disease using deep learning and explainabilities AI. And the second best paper, second best application paper award is to paper ID 28, hybrid multi-view 3D object detections with 2-dimensional image, fusion of structures from motion to learn depth. So these are the 2 best papers, best application papers which we have listed it, and their reviews, their presentations were well counted while selecting these papers. So So these are the summaries of our conference. I think I will let it over to our convener to dive in more details. So with that, I'll thank special thanks to our CIT and all the members and students participants, along with all of the other who is the reviewers as well as our advisors, international advisors and national advisors. So with that, thank you all. Yes, so I'll stop here. Oh, over to you.
Thank you very much, Sridhar sir, for your insightful and encouraging words. We truly appreciate your valuable guidance and your constant support to the ICTCON 2025 team. Let's give sir a huge round of applause. We are now honored to have with us the convener of ICTCON 2025, Dr. Pranab Kumar Singh sir. I respectfully invite sir to deliver the valedictory speech with us. Let's invite sir with a huge round of applause.
Very good evening, our respected guest of the evening of this concluding session, Dr. Sangrang Brahma, Honorary Secretary of Assam Football Association, our speakers and authors who are connected online and offline, our session chairs, our respected faculty members, and dear students. So, as a convener, I would like to extend my heartfelt gratitude to the people involved in this conference. So, this is something like a conference. Why a conference is important is already highlighted by Apu sir, and we all know the value that it carries. So, being a technical institute in this region, it is our prime duty to have such event in this institute as a faculty, as a student team, and we tried our best to organize this. There are people involved in it. It's okay, lot many people. There are people who are not present here, right? More than 300, 400 people who reviewed the papers. So I would like to start thanking those people. First, I would start with the authors, because of them only all these are possible. So authors who contributed to this conference. So 136 those authors papers where multiple authors were affiliated, and all those institutions who believed in us, who communicated their paper. I would like to extend my sincere gratitude to all of them. Second, I would like to thank the reviewer, people who reviewed the papers, more than 400 people. Okay, we only see this conference as a 2 days event, but as sir said, it is a lot more than that. It is 3, 4 months, 5 months of hardship, collecting the paper over dashboard, assigning the reviewers, getting it reviewed, then sending the comments, then getting back the camera ready paper, okay, making it in proper template. There are a lot many communication that takes place. So the reviewers have done tremendous job. So I must thank them. Okay, they are not here. So all those people who were part of the technical program committee and reviewing committee and all the reviewers, more than 300, 400 people, those who reviewed the papers, I extend my heartfelt gratitude to them. Then goes to the chairs, because they thought of organizing this, because this is something which is very much needed, courage. Okay, we lot many people are sitting here, but only few people take the courage of organizing such a big event. Okay, so the courage, the confidence that they had, I must thank both the chairs sitting here, Dr. Pankaj Pratap Singh from CIT and Dr. Sitala Prasad from IIT Goa. Let's have a big round of applause for both of them. See, like when you are going to do it, there are many formalities that has to be done here. You have to apply through a proper channel. You have to take a permission from authority. Okay, if they permit, then only you can do it. So I must thank IIT Goa, their administration, for accepting our proposal to collaborate with us for this event. And Sitla Prasad sir has done a tremendous job here. His Dean R&D, he attended the session. He delivered the speech. And their administration in IIT Goa, they approved our collaboration, and to this institute, without any this thing hesitation, they collaborated with us. And uh, there was a 3 or 4 people's group created. I know that 3 people or 4 people were there, and they used to update everything every day. So last 4 or 5 months, every few minutes you get a message. Either Sitla sir is writing, Pankaj sir is writing, I am writing, somebody else is writing, because these are the people who are behind knocking every doors. All the reviewers, all the people, all the authors. तो इन लोगों ने लगातार काम किया है, लगातार, जो हमें पता नहीं चला। 2 दिन में लग रहा है बस इवेंट कल स्टार्ट हुआ और आज खत्म हो गया। ये 4-5 महीने से लगातार चल रहा है, कॉन्टिन्यूस। इट्स अ कॉन्टिन्यूस एफर्ट एवरी डे। So Sitla sir has put lot of energy behind it. Okay, 2 दिन के पहले सारी एनर्जी, बहुत सारी, and then coming here as our host, as our guest. Let us have a big round of applause for Sitla sir. He is a very simple man, but he has a lot of energy in him. Okay, so this is the same thing which our Dr. Sangram Brahma, he started when he was in CIT in 2017. He thought of doing an event, so he organized a conference, ICTL. We are not the first one to organize a conference in CIT. He is the first person. He also had that kind of courage. That is why I like him most. And not I invite him in all the events, because we need courageous people. We need people who can take risks and who can deliver and who can do such things. Because this is not your doing, this is not only for the CIT. Okay, this is for the region, this is for the people, this is for the student, this is for all the stakeholders of this institute. When you do conference, you are creating a perception about your institute in the entire world. Okay, he organized a conference, international conference of transforming library. Okay, it was done in 2007. So lot many people from Sri Lanka, from other places, from around the different states, people came here in CIT, and it was a very good conference. And that is what we need to send a very good image of CIT outside. And these are the events which can help us. Unless we improve our image with such a reputed conference, such a reputed workshop, things will not change. Okay, so all together, as a faculty, as a staff, as a department, everybody should get engaged in such an activity. We should get engaged ourselves. We learn a lot. We meet with people, we learn with people, we connect with people, we spread about knowledge about CIT to other places as well. So this is what these people also have done, the chairs who are sitting here. And then, as Sir said, since in CIT we have a very limited budgets, so we thought of not taking help from CIT. Sir was hesitant how we will do it. I told him, don't worry, we will do it. Write an application that we don't want money, just allow us to do the conference. And then when you go for a good thing, your intentions are right, your efforts are honest, then nobody can stop you. So we have not asked money to the people, I'm telling you. We went for the invitation. When we went for the invitation, they themselves offered, sir, I am ready to provide you food. So yesterday, the food that we had, it was offered by the IOCL. You saw, right? Barua sir, he was here. Such an energy he carries. You go and meet with him, and looking at your conference, looking at your effort, looking at your reputation, looking at the proceedings. It's not that you get everything for free. They know that if hard work is there, international collaboration is there, IIT Goa is there, CIT is doing with these number of papers, there is a proceeding going to get published, then only they accept. They know, they will not say anything, but they analyze your efforts, and that is how these people support you. It's not like that tomorrow again if I go and invite him, he will offer me again. No, ऐसा मत try करना, नहीं होगा. You have to build your reputation first. Build your reputation. Don't ask. You should not beg. You should not ask. Build your reputation and let the people come forward to support you. That should be your spirit. I must thank the IOCL, okay, the HP, the BMG Informatics, who all supported this event. They said, sir, you do it, whatever is possible, 10,000, 15,000, and that too, to the proper channel. It's not like they have given a money in our hand. We have to write an application through proper channel, through director, in routing to them, and then money coming to CIT account, then coming to Pankaj sir's account. 30-40,000 sponsorship he has got, and 1,75,000 he got from the registration from the author, and within that amount of money, this event is possible. So it's not an easy job.
And then coming, I must thank all the dignitaries who joined us. They believed in us, they gave their time. See, these days, giving a time to people is the precious thing. You invite people, people say, I will come, they may not come. Somebody who is giving a time to you is the precious thing he is giving to you today. Whoever joined us online, offline, who came to this place, like Dr. Sabyasachi ji, he's here. He came from Aparasa, right? The Barak Valley, to this institute, Barak Valley Engineering College, he belongs to. Like that, there are people who joined us in the inaugural session like that. Dr. Sangram joined us in the Valley. That is the precious thing that they have given us. Those who joined the inaugural ceremony, the different sessions, keynote talks, the valedictory session, we must thank everybody. Let's have a big round of applause to all of them who gave their precious things to us. Then there are advisory committee, they are international as well as international. Okay, you don't get proceedings as simple as that. You need to have a very good team with you. You need to have a good set of professors in your advisory, belonging to a reputed institution of India, belonging to a reputed institution abroad. Then only the proceedings, the people consider the proceedings. So we have Springer proceedings because of we have a very good team of people. Okay, we must thank the advisory committee for accepting our invitation and being part of the advisory committee. If you go to the website and you look at the advisory board, then only you will come to know the people who are with us. Okay, and those who have helped us, you see the general chair, professor, director from ICTCON, people from Australia, people from Spain. So lot many people joined us. Here you can see that we have a very big team, right? We have a publicity, we have international advisory, national advisory from reputed institutions. You have a big TPC here. So all these people, there are a lot of people who are not here. So thanks to all those people, we must thank our organizing committee who are sitting here, the faculty member. Without them, it is not possible. Okay. You need a team, right? You need a support, moral support, mental support, physical support, everything. And that is possible when your own department is standing alongside you and saying that, sir, don't worry, we are here, we will take care of everything. That is the only support needed. And I must thank all our faculty members of the department who have been present and who have extended support in all our activities. Let's have a big round of applause for them. I must thank all the staff members of our department, the housekeeping staff, the administration, the everything. Mangal, you see Mahatma Dai is still sitting here, right? So last 2 days, right? Making your venue ready, cleaning things, bringing things, making it available. So it all their efforts, all their staffs, many of them could not come. The housekeeping, they cleaned everything, made the platform ready for us. So I must thank the administration, CITK administration, all our faculty, not only of the department of the institute, all our staff members of the institute, everyone who supported us. Then we had a catering team. I must thank them for providing the food. I must thank, at last but not the least, our student volunteers, okay, who are sitting here last 2 days. I know that these days it's not that only getting a time from guests is important, getting a time from a student is equally important. They also don't want to spare their time, but they have given their best. Okay, even their exams are over, they are supposed to be at their home, but we put them in lock. We delayed some of their presentation intentionally. We brought them and some of them are over, but still they are here. I don't know like how they experience. They are the one who will be sharing their experience through video or through messages. But we wanted to get you involved. Why so? Because whatever we are doing, it is not us that we will carry. Our career is done. Our career is done. We will not achieve much out of it. It is your career which we wanted to save you. It is your future we wanted to save you. It is your own personality we wanted to save you, so that you also learn, being a part of a conference, how to organize things. Yesterday, I was sitting there at night for the gala dinner, and when I saw that some of you coming to me in a panic situation, that's a chawal khatam, plate gayab, ab kya hoga? This is what I wanted you to learn. ऐसा ही घर में कल शादी करोगे, मेहमान आएंगे, चावल खत्म,
सब्जी खत्म, क्या करोगे? Will you panic that time? What I told you, that don't worry, everything सब होगा, don't worry. प्लेट भी आया 10 मिनट बाद और गरम चावल भी आया. एक्स्ट्रा में expect 150 might come, and you should prepare for that. And that is the situation that we saw, and that is how we handle, and you people handled it. It's not very, it's for you it may be a very small thing, but for your life it is a very big thing. Handling 150 people instead of 100 people, and how you handle it, that is a very big thing. I saw that volunteers taking the chairs, I saw the volunteers mopping the platform here, Christo and all. I saw the people like for the there in the ground, okay, putting chairs. Many of you, all of you have worked hard, going to this session, that session. Sometimes like घर में भी होता है, कितना काम करने के बाद छोटा है ना तो गाली देने का मन करता है, पर ऐसा नहीं है. We love you from our heart and we truly appreciate your efforts. Thank you so much for being the backbone of this program. From last 2 days we received immense love, support, energy from you all, and we truly appreciate it. And I want you all to actively participate whatever event. It's not that only we as a department we organize, you should come, you should join all good events which are taking place in this institute, beyond this institute. Go and participate and live your life. So thank you, dear volunteers, thank you so much. Our publisher Springer, they also, I must thank them. They are our publisher partners. Our proceedings are there, that brings reputation to us. It is getting published. It is Scopus Index and EBLP Index. So we must thank them, and all the coordinators, all the volunteer teams. Thank you, everyone. So that's all from my side. Thank you. Thank you so much.
Thank you, sir, for your knowledgeable words. We would also like to present a token of appreciation to Dr. Pranav Kumar Singh, sir, the convener of ICTCON 2025. So I will request the felicitation team to come forward and felicitate sir on behalf of our CITK. Sir, please do come. Let's give sir a huge round of applause. Sir, your dedication, coordination, and tireless efforts have been instrumental in the smooth and successful organization of this event. We are truly grateful for your guidance.
Few people will come and will distribute. Okay, so invite few people. Basically, Rahul and invite several people.
Now, we are going to distribute the certificates to the volunteers and
Local organizing committee. Sir, लोगों को present करते हैं. Faculty लोगों को बुलाओ. Faculty लोगों को बुलाओ.
now we are going to distribute the certificates to the faculty members. I would invite invite Sangram sir to come forward and distribute the certificates. Now the certificate goes to Ranjan Maiti sir. Let's give a huge round of applause. Next we have Professor Hemanta Kumar Kalita sir.
हो गया ना? और एक को दीजिए.
Next we have Harikanta Roy sir.
धन्यवाद.
Next we have Vikramjit Chaudhary sir. Next we have Prasanna Gurwal sir. The next certificate goes to Anup Kumar Barman sir. The next certificate goes to Mathai sir.
इसका invitation नहीं मिला मुझे अभी भी seriously अभी मैं बुला के दे अभी मैं मैं बोल रहा हूँ invitation done last
ट्वेंटी बच्चे हैं किसी वॉलंटियर्स को बुला लो एक वॉलंटियर को बुला लो नहीं एक वॉलंटियर से चल है तो ग्रुप को देन विल डिस्ट्रीब्यूट
Now,
वॉलंटियर्स है कि नहीं अब इसे राहुल कोई है भार्गव भार्गव ज्योति दास
now the volunteer certificate distribution is going to be made first by Bhargav Jyoti Das. Let's give a huge round of applause. Molly Dole, Vanshika Verma.
is the backbone like here yes. The website for every time I talk I'm very proud moment for all of and Howley how was it ये तो उसका ग्रुप फोटो ये कहाँ से
We request all dignitaries, station chairs, and participants to kindly come forward for a group photograph. With this, we officially bring the legendary session of ICTCON 2025 to a close. Thank you all for your presence and participation. We wish you a pleasant evening and a safe journey ahead. The volunteer certificate will be distributed later on after the photo session.
come here come Thank you.
Bye bye. Bye bye. Bye bye. See you in Thank you. सर्टिफिकेट है आपका सर्टिफिकेट
सर मैं बोलेंगे उसका वंशिका वर्मा राहुल वर्धन
वंशिका वर्मा
राहुल वर्धन अभिषेक काश्यप
अभिजीत कश्यप
डेजी कोलिटा निशा कुमारी
निशा
रोहन धनवार प्लीज कम फास्ट रोहन धनवार दिव्यांश त्रिपाठी
दिव्यांश
दिव्यज्योति रॉय चौधरी जीवन सिन्हा महियाबुल सरनजीत मॉडल दीपज्योति दत्ता
दीपज्योति
महबूबुल हो
महबूबल
कुरुंगा ब्रॉम
सुलंगा
समुद्र दत्ता इशाले काश्यप
your name
क्रिस्टोस ऑलवेरी
सुलंगा ओके Cristo
रूपज्योति गौसुमदारी
रूपज्योति
भास्कर डलमारी
भास्कर
मेघालय दास ज्योतिष्मान गौतम सूर्यकांत दैमन बिजू भूषण बर्मन मनभाई नाडकरी जलेंद्र जोगी
जरीन योगी
जुनक मुलिक ठाकुरिया
जोगी वो आप कराओगे
विक्सन हैजरी परिणीता राय
सीधा नहीं जुड़ा ठीक है कोई इशू
दीक्षा बश्यर
दीक्षा ओह अच्छा
कीर्तिधरी शर्मा
So,
नायमा नौशीन लस्कर गार्गी बश्यर
नईमा
जानवी रॉय अंकिता देवली
अंकिता
नवली कुमार दास प्रत्यांशा काश्यप
प्रत्यांशा
जामुना ब्रह्मो पाटिल
जब नहीं है बता देंगे
डैमानो बोरो
ब्लैंक्स
सुरजीत तालुकदार
ब्लैंक्स भी दे देना किसी का नहीं है नाम किसका है
तुषार साहा
तुषार
ऋतिराज दास फ्लोरिना हाजवारी मोमी बेगम रश्मि रेखा वसुमतारी
दे रहे हो
सुशांता बोरगोहाई
आ जाओ प्लीज सब फोटो होना
मोनिशिका दे
मेहनत किया थैंक यू किसका है ये
रश्मि रेखा है ना?
Mihit Borua. Priyanka JD.
प्रियंका कोई फोटो नहीं क्लिक कर रहा है ना?
नहीं सर.
चलो ठीक. और रोहित
Rohit Sinha.
रोहित
Mihinga Boro. Sariful Islam. Sajid Hussain. सर बाकी
और कोई है? किसी का नाम रह गया तो आ जाओ. जिसका नहीं मिला है प्लीज टेल मी. জনগণৰ মূল্যজন নে মূল্য যাম মোৰ নিজৰ লৈ যামি ন মই নিজৰ দাম তানে মই লৈ লওঁ কিয় আৰে লৈ লওঁ একেলগে 맞아 뭐라 이게 무슨 뭐라 이게 이것도 모르겠어 이렇게는 ट्रेन के ऊपर आई और वहाँ पे जो सर्टिफिकेट्स उसमें भी देख लो ठीक है ना Sir, I think she is yes. MT.
सर
So, खाली किधर होता है MT हो जाए. उसमें है नहीं. Wait, who touched it, man?
टीचर्स वाला सर
Oh, check what we said. तर यहाँ पर आगे नहीं गए तो यहाँ पर आगे नहीं गए नाम लिख रहे हैं होल्डिस होल्डिस के पास नहीं गए नाम लिख रहे हैं तो ना तो ऐसे नहीं दे नो प्रॉब्लम I know Anyone else in the check? Okay, your name, you got it? You got it? Got it?